He did say that. Oh. Keep bugging, bro.
Hi, good morning. Good morning, Hujat. Salam, super khair.
Hello, Judith, you hear me?
Yes, nice to hear you. Nice to see you.
Nice to see you too. Thank you. Okay, hello everybody. Good morning from Copenhagen. Welcome to day 4. Thank you very much for being with us with the presentation that we will have today. So let me introduce the first speaker of the first session of today, who is Dr. Fiona Pishan and Professor Juan Jose Ibanez. They will be talking about farmer lifestyle in the Eastern Fertile Crescent, new data through functional analysis of harvesting tools from Tepe Sangichakmak, Iran. The talk is over to you. If you hear me.
Yes, thank you. Good morning, everybody. I will share my screen. You can see it?
Yes.
Yeah, okay. Thank you. Okay, it's okay?
Yeah.
Okay.
Thank you.
Thank you to the organizer of the conference for giving us the opportunity to present the preliminary results of the functional analysis of the harvesting tools from the site of Tepe Sangichakmak. Useware analysis of harvesting tools is a useful method to enlighten the characteristic of cereal agriculture at the origins of the Neolithic. This method is based on the macroscopic and microscopic observation of the tools with systematic recording of stigmata of use such as scars, rounding, striation, micropolish, fractures, and residues. Sickle blades are identified in the lithic assemblages as displaying a macroscopic gloss created by the contact of the cutting edge with siliceous plants. The interpretation of the useware patterns is made by comparison with an experimental database created for the studied collection and their specific problems. Useware analysis carried out by several researchers during the last 40 years in Southwest Asia have provided relevant information on the characteristics of sickles and the conditions of cereals when harvested. Sickle gloss evolves from the Natufian to the Pottery Neolithic, from domed and less striated to more flat and abraded. This has been related with the progressive harvesting of cereals in a reaper state and the cutting of plants near the ground, most probably to use the straw. Moreover, the tendency to observe more developed sickle gloss has been related to longer uses of sickles. During the last years, the methodological developments made in the functional analysis of sickle gloss have considerably contributed to our understanding of agricultural technology and early agriculture in Southwest Asia. Confocal microscopy and texture analysis of sickle gloss are used as quantitative method, allowing a precise identification of the characteristic of plants when harvested. Data from experimental practice suggest that wild cereals growing in natural stands are cut in a green state. Cultivated wild cereals in a semi-ripe state and domestic cereals in a ripe state for maximize the yield. Considering this, the recognition of the 3 states of maturity of cereals, green, semi-ripe, and ripe in the archaeological sickles provide evidence for cereal characterization as part of an integrative study included botanical data. Using this new methodology for the analysis of more than 200 sickle elements from 12 archaeological sites from southern Levant and the Middle Euphrates, we have recently evaluated the evolution of harvesting during the time when plant cultivation activity started and domesticated crops appeared in the Levant. The state of maturity of cereals when harvesting shifts over time from green to semi-ripe and finally to ripe. The shift in plant harvesting strategies was neither chronologically linear nor geographically homogeneous. We apply user analysis to the sickle blades found in the Neolithic site of Tape-Senge-Charkmak in northeastern Iran. Our aim is to characterize the harvesting technology of the farming communities that occupy the site during the 8th to the 6th millennia BC. The site is one of the only known Neolithic sites with reliable evidence of macrobotanical and faunal remains, and recent investigation made on the site suggests an exogenous origin of cereal domestication imported from the West. The analysis of the harvesting tools could contribute to understand the diffusion of the food production and farming way of life in this region. The site was discovered and first excavated in the 17th by a Japanese team directed by Seishi Masuda, and recent excavations have been conducted by Kourosh Roustaei from the Iranian Center for Archaeological Research. This presentation will be focusing on the harvesting lithic tools discovered during the excavation seasons conducted by the Japanese team. The study was made in Japan at the Research Center for West Asian Civilization in the University of Tsukuba in the framework of a postdoc project funded by the Japan Society for the Promotion of Science. It was conducted under the supervision of the professor Akira Tsuneki that allowed us to study the material and to present the first result today. According to the results of radiocarbon dating, the West Tape began at the end of 8th millennium BC, and the occupation continued into the early 7th millennium BC. After a chronological gap of several hundred years, the settlement of the East Mound was established at the late 7th millennium and ended in the late 6th millennium BC. According to the Japanese fieldwork, the western sequence is divided into 5 occupation layers, the uppermost level having no architecture due to erosion. The preparatory Neolithic phase spans level 2 to 5, and the analysis of botanical remains coming from the recent excavation and made by Margareta Tengberg showed that the subsistence economy included cereal cultivation with the presence of domesticated wheat and barley from the earliest levels of the West Mound. Diverse wild plants, including grasses, sages, as well as wild pulses, are also present. Most of the lithic industry is made on local chert, light brown and gray flint. According to the technology study made by Goto Takeshi, blades and bladelets are extracted by pressure from single platform core. The tools comprise sickle blades, truncated and retouched bladelets and blades, drills, geometrics, and end scrapers. The Japanese excavation at the East Tape revealed 6 pottery Neolithic layers. The analysis of the archaeobotanical remains coming from the recent excavation that made by Margareta Tengberg showed that wheat is still dominant among the identified taxa, but einkorn is no longer represented, suggesting a change in the crop assemblage through time. Barley is poorly represented, and the proportion of wild plants decreased considerably. No change on the chipstone assemblages were recorded in respect to the West Mound. As well, the main tools are sickle elements, geometrics, drills, and end scraper. The sample studied at the macro and micro scale consists of 106 glossy blades from the West Mound and 99 glossy blades for the East Mound. According to experimental data, the usual traces are characteristic of harvesting soft siliceous plants, such as cereals. The blades are showing an extended and bifacial gloss, wide of several millimeters. Longitudinal linear striation confirm the cutting movement, The micropolish is covering the topography of the flint, and the limits of the use wear are well marked, suggesting the use of the blade with a haft. The blades are regular, sometimes truncated or broken for hafting, and when the cutting edge is retouched, it's for retooling. On the boss mounts, the morphology and textural characteristic of the microscopic use wear suggest that harvesting was carried out close to the ground. There are several striation and comet-shaped depression that are probably due to the contact with the mineral particles of the ground. Such a mode of harvesting allows us to use the entire plants for the domestic life. The grain are consumed for food purposes, and the straw can be used for architecture, basketry, or roofing. For having a better discrimination among types of cereal harvesting gloss on boss tapé, we use texture analysis with confocal microscopy and quantitative measurements. First, confocal microscopy and statistical treatment were used to discriminate micropolish on experimental tools. These tools were used for harvesting wild cereals in a green state, cultivated wild cereals in a semi-green state, and domestic cereal in a ripe state. Data collected from each sample was integrated into statistical software, which developed quadratic discriminant functions, building a predictive model to distinguish the three groups of tools. The main parameter explaining the discriminant capacity of the predictive model is the degree of humidity present on the repeat stems. We used the predictive model to classify 65 glossy tools from Tepe-Sangé-Charkmak. The cluster of archaeological sickles is classified close to the cluster of harvesting ripe and domestic cereals, which is consistent with the botanical data. We will deepen this analysis in the future, including experimental tools that have cutting graces. According to the gloss distribution, the longitudinal orientation of striation and the morphology of complete preserved sickle blades, we can suppose that straight and maybe slightly curved hafts were used for harvesting. Some bone hafts decorated with carving of animals were discovered in East Tapé and interpreted as sickle haft. Their morphology matched with the distribution of the usewear traces on the sickle blade. The blades were inserted in parallel to the haft using adhesive, maybe bitumen. Black and brown residue of glue are sometimes preserved on the blade. Some complete sickle blades have short dimension, which seems to indicate that several elements were hafted together for making the whole cutting edge. The sickle blades were rarely reused for other activities than harvesting cereals. For the West Mound, it's 12% of the sickle blades that are reused, for example, for scraping hide or scraping weedy plants. For the East Mound, it's only 5% of the sickle that are reused. The preliminary results of the sickle blade analysis from Tepe-Sangé-Charkmak have shown that no major changes on the harvesting tools can be highlighted along the occupation of the two mounds. The technology used to produce the blade, the way of hafting them, the intensity of retooling, the cutting edges seems to be the same. However, to confirm this preliminary tendency, a more detailed techno-functional analysis will be made in the future. Qualitative and quantitative usewear analysis have not shown evolution of appearance and texture of the sickle gloss too. However, the results obtained with confocal analysis do not exactly fit with the centroid of our experiments of harvesting ripe cereals. We are now carrying out new experiments to understand the variability of harvesting gloss in tools used for reaping different types of domestic cereals. The sickle blades from Tepe-Sangé-Charkmak are similar to the sickle blades identified on the Zagros for the late PPNB and the Pottery Neolithic. It is difficult at present to have an image of the evolution of the hafting system and the harvesting traces in parallel to the adoption and consolidation of farming way of life in this area. The hafting mode is different in the northeastern Iran than in the Mesopotamia and in the Levant for the same period. Investigating in the future the function of harvesting tools in the Eastern Fertile Crescent and beyond through high precision user analysis will certainly contribute to the current debate about the adoption and diffusion of the cultural package of farming between the Zagros and Western Central Asia. Thank you very much for your attention.
Okay, thank you very much for presenting your nice work. So could you please just, we will, if you unshare your presentation?
Yeah.
Okay, thank you. Just we want to have the participants. Okay, thank you very much. So we will have time for question, comments, and okay, Roger, good morning. If you hear me, please.
Sobakher, Hojat, good morning. Thank you very much, Fiona, for that talk. Really wonderful study. And it's interesting to see that, you know, you're not really, I mean, there's a lot of continuity as far as you can tell from the West Mound to the East Mound through time. And I'm wondering if that's connected to the fact that, you know, the practice of growing cereal crops is actually brought in from outside rather than developed autochthonously, as it were. So I'd be interested in your view on that. But also, you know, I think it would be really interesting to apply these wonderful techniques also to a site, you know, like Sheikhiabad in the central Zagros, where we have these deep sequences through time, and where, you know, one might hope to look for changes in what they're actually doing with their sickle blades, because we have sickle blades at Sheikhiabad from the very earliest levels, you know, back to 10th millennium Cal BC, all the way through to, possibly with some gaps, but all the way through to mid 8th millennium Cal BC. So, and we know they're not extensively or intensively engaging with cereal crops. So, you know, it'd be really interesting to broaden out this study and look, you know, in greater time depth across a greater region, where, including a core region where indeed cereals are, you know, intensively cultivated and then domesticated. I'm not saying that's necessarily the case at Sheikhiabad, but just as an example. So yeah, thank you. Really, really wonderful work. Thank you.
Thank you very much for your comments. If I don't know if I understand everything, and but I think that it will be really, really nice to apply this technique for other sites, as you propose. Yeah. I don't know if Juan will have something to say more.
Yes, thank you. Good morning. Thank you for your comments. This would be nice, because here we don't find many differences between the two mounts, but it would be very important to try and to test this methodology with long-term chronologies in sites where there is a longer evolution, and especially because the aspects about the origins of agriculture in this area are different from the Levant, as, for example, Amaya showed us yesterday. So we will certainly have to make new experiments for that, cutting grasses, different type of grasses. So we need both analyzing new sites with longer sequences, and also carrying out new experiments for adapting our method to this area.
Thank you.
Thank you. Wendy, if you hear me, good morning. And here you are.
Good morning. Thank you very much for this wonderful talk. And I'm sorry, I think I left my mic on early on, so I hope that didn't interrupt anything. But it is wonderful work. And in fact, we use confocal microscopy in the study of thin sections as well to get 3D analysis of materials. But one of my question, I'm sorry if I missed it too, is in other, Marta Portillo is working on phytoliths in actually the hafting materials, because in experimental studies, the phytoliths can get caught up in the bitumen, for example. So I wondered if you'd look for traces of phytoliths in any of the hafting residues, because they can get stuck in these sticky residues, not actually the sickle gloss itself, but the residues. Or if you know of any papers on that. I think Marta Portillo has been working on that with someone, a postdoc in her lab.
Fiona, do you answer, or est-ce que tu réponds sur les phytolithes dans les mastiques de fossiles?
J'ai pas très bien. I didn't really understand the question. I'm sorry.
Okay. Yeah. No. Yeah.
If there is some phytoliths on the mastic, and if we study, I don't know. On this side, I don't know, because this is only few residue and of mastic. I think maybe bitumen, but I didn't make the more observation of this residue. Maybe it could be possible to study that, but on this material, it's a little complicated because it's not really well preserved, I think. Yeah.
I would add that we're trying to analyze residues with spectroscopic microscopy, but we didn't think about analyzing phytoliths in these residues. This could be a good idea, so maybe we can be in touch with that. I know that for other contexts, there are interesting analysis, for example, for the Marmota site in Italy, the Neolithic site where sickles are very well preserved. They are doing pollen analysis in the mastic, and they are finding very interesting things related to the plants that were harvested with the sickles. But in that case, for example, in La Marmota, mastic is very well preserved. In our case, there are only small stains. So I don't know, we would find anything in there, but this could be an interesting possibility.
In fact, I think it is that very case study that you mentioned where they're also looking at phytoliths. So there was a paper at the Integrated Microscopy Approaches in Archaeobotany at Reading with it. And unfortunately, I can't quite remember the name of the paper, but it's still quite early. But thank you so much, and very best wishes in your work.
Thank you.
Thank you very much.
Okay, thank you. Douglas, you.
Hi, yeah, good morning. Just to add to what Wendy said, starches might be quite interesting as well in that regard, to add to it. Certainly we got reasonable starch preservation in some of our ground stone at Bonjuklu, for example. So just a thought.
Yes, of course, yeah. So multi-proxy approach is the best one.
Okay, thank you. Just I wanted at the end two little points. The first one is, as pointed out by Roger, concerning the introduction of agriculture to this site, Sangachakmak, I mean, the West Mound. It seems that the recent investigation done by Professor Fazl in northern Iran can be interesting and considered in the future in this regard. And the other thing that I wanted to say that using the term PPNB, the chronological term in the Zagros that you mentioned at the end of your presentation, it is not maybe based on the archaeological evidence, is a good term that can be applied to the region. Thank you very much. Okay, let's move on to the second presentation, which is by Dr. Charlotte Dufay, who will be talking about food and farming, new archaeobotanical evidence from the Zagros region. Okay.
Hi, can you see my slides?
Yes,
Excellent.
just it's not, okay.
Are they full screen?
Yeah, great.
Excellent. Great.
Yeah.
Well, good morning, everyone. Today, I'm going to present some of our archaeobotanical and environmental research conducted as part of the European Research Council-funded Mentica project at the University of Reading. I'm going to briefly introduce my role within the project, as well as discussing the major research aims specifically regarding Neolithic food procurement and the changing environment. Over the course of this conference, you have heard from most of the other members of the Mentica team, so I won't go into a lot of detail regarding site background, but rather this paper will follow on from their presentations. I will then present ongoing research and results from 3 case studies: Neolithic Beston Sur in Simshara in Iraqi Kurdistan, and Middle Chalcolithic Nad Ali Beg in Western Iran. As you've already heard, the Mentica project has been focused on how Epipaleolithic human communities in the eastern Zagros region negotiated the change from millennia-old traditions of mobile hunting and gathering to the life ways of settled farming and herding over the course of the Neolithic period. Within this wider project, I have been focused primarily on work package 2, changing environments and community foodways, and in particular on the archaeobotanical analysis of charred macro remains from our case study sites. The primary aims of this research package are to explore variation in food procurement and dietary practices during the shifting climatic and environmental conditions of the Epipaleolithic and early Neolithic at Beston Sur and Zazi Cave, and how changes to these systems may have led to the domestication of certain plant and animal species, as well as transformations in Neolithic society and culture. To investigate the use of these domesticates alongside the continued exploitation of wild foods, including resources such as fruit and nuts, leafy vegetables, tubers, wild game, fish and mollusks to create a more broad spectrum subsistence economy, and to situate the foodways of the Eastern Fertile Crescent communities within both a regional context with sites like Jarmo and Shimshara, and with contemporary developments in agriculture in the Western Fertile Crescent. To do this, we have implemented an intensive sampling program as a key part of our excavation methodology, which aims to capture both environmental macro remains like charred seeds and charcoal, alongside micro remains like phytoliths and dung spherolites. Now I will turn to present some of our recent results, as well as discuss ongoing and future research plans. So you've all heard quite a lot about Beston Sur over the course of this conference, but just as a quick reminder, the Neolithic tau site of Beston Sur is located on the Sharazor Plain in the western foothills of the central Zagros Mountains, 33 kilometers southeast of the modern city of Sulaymaniyah. The climate in this region today is characterized as semi-arid Mediterranean and is highly seasonal, with cold, wet winters and hot, dry summers. And due to this high annual rainfall combined with slightly alkaline soils, this area has been known recently for its agricultural productivity. Paleoclimate evidence from Lake Zareba in Iran has suggested that during the Neolithic, the climate in this region was generally favorable for rain-fed agriculture, although it may have been slightly drier when compared to other sites in the Fertile Crescent during this period. And the site itself is situated in an area of fertile arable soils, fresh water sources, and hilly terrain suitable for hunting and foraging. As you've already heard from my colleagues, a new program of excavation began in 2019 and has been focused particularly around Space 50, an internal area found to contain a large number of human burials, particularly of infants, but has also aimed to identify external areas where activities such as cooking, plant processing, and disposal of waste may have been taking place. A key component of our excavation methodology has been the implementation of an intensive sampling strategy, including the flotation of soil samples from every unit excavated. During the 2019 field season, the team floated 217 samples for a total of 4,592 litres of soil. Of these samples, 186 were from Neolithic contexts, and a further 31 from Iron Age levels on the site. All of these samples have been fully processed at the University of Reading and have been found to contain a mixture of domesticated crop material, such as whole barley, the gloom wheat and lentil, alongside wild food resources such as almond and pistachio, and the remains of arable weed species like small-seeded legumes, wild grasses, and a wild mustard type. However, the density of these remains across the site was quite low, even when taking into account the large amount of soil processed, and the overall preservation of these seeds is fairly poor, and this is a point I will come back to in just a moment. Preliminary spatial analysis of plant remains does indicate some variation by context across the site, both in terms of the amount of material covered and the range of taxa identified. In particular, we can see some differentiation between internal versus external spaces across the site, and this fits quite nicely with the points that Ingrid made in her paper on the analysis of the heavy residue. Internal areas in general appear cleaner and contain more cereal grains and fruit nut fragments, particularly oven F17, which is located at the top of the plan to the north of space 50. By contrast, external spaces appear to contain greater quantities of cereal chaff, and this is most notable in samples taken from an area at the bottom of the plan that may potentially have been used for domestic refuse disposal. Other apparent trends include a greater proportion of pulse species identified from external areas and the presence of weed wild taxa remains throughout the trench. We hope that with future excavations at Beston Soar planned as part of the Mentico project, we will be able to add more archibotanical data to this emerging picture of spatial patterning at the site, as well as the identification of specific cooking and processing areas around the site. However, the biggest challenge that we face with regard to archibotanical interpretation is the fact that the actual density of charred macro remains recovered from Beston Soar is quite low, and generally the poor condition of the seeds has made identifying remains to the species level quite difficult. There are a number of reasons why archibotanical macro remain preservation is fairly low at Beston Soar. For example, bioturbation by modern plant roots, burrowing snails and mammals can be seen across the site, and the soils themselves include a high proportion of expandable clays that are susceptible to shrink swell during the alternating wet and dry conditions in this region. These conditions have made the use of traditional archibotanical techniques a bit of a challenge, to put it mildly, but has presented us with a unique opportunity to create a more integrated approach to plant identification and analysis, both on the ground level in the field and back in the laboratory. Microremains such as phytoliths and calcitic ashes are regularly identified in micromorphology thin section, and both ongoing and future work, some of which was presented by Kate on Tuesday, will include the analysis of strategic phytolith samples, the use of scanning electron microscopy, and the integration of results from soil thin sections. We hope that this combination of approaches will further our understanding of the taphonomy of Beston Soar, as well as expanding our datasets to include information on plant parts not regularly recovered through flotation to fill in the gaps regarding plant use and deposition during the Neolithic. My second site, which was introduced by Roger on Monday, is Neolithic Shimshara, located on the Rania Plain on the right bank of the Lesser Zab River. The site itself is only accessible periodically in late summer after it was flooded by the Ducken Dam in 1959, and this has severely limited the extent to which the site can be investigated. But in 2013, 2 trenches were excavated adjacent to the main profile of the site to investigate the Neolithic occupation levels. During this excavation, charred plant remains were visible in the section, and a total of 30 soil samples were taken for flotation. In total, these samples have yielded 21 different taxa types and plant types with a low average density of 0.89 items per litre. Crop taxa were the most ubiquitous category of the assemblage, with pulses and cereals found in nearly every sample. Pulses were primarily identified as lentil, with less frequent examples of vicia and bitter vetch. But unfortunately, as was the case at Beston Soar, all cereal material was too poorly preserved to identify beyond indeterminate wheat and cereal categories. Alongside the crop remains, wild foods were also represented by pistachio nutshells and fig seeds, together with other weedy taxa such as small grasses, poppy, and sedges. When looked at spatially, the 2 excavated trenches look quite distinct from each other. Trench 1 contains a high percentage of crop remains, particularly pulses and cereal grains, whilst remains from Trench 2 and the west-east section contain much higher quantities of weed wild taxa. This corresponds with the interpretation that deposits in Trench 1 included midden-like layers where the remains of food preparation and cooking would have been discarded. By contrast, the lowest levels of Trench 2 were thought to comprise a series of small pebble and stone surfaces mixed with occupation residues. This interpretation, coupled with the much higher proportions of weed wild taxa, and in particular small wild grasses in these levels, may suggest that these samples represent the remains of grassy russes spread on floors or from temper for construction materials. My third site is a Middle Chalcolithic site, so slightly beyond the remit of early farming communities, but still important, I think, because of the lack of excavated Chalcolithic sites in this region, but also because of the continuation and evolution of food procurement practices that we have identified in the Neolithic that continue to be used in this later period. Nad Ali Beg is located in Kermanshah province, western Iran, approximately 125 kilometers from the Iraq border in the north-central Zagros area. This region is fairly mountainous and today has a typically Mediterranean climate with moderate summers and cold winters, although average annual temperatures are typically lower than those seen at Bestansur and Shimshara. Additionally, annual rainfall is lower, around 480 millimeters a year, but is still enough to support a rain-fed farming economy. In terms of paleoclimates, the Chalcolithic period has been considered a climatic optimum, with increased levels of rainfall across the Middle East, supporting an expansion in terms of settled agriculture and the intensive use of domesticated plants and livestock. Towards the end of the 4th millennium BC, conditions became increasingly arid throughout the region, but certainly during the occupation of Nad Ali Beg, it is likely that the climate was favorable for rain-fed agriculture. The site itself is located 18 kilometers from Sonkor town, close to the Jamashan River. The tell is about 180 meters in length and 150 meters wide, with an average height of 6 meters. However, deep agricultural ploughing in the area has effectively destroyed much of the upper layers of the tell, leaving only a small untouched ridge on top of the hill. The site was excavated by an Iranian team during 2 seasons in 2016 and 2017. In total, 5 trenches were excavated with the aims of exploring the sequence of settlement at the site, as well as investigating regional Chalcolithic interactions, evidence of cultural exchange, and the diet and nutrition of its inhabitants. Intact architectural remains were obtained exclusively from Trench 3, located on the south side of the hill, where damage from ploughing was not so prevalent. Features identified included walls, ovens, and clay platforms, as well as finds of stamp seals, tokens, and Dalmaware pottery dated to 2 individual phases of settlement during the Middle Chalcolithic. As part of the excavation methodology, 46 flotation samples were taken and sent on to the University of Reading in October 2020 for archaeobotanical analysis. So this is an overview of the assemblage results, and the assemblage primarily contains cereal grain, chaff, and weed remains, with only very small proportions of pulses and nutshell. But what was most interesting was the complete dominance of cereal chaff, which was present in every sample and dominates nearly every sample. Some of this material was very nicely preserved and has allowed identification to the species or taxa level. Cereal grain was primarily represented by Emma, with very little Holdby or einkorn wheat. Cereal chaff was represented by intact Emma spikelets, including a number of terminal spikelets from the very top of the ear. Of the fruit and nut remains, so far only almond has been identified, and of the arable weed remains, species include Gallium, Silene, and wild grasses, including Lolium and Bromus. Correspondence analysis has been used as a means of exploring compositional patterning amongst the assemblage. This is an ordnance technique that groups samples with similar species compositions together, whilst those with diverse compositions are located further apart. When coded by Trench, Trench 1 and Trench TTB appear to have fairly similar species compositions. Trench 3, by contrast, appears quite variable, containing some samples dominated by chaff or weed seeds, and those located near the top of the plot with higher proportions of cereal grain. This high level of variability becomes clearer when analysing the samples from Trench 3 separately. Again, the majority of samples appear dominated by cereal chaff, but there are a number of samples located at the top of the plot with more mixed compositions, and in particular samples containing more cereal grain. The figure on the left shows samples from Trench 3 coded by a chronological phase, but there appears to be no apparent temporal patterning visible within this plot. Instead, it would appear that the compositional variability of samples corresponds most closely with spatial location within the trench, and can perhaps provide us with evidence for the location of specific plant-based activities across the settlement. For instance, the area in front of the platform and the oven have much higher proportions of chaff in comparison to other areas of the trench. And this pattern becomes even clearer when we look at the actual number of plant remains recovered from each area of the structure. The dark red colour here corresponds to a sample containing over 500 individual remains. And again, the area in front of the platform and the oven, which were dominated by cereal chaff, are also the areas with the highest quantities of plant remains recovered. We can speculate that this area was used for the final processing of wheat grains, an activity that would have needed to be done by hand before food preparation, and that the oven to the side was used for the disposal of chaff waste. This is in direct contrast with other areas of the structure where the quantity of plant remains was much lower, indicating that these areas may not have been used for plant-based activities or were regularly cleaned by inhabitants. This mixture of preservation levels, combined with varying sample compositions, particularly in Trench 3, would indicate that these remains are not indicative of in situ burning events, with perhaps the exception of the oven on the far left, but rather the disposal of cooking remains alongside crop processing byproducts within specific areas of the site itself. Overall, archaeological investigations undertaken by the Mentiker project are providing a wealth of new data for time periods and regions of the Fertile Crescent that have previously been under-researched, either due to locational access, a lack of identified sites, or a research bias towards other regions. Plant remains from Bestensor and Shimshara are providing us with rare evidence for early Neolithic agriculture in the Zagros region, as well as indicating that foraging for wild plants, fruits and nuts continue to take place in these communities beyond the establishment of small-scale agriculture. Additionally, the ongoing challenges presented by the preservational conditions seen at these sites have led to the creation of a more integrated approach to archaeobotany in the field, which could hopefully be implemented at other sites with low levels of charred plant macrodomain recovery. Work at Nerd Ali Beg has delivered a large quantity of new evidence for Middle Chalcolithic plant use in a region that has previously been understudied archaeobotanically. Additionally, spatial analysis has given some indication of plant-based activities within structures at the site. Similarly, the results from this site do not indicate a dramatic shift in farming practices from the Neolithic to the Chalcolithic period. In particular, the presence of fruit and nut species, alongside the continued use of domesticated cereals and pulses at the site, indicates that broad-spectrum food procurement strategies were still in use at this time. Rather, these results suggest that farming throughout this period in the central Zagros region was characterized by a continuation and gradual refinement of intensive plant cultivation systems that chart their origins from the earlier Neolithic period, rather than as a prelude to the expansion of agricultural production, and in particular cereal cultivation, that supported the growth of late Chalcolithic and early Bronze Age sites like Tel Brak to the northwest and the early urban centers of southern Mesopotamia. Finally, I would just like to thank everyone involved with the Mentiker project for their support, and particularly our colleagues in Kurdistan and Iran who have facilitated our research and provided access to material. Thank you.
Okay, thank you very much for your presentation. Very nice. So we still have your full screen.
Yeah.
Okay, thank you. We have a little bit of time for one or two questions if there is something. Okay, it seems that it was very, very clear. Thank you very much.
Thank you.
Okay, let's move on to the third presentation, which will be by Dr. Mohsen Zaidi and Professor Nicholas Cunard. They will be talking about the earliest Neolithic traditions of the Iranian Zagros region, evidence from Chagha-Golan in the western foothills of the Zagros Mountains of Iran. If you hear me, Dr. Zaidi, it's over to you to talk.
Yes, thank you. Can I share my screen?
Yes, please.
Can you see it?
Yeah, great.
Okay. Hello, everyone. Good morning. Before I begin, I would like to thank the conference committee and all organizers who made this event possible and the opportunity for all of us to present our work. For this talk, I'm going to present the ongoing lithic analysis from the basal layer at Chagha-Golan, which represent one of the earliest Neolithic sites in the Zagros region of Iran. But before I begin, I would like also to dedicate this presentation to late Khalilian, who introduced Chagha-Golan in Iranian archaeology, and late Dr. Malik Shamirzadeh, who visited the site and named it after the modern village of Golan near the site. The outline for the talk, first an introduction and research background to the topic and site, and then the research objectives for the current study, material and methods, and used for this current work, and at the end the result and concluding remarks. Coming to the point, we are all familiar with these publications. Previous studies have shown that two major cultural areas or techno-taxonomical units were present within the Neolithic Fertile Crescent of Southwest Asia, the Western and Eastern wings. The main Neolithic lithic industry in the Eastern wing of the Fertile Crescent is the Muallafatian. After the pioneering work by Braidwood's team at Tel Muallafat in 1954 and further significant fieldworks and contribution mostly by Karol Kozlowski, the term Muallafatian lithic industry introduced into the archaeological literature of the region. And since then, discussions are still going on about the emergence and development of this early Neolithic cultural unit in the Eastern Fertile Crescent. For instance, its origin from the local late Epipaleolithic Sarsian core technology and the nature of Neolithic package during the early Neolithic Muallafatian. Talking about the techno-typological characteristics of Muallafatian lithic industry based on Kozlowski, the Muallafatian lithic industry is characterized by the dominant production of blade and bladeless from single platform cores and using pressure technique mainly. The common production of backed bladelets, simple tool composition with dominant tools made of regular blades and bladelets. And in general, Muallafatian has been divided into three stages: early, late, and post Muallafatian. Here, the early Muallafatian is relevant to this present work. Of course, besides other important questions that our project has regarding the origins and emergence of farming and village life in the Zagros Mountains, the relevant question for the current study are how do the lithic assemblages at the basal layer of Chogagolan are characterized, and how does it contribute to our better understanding of the emergence and development of the Muallafatian lithic industry in the Eastern Fertile Crescent. Beginning with the site location, in this slide, you can see the map of Iran and the location of the major early Neolithic site in the Zagros Mountains. And the location of Chogagolan in the Hilly Flanks of the modern Iranian Zagros is indicated by a red dot near the Iraqi border. And on the left side, you can see the satellite image indicating the location of Chogal on the right bank of Kundan-Cham River. Chogagolan is located 35 kilometers north of the modern city of Mehran, Ilan province in western Iran, and was discovered by accident during the geological survey conducted for the Kundan-Cham River dam site. After its discovery, late Khalilian from the Ilam Department of Antiquity visited the site and introduced it as an early Neolithic settlement. Unfortunately, the site shows considerable damage on its apex since it was located on the former front line of the Iraq-Iran war. Local farmers still plowing the surface for dry farming, and looters pits are visible at several places. Our excavation was also a rescue excavation before further damage to the site. Here on the right side, the satellite image show the exact location of the sites in Amirabad Plain on the right bank of the Kundan-Cham River. On the left side, the map indicating the location of Chogagolan in western foothills of the Zagros Mountains and descending the elevation toward the Mesopotamian lowland. And I have to mention that originally Chogagolan consisted of two independent localities. Chogagolan 1 in the lower picture on the right has been investigated employing a small-scale excavation in 2009 and 10 under the direction of the others. Chogagolan 2, a bit further to the east and right on the riverbank, although almost destroyed by river erosion, is also Aceramic Neolithic date, but has not been systematically studied yet, and it seems to have shallow deposits. It has obsidian on and could be occupied parallel to the last phases of the occupation at Chogagolan 1. Here you can see the topography map of the site and the location of our trenches. The top right is the general view of the tile site. On the left, you can see our trenches during the excavation in 2009 and 10. We conducted small-scale excavation at the sites in two main areas. Area A, 4 by 2 meters, and the deep sounding, about 2 by 2 meters. We defined 11 archaeological horizons at the deep sounding. Chogolan was first occupied at the end of the Younger Trias-Cold episode around 11.7 cal BP. And long-term occupation, abundance of solid architecture led to the formation of a tell site with 8 meters of cultural deposits. Like most of the early Neolithic sites in the region, the settlement is located near the water source here on the right bank of the Konjancham River. This the Chogolan was eventually abandoned after 2 millennia, around 9,600 cal BP. In this slide, you can see the deep sounding during the work. To the left is the coronal stratigraphy and the dating results. Chogolan constitute one of the unique sites of the early holos in the Zagros, which high stratigraphic resolution and rich archaeological remains at the site through a sequence of 2,000 years. I will be talking about the lithic assemblages from the lower part of the archaeological horizon 11. If you look at the bottom of the stratigraphy, the lower part of the ashy deposit, which we call it the archaeological horizon 11. In this simplified chronological table, you can see the K epipaleolithic and early Neolithic sites in the Zagros region, including Chogolan, and how the chronological gaps are gradually going to be filled by different projects. Our excavation at Chogolan revealed very rich lithic assemblages throughout the sequence, but the richest layer was AH11 at the base of the tell. For the current study, I analyzed a small sample of more than 6,000 chips lithic from the basal layer, AH11, that will be presented here. As mentioned earlier in our first talk on Monday, we use a very simple hand bucket system to recover all organic and inorganic remains, including very tiny fragments of cheap latex. As you can see, we did float and wet screen the entire excavated sediments. Just for your record, here you can see a list selection of stone artifacts from AH1 to 10 from Chogolan. The majority of the cores are conical and bullet-shaped cores produced with the pressure flaking technique. The production of regular blanks, blade and bladelets, was very demanding. The majority of the tools are retouched, bagged, and truncated pieces. Sickle elements are also visible at the bottom of the picture, colored with yellow. Yeah. But the raw material, our survey results indicates that people in Chogolan use locally available raw material for stone knapping at the site. Two main geological formation can be determined from where people use as their source of raw material. First, the Pleistocene conglomerates marked with yellow color on the geological map. And the second chert nodule from the limestone formation of the late Paleocene available throughout the folded Zagros marked with the green color. I should mention that there is an identical pattern in the variability of the raw material used throughout the sequence, except H1 and 2 top of the sequence, which produce low numbers of imported obsidian. Okay, for the current study altogether, 21 samples, which means 21 buckets from the excavated volume have been examined so far. The table shows the total number of analyzed lithics from the basal layer, H11. I use different techno-typological attributes and metric analysis for each piece of lithic to gain the data presented for this work. So you see the category of the lithics, starting from cores to base products like microdebitage, altogether 6,085. In some, 54 cores are analyzed, and here you can see the distribution of core types and core technology, and like blade cores, bladelet cores, or mixed cores. And the techniques they use for making the blanks are percussion, pressure, or pressure. So here, in this illustration of the core, if you look at the core types from the basal layer, the true bullet cores are almost missing, but mainly conical, semi-conical, and irregular cores. These cores have negative removals from the combination of pressure and percussion flaking techniques. These are actually from the lower part of AH11. So, but what you can see here is the fully established pressure flake cores in the upper part of AH11. So the question is there any diachronic change in core technology at Chogolan? Here is a selection of tool types from the basal layer: retouched, backed blade to bladelets, and truncation, scaling bladelets, and microliths, and a wide range of variability in color and quality of the raw material can be seen here. In this diagram, you can see the distribution of technological categories. Bladelets are the most dominant blanks for produced blanks, and both formal and informal tools. Blades and flakes were less frequent. If you look at the flake debitage, you realize that the flakes are mostly byproducts of stone napping. To compare formal versus informal tools, more than 67% of the tools have intentional retouching, and about 33% were just utilized without further modification. Altogether, 556 tools. Concerning tool typology, the formal tools are strongly dominated by nibbled, backed, and retouched pieces, mainly produced on bladelets. Between the informal tools, utilized pieces are the most frequent ones and constitute more than 96%. As you can see, the formal tool types are mainly include retouched bladelet with oblique truncation or just truncated pieces, nibbled, perforator, or back pieces with oblique truncations. The distinctive feature of the lithic assemblage at Chogolan is the abundance of blade and bladelet production. By looking at the width ranges of the blades and bladelets at this diagram, a tendency to standardize in blade and bladelet production can be seen. The width ranges for the blades lie between 11 to 13 millimeters, and for the bladelets lie between 5 to 7 millimeters. So in this combined diagram, you can see the width ranges of both blades and bladelets in millimeters. In general, the data matches with the early Muallafatian industry as defined by Kozlovsky. So to conclude, so our analysis indicate that the people used or exploited the locally available raw materials for stone napping at the site. We had no obsidian at the basal layer, but low amounts of imported obsidian just at the end of the sequence in layer 1 and 2, which clearly match with the other data from the other early Neolithic sites in the Central Zagros. We have the evidence of on-site flint napping with large number of cores and traces of waste products of napping activities, as I shown in the pictures. Economizing of raw material reflected by exhausted cores, and frequent use of pressure flaking technique with combination of direct percussion, basically at the beginning of the sequence. And the chipstone assemblages characterized mainly by systematic production of bladelets and tools made on them, general similarities with other early Neolithic sites in the Zagros region, but also with its own variability. That means if they look at different sites in how they excavated in terms of excavated volumes, large versus small scale, or techniques, if they sieved or unsieved this excavated sediments, and the variability between the eastern and western Muallafatian in highlands and lowlands. Presence of microliths throughout the sequence, it's always visible, the entire sequence. And what we can also see is a gradual diachronic change in core technology, starting from the basal layer with the as indicated by this mixture of pressure and percussion mix a technique for making platelet. And based on former USV analysis, we know that a wide range of activities such as cutting, harvesting, perforating, and limited indication of scraping practice at the site, hunting, plant and cereal harvesting as one of the major activities was a practice at the Choragolan. And also the results from the USV analysis fit also clearly to our zooarchaeological and archaeobotanical studies, which indicate transition from foraging to farming community at Choragolan. So thank you very much.
This presentation. Okay, Dr. Jais, I see that she has already raised her hand. Okay, if you hear me, please ask your question.
Hello, I hope you can hear my voice clearly. And I have actually two questions. First one is that you mentioned in the tool categories, you said that a very few number of tools are also made on flakes, although the majority of them are from blades and bladelets. I wanted to know what are those tools on flakes, even few in number. And the second question is also related to the first question. I wanted to ask if you can have, do you have any explanation? Because before the beginning of the Neolithic in Zagros, we know that in some sites we have a total independent operational sequence focused on the production of flakes from flake cores, and they turn into specific tool types. And after the Neolithic, at least I know from a collection that currently I'm working on from Dehloran in 5th millennium, 6th BC, also this is the case. We have a whole independent operational sequence based on producing flakes and flake tools. But as it seems, it's not the case in the early Neolithic sites. And is this something related to Choragolan as a specific functional reason of the site? Or as you mentioned, I think you said that it's like the other sites, it's characteristics which is seen in many other sites. Do you have any explanation that what happens and why? What is the process underneath such a major shift, putting aside the flakes and the industry of producing and using them as tools? That's my question.
Yes, thank you very much for your good questions. First of all, as I mentioned, the flake tools are very low in our assemblage, not only at the base of the sequence, but throughout the sequence. And what we have is only just some flakes that's either used or just, finely retouched. That's it. We don't really have any specific kind of modification to these flakes, as I don't know if you like scrapers. It's totally absent at Choragolan so far. So because first of all, our excavated volume was too small. So if you look at the trench, it was 2 by 1, and at the base of the layer was even smaller than that. And on the other area we excavated 4 by 2 was also, we reached only the depth of 1.5 meters. So I'm not really emphasizing that what we have so far is representative for the whole site, but this is what we have so far. And regarding the second question, as we analyze the lithics, so beginning with the early Neolithic, specifically at Choragolan, so we have an explosion of producing blades and specifically platelets products. and tools that made on these platelets. And this is also related to the core technology, of course. Maybe at the beginning it was more or less practicing with different techniques like percussion and pressure, but I think every site has its own variability and function. So we can't say that Chora, Golan, Sheikhiabad, or East Shahzab, they have the same function at the same time. If you look at the overlapping period. So I think the general similarities are what was happening during the early Neolithic, so mostly related to their daily tasks and activities and economy. But there's differences and the variability in the assemblages could be due to the site settings and their different functionality. So this is what I see in different early Neolithics and also Chora Golan. And I don't know why in some early Neolithic sites they tended to use more flakes than Chora Golan or other early Neolithic sites. I don't have any clue for that, but if you put everything general scenario for the early Neolithic of the Zagros, so you see that all the people just focus on making blades and bladelets using pressure technique, or at the beginning with the combination of percussion and pressure to make their tools and do their daily tasks. I don't know, cutting or harvesting whatsoever. I don't know if I answer your question.
Yes, thank you. I asked this question because I think at least a part of this pattern that we see, only bladelets, only bullet cores, comes from the bias in the studies, because in my opinion, sometimes we don't look for some elements, because when the Mu'allafatiyan was first described in the 1990s, it was focused on the bullet cores and the bladelets, and they are easy to distinguish and they are beautiful. So sometimes I think maybe we are not looking for some things. For example, as you mentioned, the scrapers, thumbnail scrapers are really numerous across the whole Zagros. And suddenly you say that they are absent from the early Neolithic assemblers, or at least at Chora Golan, because I know you're an expert and you have studied the assemblage very well. So they are absent. And this is the question I have. If this absence real, or is this a reflection of the bias in studies? This is my main question. But you have already explained very well about Chora Golan.
Yes, as I said, so fortunately at Chora Golan, I'm not talking about the other side, fortunately at the Chora Golan, the technique we use for our excavation was so fine and precise that we recovered even very tiny micro deposits, and we look at all of them. So we didn't miss anything at what we have. So I'm not sure about the other sides.
Thank you.
No problem.
Okay, it was a little bit long question and answering. So Douglas, I'm sorry, we are a little bit behind, but you can put your question in chat. So it's should be very nice, interesting discussion. So let's move on to the last presentation of the first session, which will be by Dr. Robin Bendry, and the title of the presentation is Ecology of Domestication, Human-Goat Environment, Interactions at the Start of Farming in the Neolithic Zagros. If you hear me, could you please... Yeah,
sorry, I'm just sharing my screen. I've got some... Right. Can you?
Yes.
Right. Is that full screen?
Yeah.
Great. Thank you. I'd like to thank the conference organisers and everyone who's attending the conference. My presentation focuses in a bit from the abstract that I wrote for this into one dimension, because I wanted to develop on some of the dimensions of how the interactions between humans and animals within contexts and certain environments expose us to disease risk, and how we create the conditions for these for zoonotic diseases to transfer, and to think about sort of case studies of domestication as a step change in these relationships. And so I'm going to look at the sort of the well-known record of goat domestication within the Zagros region, and think about it in terms of how it may have enabled changes in infectious disease risk. Some of this work was undertaken at the University of Reading when I worked with Roger and Wendy Matthews there, and then some of it's been undertaken at the University of Edinburgh. So the link between animal domestication and zoonoses has very commonly been made. It's frequently hypothesized. There's some very good data that relates the longevity of our relationships with domestic animals, with the number of shared parasites and diseases, sort of as illustrated in the graph on the right here. Effectively, a long and close relationship encourages the ability to share diseases. And it's not always in one direction. And the general idea is that we maintain animals in larger populations, and we maintain them in these large populations close to us. And this enables this stable conduit for human infection. The problem with this is that there really is very little direct archaeological evidence at many of these transition periods in the past, and we also frame this very loosely, and we don't have a good sort of solid understanding of what are the socio-ecological dynamics of these past emerging diseases. What are the contexts? What are the relationships? So what parameters shape past disease experience and past disease expression? So specifically, I want to look at the Zagros region, and in the Near East more broadly, we have the earliest sort of good possible or probable cases of brucellosis. There's a range of them from Bronze Age sites. It's quite frequently hypothesized that that goat and sheep domestication has been directly related with the emergence of zoonotic brucellosis. And brucellosis is the specific disease that I want to look at as the relationship. There's a very close relationship between sheep and goat herding and zoonotic brucellosis, and it's this disease in particular that has been hypothesized as emerging in the context of caprine domestication in the Near East. However, there is, as I indicated before, for diseases in general, there's not much direct evidence for the emergence of this specific disease. We do have one possible human case from Ganj Dareh. This is older adult individual 22, published and analysed and published by Deborah Merritt, which has some very good osteological evidence to indicate it could have had brucellosis, but this is not definitive. So just to sort of go over what is brucellosis, it's a highly contagious disease. It's actually sort of described as the most common bacterial zoonosis in the world. There's 500,000 reported cases every year, but probably this is grossly underreported, and it could be up to 12.5 million. This tends to impact rural communities that are often sort of sidelined by healthcare and in direct contact with, they've been involved in animal husbandry and animal management. It's a chronic disease. It's rarely fatal, but it can have very unpleasant and disabling consequences. So it can have a broad range of impacts. It impacts animal health and human health, and there are the wider economic impacts. So this can have sort of serious repercussions on many scales, from the household, the ability to subsist and to function and to sort of make money. Kind of illness has a very serious effect in that way, but it has a big effect on livestock production more generally, in terms of sort of disruption to market, milk production, sort of loss of animals, and so on. And it remains in many parts of the world a serious problem today, and it's endemic disease in the Middle East today. It's a major public health problem. Some of the incidence data is here. It's widespread. It's actually increasing in prevalence in livestock in Iran, as Mayam Daydar's recent work has shown. And just really to kind of think about how the levels of prevalence within communities that are very closely connected with animal husbandry tend to have very high rates of active brucellosis. So nomadic communities in Fars, for example, were found to have 10% of them had active brucellosis. Populations of it's very occupation based as well. So hunters, butchers, and healthcare workers in Kurdistan in Iran, again, had about 10% of them suffered from active brucellosis. It can impact genders and ages differently depending on the activities and the everyday occupations and lifestyles. If you're involved in animal husbandry, milking, butchery, it exposes you to greater risk. It can have a series of very sort of difficult adverse outcomes for pregnancies, and is a significant risk factor. And today, it has a substantial sort of wider economic cost. So just to underline the sort of the severity of the impact of this, we're talking the millions of dollars worth of lost animals. There are a range of symptoms that aren't recorded in the skeleton, and some that are. So here we have, so the osteoarticular localizations, and here we have a vertebra from a skeleton, a medieval skeleton that definitely had brucellosis, identified by DNA. And we have an understanding of how it impacts sheep and goats as well. We have Brucella melitensis is the main disease that transmits to humans, and sheep and goats are the main reservoir of this disease. And humans get it through ingesting unpasteurized dairy products or from direct contact with animals, and this can be even through handling dung or something like this. Looking for the evidence in archaeological animal bones is problematic because we don't have any good control data. It localizes in certain parts of the skeleton, so noble joints, certain soft tissues, and it can lead to sort of light scale periosteal reactions, so minor pathological changes, but they would just be non-specific if viewed in a disarticulated assemblage. We also have indications of there's large numbers of abortions in goat populations where so this could be an archaeological signature as well. So we have a situation where it's a very common disease and there's very little archaeological evidence, and it's very problematic to identify that evidence. So the approach I'm taking here is to look at sort of a holistic approach, because if we look at siloed archaeological analyses, just looking at human pathology, just trying to look at animal bone pathology, it is problematic to assess the potential presence of this disease in the past. And it was probably a very common and very widespread disease that impacted many many communities. And so taking a sort of a One Health approach, which tries to combine different data sets, tries to look at a holistic interaction of animals and humans within their environments, gives us the potential to model and reconstruct the interactions that may have led to the emergence of this disease or other diseases in the past. And so the idea here is to, and as we know from recent painful experiences with the COVID pandemic, infectious disease is shaped by all its biology and its society, it's the socio-ecological interactions that are shaping the impact of that on its spread and its impact on communities. So if we take brucellosis transmission, for example, it circulates naturally in wild animals, and today our domestic animal populations are sometimes infected from wild animals. We receive it primarily from domestic animals, but humans are a dead-end host, so we don't pass it on to other humans. And so the idea here is to try to explore the point at which, in the evolution of animal husbandry, when did conditions emerge to support sustained zoonotic brucellosis? Because you could have occasional infections that enter a herd, but we kind of want to know at what population size and at what population structure would you have permanent support for the circulation of the bacteria within that population, because if the population is too small, once all the animals have had it, the pathogen will just die out within the population. So this was a sort of a simulation computer modeling approach that I undertook in collaboration with some veterinary epidemiologists who did the very complex modeling part of this, Dr. Guillaume Fourny and Professor Dirk Pfeiffer at Royal Veterinary College. And I won't go into this because everyone knows the very well understood sequence of goat populations through time, with the wonderful work of Daly and colleagues recently showing the domestic population at Ganj Dareh. I'm going to look at three populations quickly: Ganj Dareh, Ali Kosh, and Jarmo. These are very useful for exploring this question because they've all been recorded and analysed in the same way by the work of the work of Indizida. So we have well dated and characterized assemblages. We have detailed age and sex structure of each of these populations, so we can use this to build the model. The sites vary in size and in location, so we'll be thinking about the different populations of goats. Each of these sizes may have varied. We have Ganj Dareh is quite a small site, Ali Kosh and Jarmo are much bigger. The model parameters basically uses the age and sex structure from the archaeological data, and then we used a modern comparative population profile to try to use it as a control for the archaeological populations, because there is uncertainty in sort of how much they capture the complete population of animals. And we used a general understanding of the spread, the epidemiology and pathogenesis of Brucella in its modern context. And to cut to the results quickly, on the right here we can see 4 graphs, and up the y-axis is basically how infectious we had to change the variability of how infectious the pathogen was, and along the up the y-axis and along the x-axis is our range of population, the variation of the population of goats at that particular site. And what it shows is that the pathogen could have been sustained even for low levels of transmission in very small populations. So, for example, Ganj Dareh, if there were just 100 goats and relatively low infectious rate for the reproduction value for the pathogen, it would have sustained permanent infection. So we are talking about relatively small populations where this can happen. And it's very clear that this is related to the creation of dense population and major changes in the demographic characteristics. So it's actually those populations that have higher proportions of females are more susceptible to the emergence of sustained brucellosis infections within the herds. And when we modeled meta populations of villages, every time you increase contacts between villages, this radically increases the chances of the disease becoming endemic. And we know that across this time period, these populations are in contact. There's exchange of ideas and artifacts and probably animals throughout these networks. So we have a system that would have enabled the emergence of this disease very early on. And it's very clear that it's selective harvesting of the young male goats that modified the age and sex structure. And this increased the vulnerability to pathogen invasion and the probability of it becoming sustained. So then if we look back at the broader picture of what's going on in the Near East, and this here we have a graph of work done by Arbuckle and Tiki looking at caprine population profiles from metrical data, and it's the decision to keep animals in larger herds, but it's also the decision to manage herds for a female-dominated structure, which would have strongly promoted the transmission of Brucella melitensis. And initially, there was a great diversity of management strategies, as shown by Arbuckle and Atiki, with this pronounced young male cull only occurring sort of regularly much later. So sort of using this kind of background the understanding of the population profiles of these animals, we can begin to predict where the likely origins or emergence may have occurred for this disease. So to summarize, this modeling exercise shows that conditions were present very early on for the emergence and endemicity of brucellosis within goat populations. It shows that there were two primary factors. This is population size, but also the demographic profile. And then if we fold into that also the degree of connectedness between these different communities, it can give us an idea of the likely sort of context and rates of emergence. And I think these kind of simulations provide the foundation for reinvestigation of the archaeological record. They can target attention at where we should be looking for other forms of evidence. And it also means that if we can model socio-ecological practices and we can tie this into genetic data, then we can start to look at how cultural practices actually shape pathogen evolution if we can look at case studies through time and space. And what is very clear about this particular disease, brucellosis, when looking at in the bottom right-hand corner, we've got Nathan Wolf's model of the evolution of zoonotic diseases. Brucellosis never passes beyond the stage where it's transmitted from animals to humans, because the ecology of it means it never transmits from humans to humans. It's extremely rare. So what we have done pretty much for the last 10,000 years is create the conditions to sustain this disease very close to us and expose us to this problem. Thank you.
Okay, thank you very much for your very, very fascinating presentation. I'm wondering if there is any short question or comment, just we can have a little bit of time. Okay, Melinda.
Good morning, everyone. Wonderful paper, Robin, and I think I'm very excited to see this, and I know that a lot of folks are sort of on the trail of this, and I think this will help spur them on. I'm wondering a couple things, and I have a brief comment, but mostly, we have the other evidence in the archaeological record for this condition, and we've looked at the number of neonatal and perinatal and potentially fetal caprine remains at Ganjtere to be a possible indicator of this. But I'm interested in seeing how much that occurs in other sites. And I haven't seen too much evidence of it in the Zagros sites, but it may also be because of the older samples just weren't recovering that material. But it would be great to see if we could have some sort of a survey that would pick up these very young remains. So if you've got any other information from Bestançon or some of the other sites, that would be most interesting. And then just a sort of caution. Personally, I don't find the Arbuckle and the TG article all that persuasive about the diversity of and the late occurrence of young male culling practices. And you and I could go over my many objections to that, but I wouldn't necessarily use that as an indicator that this young male harvesting practice is such a late or sort of dispersed practice. But I would think that there's better evidence that it is actually quite early and quite pervasive. So that's basically it.
Okay. Yeah, I think there are late fetal remains from a number of sites. And I think the problem is that there's a range of pathogens and a range of circumstances that can lead to fetal loss in livestock, and there's a broad range of them that could have been in terms of early husbandry practices. But the thing that I've looked at some of the the prevalence of these things, and Brucella is just so infectious, and it's so it's the most common laboratory disease in the world for humans because it requires so smaller parts per million to get to achieve an infectious state. So I think there's a lot to, have you seen Joris's recent paper on he's looked at sort of fetal aging of sheep, and he's started to look at I think there's a Schickleyhoek, different sort of potential causes for that.
Okay, thank you. Kevin?
Hi, Robin, thanks for the talk. I kind of wanted to hear what your thoughts were about the fact that despite its infectivity in animals, it's not particularly infectious once you get to the human state, and whether that's if that's because of how it is transmitted from via the gastrointestinal urinary tract and through milk, whether that might point to I don't know if we can identify pottery that were used to as storage for milk products. Maybe you could pick up brucellosis there.
So it there are very rare. It's transmitted. It localizes in the placenta, and it replicates there, and that's what causes the abortions. It's transmitted through the reproductive tract, so it largely impacts mammary glands and so on. So that's where humans get it through the milk, and there are very rare occasions of it being sexually transmitted, but it doesn't, because of the ecology of it, and because of how because it's excreted in the environment and other animals are eating the grass in the broad environment. That's how it spreads within animals in a very close proximity, whereas we don't we don't subsist in quite the same way. So there is very, very low transmission between humans. So I think you're right. It's looking for those. Yeah, I think milk residues is a good. They found it were proteomics in cheese from Egypt, but I think it's kind of uncertain if it. I think it's Bronze Age, if I remember correctly. I can't remember correctly, but there is a range. There's a range of routes I think to identify it potentially. But it is this the Brucella cell wall is much weaker compared to the sort of mycobacterial cell wall. So that's tuberculosis. There's lots of evidence of it being recovered, whereas there isn't. There's like 5 cases globally of Brucella because it just isn't. It doesn't survive well in the archaeological record, and also the osteological evidence is is very variable. Its expression in the skeletons, so it gets missed and it gets under-recorded. I think there's a temptation often to see it as something else.
Tricky problem.
Okay, thank you very much, Robin. If you have a look at the Q&A.
Microphone is not on.
No, it's okay. There is another question, so just you can write any answer. So thank you very much. We close up the first session, and we'll be back in 20 minutes. I think we are a little bit behind at 10 o'clock as previously scheduled. Okay. 11. 11, sorry. Yeah. Okay. Bye for now.
Bye.
Okay, everyone, welcome back to round 2 of our papers today. And it's my great pleasure to introduce the first speaker of this session, Donna de Gröne, who will be talking about human-animal interactions in the early Holocene of the Eastern Fertile Crescent. Over to you, Donna.
Thank you. Let me just... Can you see my screen now?
Yes, looks great.
Perfect. All right. Good morning, everybody, or good afternoon, depending on where you are in the world. And thanks to the organizers for having me at this conference. So I'll be talking about animal management in the Neolithic in the Eastern Fertile Crescent, which is my PhD project, and I'm also part of the MENTCA project. So for my presentation today, I will first be shortly talking about my role in the MENTCA project and my research context. And then I'll be presenting the results from the zooarchaeological analysis of Baston Sur. And I will mainly talk about the big remains of this site. And then I will very shortly talk about the stable isotopic analysis I conducted on motors of sheep and goat. There was more about isotopes in my abstract, but due to the pandemic, loads of that got delayed. And I only got these results last week as well, so it's very preliminary analysis. So my research is part of the ERC-funded MENTCA project, which you've heard loads about so far. So my project is part of work package 2 as well, just like Charlotte Stiffy, and she already talked about what this work package actually is, but I'm focusing on the animal side of food waste in the Neolithic. Melinda Cedar already talked loads about the fact that domestication is a very long process, which takes several millennia. And the end result of domestication is obviously an animal which clearly looks different from its wild progenitor, but there are a lot of stages in between, and very little is known about what these first stages exactly involve. And it's very local as well. And we don't know so much about those first steps towards domestication in the Eastern Fertile Crescent, especially compared to the Western Fertile Crescent, although obviously during this conference we've heard loads about work being done in this region now. So people already touched upon this, but I don't think it's really been talked about yet. So Melinda Cedar divided different ways animals can get into the domestication process. In the prey pathway, very simplified, humans hunt a certain species, but in order to maximize their gain, they start to manage the herds, which can eventually lead into a domestic partnership. And sheep and goat are both likely to have been domesticated through this pathway. The commensal pathway differs from the prey pathway in the fact that animals are attracted to the human settlement themselves. For example, because of the food waste of which humans leave, and humans do not necessarily have to hunt this species. Dogs are likely to have been domesticated through this pathway, and maybe pigs are domesticated through this pathway as well. And since I will be talking more about pigs, this is quite interesting to mention. There's several markers for human management which precedes domestication in the archaeological record. First of all, there's the change in sex and age patterns, which has been used by Melinda Cedar to reinvestigate animal domestication in the Zagros region. And also there's a change in body morphology, but that's more visible at the end of the domestication process and not so much at the beginning. Other than that, humans, when they start to manage a population, can exercise control over the diet of animals, for example, by fodering them certain food sources. So food sources they might not normally have access to, or by restricting them access from certain food sources, for example, by restricting them access from certain environments. And this might be visible through stable isotopic analysis. And just like that, people could restrict movement of animals or introduce them to new locations. And this might also be visible through stable isotopic analysis. And also now there's Asian DNA. I guess more people will present about that today, and I don't know so much about what that exactly can do. So for my research, I tried to get a better insight in what the first steps of animal management in the long process of domestication exactly involved. I'm both analyzing newly excavated material from West on Sur, which you've already heard loads about, so I won't go into details about the site. I also did a stable isotopic analysis of teeth of sheep and goat from Ganj and Chermo, which has been excavated by Braidwood and then restudied by Melinda Cedar. So here you can see the preliminary results of the zooarchaeological analysis of West on Sur. So these graphs are only mammals and are not including micro mammals. The left graph is based on diagnostic zones, and this graph is based on number of identified specimens. So you can see that sheep goats are the most abundant animal group at the site, and sheep, that's the orange bit, and here are clearly outnumbering goats. Then we've got quite a high abundancy of suids, so I call them Sus here, but I call them Sus here because they can be either wild boar or pigs, although I think, and I'll talk about that in a bit. And you can see we've got quite a lot of large surfeit too. And so here you can see the abundancy of pigs at several sites in the Eastern Fertile Crescent. As you can see, at West on Sur, we clearly have a very high abundancy of pigs compared to wild boar, compared to other sites. There's only like more at Shimshara, which is another site excavated by the Mentka project. This site was close to marshlands, so maybe that's why there are loads of wild boar or pigs there. And then at Asiab, there were quite a lot of wild boar too, but most of them are found in a special deposit, so they're overrepresented here. In pottery Neolithic Charmo, we think pigs are domestic, but still they're not as many as at West on Sur. So here you can see the log size index of the pigs of West on Sur. If you're familiar with log size index, you basically have to remember that everything on the right is bigger than the standard animal I compared several measurements to, and everything on the left is smaller than the standard animal. So we can see post-cranially, the pigs of West on Sur are very large. They're larger than most other Neolithic or Epipaleolithic sites in the Eastern Fertile Crescent, but these are dental measurements, so these are from the molars. And then we can see they're quite small actually, and we've got especially quite a small group here, which is even smaller than Charmo pottery Neolithic pigs, their molars. And this is very interesting because the molars are not so much influenced, the size of the molars are not so much influenced by sexual dimorphism. And also they are maybe decreasing in size prior to like their body. So maybe their teeth decrease in size in the domestication process first. So this is the aging of the pigs, both based on dental eruption and wear and bone fusion. The age pattern of our pigs or wild boar is very varied. We've definitely got some young animals on the side, but we also have got quite a lot of very old individuals, and there's not very many prime adults. So to summarize, at Peston-sur, we've got a very high abundance of wild boar or pigs. They're very large postcranially speaking, but they've got quite small molars. The environment in the Neolithic around Peston-sur would have been a good place to live for wild boar because there were lots of marshlands, and Shimshara has quite a similar environment. So it might be that they were just hunted since they were around the site more. Although in one trench at Peston-sur, a coprolite of a pig was found, showing that at least one alive pig or wild boar was present on the site. And of course, in itself, that doesn't say that people were keeping pigs at the site, but they were very close to the humans. And since they might have been domesticated through the commensal pathway, this is very interesting. I also just wanted to include these figurines. They're from Sarah, which is slightly later in date, and they're excavated by Braidwood. And I'm not an expert on figurines, but I thought, like, this is the one we normally see, the left one, and that looks quite dangerous and has a long snout, like a proper wild boar. But then these others, which are also found there, don't look as dangerous, look even mildly friendly and have way shorter snouts. So those might be animals along the domestication process, I thought. So I also wanted to talk about the isotopic results I got so far. Like I said before, I only got these results last week, so they're very preliminary results. I think you might have all heard of sequential sampling of molars to get different seasonal signals in isotopes. So you can see an example here, like you take multiple samples on the same molar, and then you can see different moments in the lifetime of the animal, and therefore you can see seasonal variation in diet. The isotopic composition of oxygen in teeth is reflecting that of the animal body water, and that is made up of the ingested water and oxygen in the food sources of the animal. The isotopic composition of water around the world varies according to fractionation processes involved in evaporation and condensation. And the main variance we see in teeth is based on seasonality, although altitude can play a role too. And we might also see variation in oxygen isotopic composition between sheep and goat, because there might be a difference in the oxygen composition in plants. Especially goat and sheep might have different seasonal signals, because goat can live for longer periods without drinking water, getting all the moisture they need from plants, while sheep are less likely to do so and need to drink actual water. And this is a modern teeth from Peston-sur resampled of a sheep, and here you can see quite nice seasonal differences. And the isotopic composition of carbon, which we sample along with the oxygen, can give more information about the plant foods consumed, since the carbon in animals in the teeth reflects the plant food. Plants absorb CO2 for photosynthesis, and the main differences in the carbon isotopic signal between plants is between C3 and C4 plants, which photosynthesize in a slightly different way. You can see the different signals here. The abundancy of C3 and C4 plants is dependent on the area. In current day, Arak and Iran C4 plants are native to the area, but they are in the far minority, like the orange bits here are the proportion of C4 plants. And we don't know very well how many there would have been in the Neolithic. And the abundance of C4 plants is also very much dependent on season and elevation. And within C3 plants, there is variance within isotopic composition as well. On a seasonal basis in semi-arid environments like the Zagros Mountains, the carbon isotopic compositions in C3 plants shifts to moisture availability and humidity levels. And this is also likely to have been reflected in teeth. So here you can see all the results I've got so far. So the range of them, as you can see, there's a large overall overlap in carbon and oxygen composition between Charmo, Ganstiere and Peston-sur, but Ganstiere has a bigger range, which is interesting. It might be just because I sampled more teeth from Ganskaray, that there's bigger range, but it might also be that there's more variance in seasonal differences. And here you can see like older isotopic analysis from test answer. These are all M3s. So I only just started modeling the data I've got from the teeth with a model made by Marie Balesse. She made the model mainly to account for tooth growth when looking at bird season. But since often I don't have complete sequences for my teeth, it's actually a good start to see the full seasonal sequence. And it's easier to spot the odd values, which obviously doesn't mean they're wrong. Of course, the module is only using the data it has, and since I don't have full seasonal sequences, it assumes all seasons will be very much the same. So the green lines here are the data, and like every white dot is a data point for me, and then the blue lines are the expected seasonal curves. These are all M2s. So I only just started doing this, but you already can see the examples of the 3 sites. And you can see the oxygen data vary a lot per site, but also intra-site, like between those two, there's already quite difference. But yeah. So I need to work more with those modeled oxygen data, and I need to add the carbon to those modeled oxygen data to see further like differences between seasons. I also hope to do some stable isotopic analysis on bone collection from Ganskaray. I already tried it for Charmo and that didn't work, which I also kind of didn't expect to work. And on Bastansur, the results were quite poor as well. But in general, on the higher Zagros, there's quite good collection preservation. We, for example, tried to do bone collection analysis on Shagyabat, and that worked quite well. Also, maybe I get more samples from Sarah Panasia, which will be good to compare with these sites. And the project, Menka project, is now also analyzing the zooarchaeological assemblages of Hout UK, which you heard about on Monday from Hassan and Roger. I am more than out of time, but I'm happy to answer any questions, also more specific questions about the sheep and goat, which I didn't really talk about so much in the presentation. Thank you.
Thank you so much for your talk. That was very interesting. Do we have any raised hands? Melinda, is it from earlier, your hand, or a new hand?
I didn't raise my hand, but it may be an earlier hand, but I'm happy to say a few words. Lovely paper, and I can't wait to see the rest of your results from all of your hard work at the Smithsonian and other places. I'm very interested, obviously, in the pigs. I'm sort of pig obsessed these days. So mostly I think we can talk sort of offline because we'll really get our snouts into the data that might bore other people, but will fascinate me. But I just wanted to let you know that Jimena Lemoyne and I are finishing our analysis of the Hollandchemy pigs. We have a paper in prep that we hope to submit this fall, but it presents a number of different models for both hunting and herding of pigs, because they have such an interesting difference in their demographics that we really need to have much more refined models. But what we are seeing, as I mentioned in my talk, is a shift in time in these early periods at Hollandchemy towards something that may not actually be management, but may be setting a precedent with the clear signatures coming up at China. But what I didn't mention in my talk is that we also see over the short occupation at Hollandchemy, only 200 to 300 years, clear evidence of a reduction in the size and the breadth of lower molar teeth. So there may actually be some morphological change, and it would be very interesting to compare that to your samples. So I wouldn't necessarily assume that your Bastansur pigs are totally wild at this point, given the diversity of these age models. But I think it's something to be looking at in the future. So that's basically my incoherent comments at 5:19 in the morning in Maine. So thank you, Donna.
Thank you very much.
I think we all appreciate your early morning efforts here. Marjan Mashkour, please, next.
Yes, hello Donna. That was great. It was very interesting. I was very interested about especially your isotopic data, as I think we had exchanged on a bit on that together. And as maybe you know, I've been analyzing also the Ganj-Dareh new material from Ganj-Dareh and some from the previous excavations through Melinda Zidir. So we are putting all these together. We've been late, but we have some, of course, information on several sites. And so I just wanted to say that we see really seasonal movements in, at least in Ganj-Dareh material. So it's very, very exciting to have all these data coming together for this region. And thank you for your talk.
Thank you very much. That's good. It's great to hear that you've got all the data coming together. It's good to look at.
Okay.
Great, thank you very much. And so that we stay on time, if you're having more questions to Donna, then please put them in the Q&A. Also, there's another question there already from an earlier speaker. So thank you very much again, Donna. We'll move on now to the next talk, which will be presented by Elenia Suti on behalf of herself and co-authors. And this talk is Environment and Subsistence in the Zarzian, New Evidence from Palagaura Cave. Thank you, Eleni.
Just give me a second. Okay. And just give me a second. Good morning, everybody, from cloudy but not too cold Liverpool. Today, I'm going to talk about the subsistence datasets from Palagaura Cave. As you all know, Palagaura was first excavated in 1951, followed by a second season in 1955 by Bruce Howe and Bob Bridewood as part of the Iraq Zarmo project. This expedition followed the pioneer work of Dorothy Garrod in 1928 at Suleymaniya at the late Paleolithic sites of Zarzi and Hazar Merd. 7 decades later, quite a bit of time, myself with Doug Baird initiated the Eastern Fertile Crescent Prehistory Project. And you can see here the project participants, quite a few of them, the project team members, key project team members, quite a few of them are with us here today. During this time, 70 years almost, with the exception of Palagaura and to a lesser degree Shanidar B, the Zagros Epipaleolithic continued to lack reliable radiocarbon chronologies, and again, with the exception of the Palagaura faunal data, robust archaeobiological data. Plant exploitation in particular remained completely unknown. So these were basically some of our key motivations. But in the process of thinking through project aims, we came up with more reasons for returning to this part of the Fertile Crescent. Our key main research focus is, of course, the time span between 20,000 and 11,000 years Cal BP, represented in the northern Zagros by the Epipaleolithic Zarzian and the Proto-Neolithic chronocultural horizons. Our main objectives is to investigate the chronology, habitation patterns, and resource exploitation strategies, of course, including plants, animals, and raw materials, characterizing local communities during this time span, and to compare our finds to other regions and contemporaneous entities known from Iran, as well as Anatolia and the Levant. Our main research aim is to investigate the nature and socioeconomic and ecological contexts of the late Pleistocene and earliest Holocene hunter-gatherer habitations in this part of the Zagros, and particularly the corridor linking the Taurus, the two sides of the arc, the Taurus and the Zagros, including, very importantly and critically, potential links and interactions with both the upper Tigris Basin to the northwest and the central Zagros to the southeast. So, Palegaura Cave is situated in the Slemani region of Iraqi Kurdistan on the northwest extension of the Baranan limestone reeds, flanking the Bazian Valley on the northwestern Zagros foothill zone. The site is located at an altitude of approximately 854 meters above sea level. A cave and rock shelter, the cave and the rock shelter complex facing the southeast, as indicated in this image. It is part of a complex of caves and a little, very, very shallow rock shelter, as you can see here. Of all these, only Palegaura Cave, as originally investigated by the Brightwoods and Howe, had evidence of early prehistoric habitation. Brightwood and Howe had excavated to the bedrock the main chamber of the cave, but had left the terrace here and the threshold of the cave unexcavated. Over two short seasons in 2016 and 2017, we sunk two test trenches, Area A, located here, and Area B on the terrace. And in 2017, we focused most of our efforts in Area A, as initial results suggested that it held greater potential, especially regarding the density of its plant and faunal assemblages and the integrity and phasing of its stratigraphy. Area A had evidence for in situ activities as well as dumping from what was the likely focus of late Pleistocene activity in the main cave chamber. In 2017, we extended Area A to a total size of 2 by 2 and excavated to the bedrock. Views of it you can see here, which was located at a depth of approximately 1.02 to 1.2 meters, representing the depth of the late Pleistocene deposits below the topsoil layer and the early Holocene deposits. Flotation sampling was applied at 100% to all undisturbed late Pleistocene deposit excavated in Area A. Machine-assisted flotation was applied throughout. Given the nature of the clay-rich sediment matrix and the volume of the samples, any other processing method would have been completely inefficient for archaeobiological recovery from 100% of the excavated late Pleistocene deposits. A few things about chronology. We have obtained thus far a limited set but fully stratified AMS radiocarbon dates. Our strategy was to focus on, to date, single entity specimens of short-lived material and all of them of the same botanical species, exclusively almond charcoal, and for the earliest part of the excavated stratigraphy, which, if I remember well, was just above the bedrock, context ADG, almond nutshell. Our work has extended the chronology of, compared to previous assays of the cave by about 2,000 years, beginning at approximately 19,600 Cal BP based on the Bayesian modeling of the dates. The cave use appears to have been continuous through the late Pleniglacial, represented in the Area A stratigraphy by phases 1 to 2. So from approximately 19.6 to 16.6 Cal-BP. This is followed by a possible break or potentially more sporadic visitations after 16.6 thousand Cal-BP, which coincides actually with the extremely dry conditions of Heinrich Event 1. The use of the cave, regular visitations to the cave, appears to have resumed at the beginning of the late glacial. We have so far obtained no dates from the uppermost part of the phase 3 strata, which represents, as I said, the late glacial. Our Bayesian model suggests a likely end of area A late Pleistocene deposition around 13.2 Cal-BP. There could have been later habitation mixed near the top of the sequence excavated by Howe, as indeed has been suggested before by some of the bone collagen dates previously published by Melinda Zider. But on presently available evidence, we cannot resolve this issue. Moving on to the faunal remains, and I hope that I will do a good job with them. Previous zooarchaeological analysis from the Iraq Jarmo excavations, project excavations at Palagara was published in detail by Turnbull and Reed in 1974, who interpreted the site as a short-term hunting camp located in a sparsely wooded steppe. Our diagnostic sample size is considerably smaller than what was studied by these authors, but systematic sieving of the EFFECT project produced a slightly different balance of remains, with larger and medium-sized mammals being similarly represented, although we had lower percentages of large mammals. But unsurprisingly, given the recovery from a mesh size of 500 microns for the flotation heavy residue, much higher proportions of fish, bird, and microfauna. Microfaunal categories haven't yet been studied, but they promise additional information on the paleoenvironment. We do have overall counts of diagnostics, however, for those categories. For today, we have focused on large and medium-sized mammals from the larger than 4 millimeter sieve fraction, and we will also include discussion of tortoise remains as part of the reptile category. As you can see here, our species list and NISP comparisons, the number of identified specimens and NISP relative proportions breakdown show a similar range of taxa to those reported by Turnbull and Reed, albeit with some differences. Onager, the half-ass Equus hemionus, is present in highest proportions between 20 and 30%, a typical plains grassland species which biometrically compares well with the modern Iranian onager. You will see we have compared here graphically two phases only, phases 1 and 3, and there is some variation between them. For example, phase 1 has lower amounts of larger mammals and higher proportions of bird, fox, and hare. But generally, the overall trend between the phases is similar. They are both also dominated by tortoise, to which we will come back later. After onager, we see red deer, Cervus elaphus, a woodland or woodland edge inhabitant. Gazelle, which we assume to be the Persian gazelle from known past and present distributions, and also slightly fewer wild sheep and wild goat, both equally represented. There are birds not yet identified, fox and hare, then very low proportions of wild boar, and even lower percentages of wild oxen and fallow deer, probably the Persian fallow, the Mesopotamian subspecies. There we are, some wonderful pictures of animals and tortoise. These animals together represent a mosaic of habitants from grasslands, equids, typical inhabitants of them, shrublands and woodlands such as deer and rosen, steppes, gazelle, these wonderful little creatures down here, mountains, of course, the wild goats and sheep, to wetlands, these wild boars here. The taxonomic habitat index, which filters out human selective practices, also shows a diversity, as expected, of habitat types, with grassland, steppes, shrubland, and forest environments best represented by the suite of taxa we have found in the Pallegaura assemblage. Turning now to onager hunting, the sample of onager tooth crown heights that could be measured showed animals were culled primarily as adults, either primates between 7 and 9 years old or 10 years and older, with just one younger animal present. A previous reanalysis of the older equid assemblage from Pallegaura by Bakken argued that hunting of equids could be interpreted as targeted selection rather than whole herd culling, and likely focused on female groups with the occasional juvenile. This interpretation seems to fit well with our data too. Onagers exhibit behavior in which the males hold seasonal territories in richer grasslands, and female animals tend to range across those territories. In present-day Iran, onager herds inhabit the grassy plains for much of the year, but shelter in the hill valleys in the harsh winters and springs to avoid strong winds. It is possible that the epipaleolithic inhabitants of Pallegaura awaited onager herds entering the Bazian Valley in winter and spring, or spring, or spring, after their mating season and before summer birding, since these fast-running individuals would be easier to trap or stalk in an enclosed valley rather than on the open plains to the southwest. Moving on to skeletal part representation, were we to base our interpretation only on diagnostic elements, our analysis would have suggested that only head and foot bones were transported to the site. However, to get a better understanding of body part representation, we also imputed in our analysis undiagnostic fragments too, attributed to mammal size class. And here you can see that all major elements are represented, including, for example, skull parts and all limb bones. This indicates that whole carcasses were transported to the site. This might be more likely if onagers, and indeed the other taxa too, were hunted in close proximity to the cave, that is, in the Bazian Valley immediately adjacent to it. Moving on to butchery patterns, the large and medium-sized mammal bones show clear evidence for marrow extraction on mandibles and the spiral fractures on long bones and phalanges. So, extraction of within bone nutrients was clearly important to the inhabitants of the cave. The table on the right here, frequency of butchery, that is marrow extraction, shows that elements of the larger animals, such as onager and red deer, were more highly processed than sheep, goat, and gazelle-sized animals, hinting at experienced decision-making in this regard. Tortoises, a brief mention of tortoises here. Identified specimen counts, that is NISPs, tend to inflate tortoise representation because their carapace fragments are easily identifiable and break down into smaller scutes. So straightforward NISP percentages would put tortoises at 70% of the assemblage. We have used instead adjusted standardized counts, which even then make up almost 30% of the assemblage. Tortoise remains always require close study since they can arrive in archaeological deposits by natural means, for example, through natural death of these burrowing animals. But overall, the condition, taphonomy, and patina of the bones found at Pallegaura show that they are highly likely to be human food waste processed for the meat packages they provide. So overall, based on the faunal remains, we know that in other studies of Middle Eastern Epipaleolithic zooarchaeological assemblages, the presence of high numbers of smaller animals, such as tortoises, plus alongside evidence for intense carcass utilization, including marrow extraction, is often taken to reflect what we can term resource stress and feeds into pressure models. We argue, however, that Pallegaura does not show evidence of resource stress for several reasons. First, marrow extraction is commonplace among hunter-gatherers as a routine means of gaining storable marrow to carry over lean seasons. The Pallegaura occupants were selective in their marrow processing habits. They didn't process every single element, but selected large mammal metapodials and phalanges, which are easier to open and more marrow-rich. Third, tortoises are slow-moving animals, making easy pickings for hunter-gatherer groups and do not need to imply an absence of larger game. And finally, between phases at Pallegaura, we don't see changes in the proportions of hunted animals, which would indicate an overhunting scenario. Rather, there is little change between phases. And in addition, the hunting strategy of the most common target, the onager, shows no pressure at all, which would have been suggested were there a case for an abundance of juvenile individuals. And finally, with regard to animals, we have also some evidence for culturally modified bone. Here you can see on the left an ochre-stained flat blade of an onager scapula. The ochre residues are highlighted here in the circles. This suggests that the scapula might have been used as a pallet. We also found 3 ochre-stained tortoise fragments, and you can see a beautifully photographed example here. The one you see here is the marginal scute of the carapace with clear evidence of ochre staining on the inside. 2 other scutes have ochre staining on their surfaces, which are also slightly polished, hinting at the carapaces being used as ochre decorated vessels. These fragments hint at the incorporation of animal parts into the social and symbolic lives of the hunter-gatherer forager groups at Pallegaura. Moving on to plants, and a bit more solid ground for me. In previous sessions, some conference delegates stated that there is no evidence of Epipaleolithic use in the Eastern Fertile Crescent. So I start with this disclaimer. This is factually incorrect. There was published evidence before, that is, for example, the terminal Pleistocene Epipaleolithic levels at Kyortik Tepe in the upper Tigris Basin of Eastern Anatolia. And there is now new evidence from Pallegaura, which I'm about to discuss today, and has been already published in September of last year. These data may differ from Levantine sites, such as Ohalu II, to mention but one example, but this in itself does not diminish their importance for an emergent understanding of the Zagros Epipaleolithic, both in terms of prehistoric plant use and of late Pleistocene plant ecologies. It is true that similar data are still lacking from the Iranian Central Zagros, which is a gap that will hopefully be addressed in the not too distant future. At Pallegaura, we have found two major plant part groups. Nuts overwhelmingly dominated by almonds, with few poorly preserved fragments tentatively identified as pistachia, seeds, notably legumes, especially Vicia lathyrus, but also a number of small and large seeded grasses, which also include wild barley, and a few others, for example, mustards, as well as quite well represented in the Pallegaura botanical assemblage, tubers, parenchyma, and sedges. Preservation, especially the impact of leaching, was a major issue, and this is also evidenced by the study of phytoliths. A full report has been included in the project publication in 2020 in PLOS ONE. The stratigraphically and chronologically earliest phase 1 held much denser concentrations of both wood and non-wood char plant remains. And the reason for that is that the phase 1 deposits were sealed under successive rockfall layers. And you can see here the differences in the densities measured as total counts and NISP counts per liter, starting from phase 1, which is the earliest, moving on to phase 2, and then phase 3, the uppermost part of the excavated sequence. And here you can see illustrations of a selection of Pallegaura Epipaleolithic plant remains. So we have the almond nutshell, fragment of tuber, Vicia lathyrus seeds, hordeum that was actually found both in the deeper layers as well as higher up, including bits of hordeum chaff, and a selection of small seeded grasses. We have some possible pistachia nutshell, as well as plenty of indeterminate nutshell that was really poorly preserved, as well as an abundance of phytoliths, including regular presence of starch granules in phytolith samples studied by my colleague Emma Jenkins. Ecology. The charcoal taxa, the dominant charcoal taxa by count and ubiquity were almond, oak, and salicaceae, plus Celtis, hackberry, in this order. Most of these, and I will briefly go back to this slide, were found in phase 1, the late pleniglacial deposits. It seems that leaching had a particularly nasty effect, as you can see here, the lower part of this table, on charcoal preservation, with most of the material coming from the sealed under rockfall layers deposits of phase 1. So basically we have two main habitat types, considering all things considered together, the wood and the non-wood macro and micro fossils. We have the riparian wetlands, and you can see here characteristic examples of the salicaceae and fraxinus charcoals, as well as open woodland and grassland, represented in terms of arboreal species by almond, as well as oak fragments that were found diffused through the entire part of the stratigraphy, even in the latest phase 3 deposits that were otherwise so badly affected by preservation issues. This reconstruction brings us to the question of the paleoenvironmental reconstruction. On the left here, you can see the ice core chronostratigraphy and its correlation with the Lake Zeribard data, and overlaying here the time span which sets Pallegaura, fits Pallegaura chronology to this scheme. Note that the dominant woodland taxa we have found, the almonds, the salicaceae, that is willows, poplars, as well as Celtis, are either entomophilous or poor pollen producers. Something that holds true for Pistachia too, which is underrepresented in pollen diagrams as an erratic pollen producer. Okay, so according to the Zeribar pollen data, the time span corresponding to Pallegaura epipal habitation is basically, as has been described by other authors, represents a state of virtual desert. There is virtually no woodland growth. And when we come to the start of the Holocene, after the Younger Dryas, which obviously is not a period that concerns us here, but is nevertheless indicative, we have a very slow re-advance of woodland. However, we know from our previous work at Chogagolan, and we've mentioned that briefly in the previous days, the charcoal diagram published as part of our collaboration with the Tübingen Chogagolan team in 2015, that there is no oak there, but Pistachia is quite abundant, and it actually increases rather than decreases during the lifespan of the site. In this context, explanations favoring early human pressures on woodland vegetation appear to be unconvincing, as they have been elsewhere in Southwest Asia. Specifically for the Zagros, and particularly for oak, the explanation offered previously by El Moslimani and Jamali concerning the failure of oak to regenerate from seed in hot and dry summers with high insolation appears to be more convincing. That is, the higher seasonality characterizing the early Holocene. More convincing, and probably working together with this explanation, is the one previously proposed by myself and Kabuktu in a paper published in 2014 in Quaternary Science Reviews on the impact of competition with grasses, which also pick up dramatically at the start of the Holocene, until grasslands are checked by the expansion of sheep and cattle herding. You can see here how fast grasses raise at the beginning of the Holocene. And I may draw your attention here to the fact that the expansion of sheep and cattle herding appears to have been a rather late development, as was discussed yesterday in the Zagros. What then about the presence of deciduous oak at Pallegaura in the late Pleniglacial? Zeribar shows no oak. Here is the Zeribar lake located on the topographic map. It is situated in a high altitude catchment close to the rain shadow and an intensely cold area during this period. By comparison, Pallegaura is located in a sheltered valley near water courses and must have received more rainfall rather than snow during this period. This idea was first proposed by Herbright and taken up by Willem van Zeist vis-à-vis the northwestern Zagros Hilly Flanks. We have no botanical data from other Epipaleolithic sites in the central Zagros to compare and test this altitudinal difference in the distribution of vegetation. However, we have some data from Upper Paleolithic sites, both about to be published and unpublished. The first set of data comes from Shanidar Cave, Baradostian, recently dated to about 42 to 35,000 years ago. Specifically, plant remains from Baradostian hearths as well as dispersed contexts. And we have found in these Pistachia, almond, hackberry, a collection of small and large seeded grasses, as well as legumes, tubers, and char plant aggregates. In terms of charcoal, The Paradostian layers include both deciduous oak as well as pistacia, plus almond, maple, and hackberry. From the central Zagros, we have looked at wood charcoals from Yafte Cave, also Upper Paleolithic, dated to about 38 to 35,000 years ago. And unlike Shanidar, the Yafte Cave wood charcoal is dominated by almond and acer. So there seems to be a Zagros gradient, northwest to southeast, and from west towards the east, towards the plateau. From deciduous oak down to pistacia, at least for the early Holocene, but we know that during the late Paleolithic and the early Holocene, deciduous oak existed in the northwest. Throughout this region, amygdalus, almond is abundant both in late Paleolithic and early Holocene periods. So to conclude, the Eastern Fertile Crescent Paleolithic subsistence, a first, let's say, provisional, subject to the availability of more data, integrated view. There is definitely evidence for broad spectrum hunting economies, and moreover than this, there is no evidence for resource depletion or stress. The strategies remained stable throughout the epipaleolithic habitation of Palagaura. Plant economies, almonds and legumes were likely staples alongside various grasses, including wild barley and tubers. These form a very interesting antecedent of what appears to have been a remarkably long lived tradition of plant use across the Taurus-Zagros arc, that is the roundhouse horizon in the early Holocene in eastern Anatolia and northwestern Iraq. Nuts and legumes, moreover, appear to have been Paleolithic plant staples, not only in this region, but more generally, I would argue, and we have put a couple of papers in to this effect, across the woodlands and grasslands of the Eastern Mediterranean. Not unsurprisingly, and certainly significantly, amygdalus and or pistacia also are the dominant charcoal taxa at most of these sites. I would say, and we have put it in writing, resilient plant habitats managed for millennia prior to the start of the Holocene appear to be represented in these open woodland grasslands. There are implications to this argument, which I don't have time to go into now, which redefine our understanding of foraging and its construction, going well beyond the confines of pre-domestic cultivation with regard to ecological inheritances represented in the archaeobotanical record. Both nuts and legumes are resources require complex processing sequences and technologies, not always or necessarily associated with groundstone implements as such. The reason they require them is that they render them edible by humans and convert them into foodstuffs. We now have additional evidence beyond presence equaling harvesting in hand to support this hypothesis, with data also including SEM of chart plant aggregates, as well as other analyses which are about to be submitted for publication. And I will close this presentation by some points that go beyond research, as there are also epistemological and other social responsibility issues by focusing on subsistence archaeology as well as material culture. Flotation sampling, both its application and sampling coverage, must become an integral part of all projects, but especially pre-agricultural communities. Archaeobiological remains are an integral part of humanity's ecological and cultural heritage. And the second point in relation to this is that we have been observing a rapid decline of organic preservation. It is already noticeable at several sites. Doug mentioned the other day the lack of any organic preservation from Karim Shahir. And we know from published descriptions that Turkaka is pretty much the same situation. And at Palegaura, every test we ran for bone collagen preservation returned negative results. And I've already spoken about the effects of leaching. There are major identified risks, not just in this region, but across the world, represented by global climate change and site destruction. And it is quite possible that giving it another 10 years, there may be nothing to investigate, to retrieve and study with regard to our shared ecological and cultural heritage. Another important thing has to do with data curation and open dissemination. We all have to strive harder to get our reports and full data sets out there in public. Data archiving and securing access to data and primary materials for future generations of researchers, as well as undertaking new studies of older data sets and primary materials. This is very important, especially for primary archaeobotanical data. None of us will live forever. We need to do more in this regard. I don't need to emphasize further the importance of fostering public communication, but I would like to conclude this list with a plea for promoting creativity and innovation. We do need to stay open-minded, building on new approaches and new data. Some older concepts are fast approaching the end of their usefulness for generating new insights. We are all susceptible, myself included, to confirmation bias. So we need to do more in this regard. And with that, I would like to thank the conference organizers for providing this opportunity for open discussion and debate, as well as several people who have contributed with this work to this presentation and to previously published and future to be published work. Thank you.
Thank you very much, Eleni, for this detailed overview of the Palegaura material. We're running quite late now, so we're going to move on to the next speaker. So can we? It would be Kevin Daly now. Yes, there you are. Okay. Go ahead.
Sure. Just share screen. Sorry. Can you see my screen? Oh, sorry. I should be more prepared. Can you see the slides?
Yes.
Yeah. Okay. Hi, everyone. My name is Kevin Daly. I'm here to talk to you about ancient goat genomes from Tepe Abdulhazin and Ganj Dara. I have a list of co-authors here, Lisa, Pernille, Marjan, Mindy, and Daniel Bradley. But this work couldn't have happened without, at least other collaborators. So I'd just like to thank them now. This is going to be a real sprint through some results, because I would like to do a few other things rather than just talk about this study in particular. So I won't introduce the sites. Tepe Abdulhazin and Ganj Dara, I'm sure you're familiar with them. Kind of the intention of this collaboration was to combine archaeozoological data and paleogenetic data to kind of assess the goat populations at these ceramic Neolithic sites where there's evidence of management. So in a reanalysis of the goat remains from Ganj Dara across all levels. This is with the recent excavations with the Iranian-Danish team and the Smith excavations. What we can see is a difference in the survivorship of males and females goat at roughly the age of 12 months. Males appear to get slaughtered, whereas females are allowed to continue to survive and breed. And so preliminary analysis of the faunal data from Tepe Abdul Hussein shows a similar drop-off of survivorship in across the older population. This isn't split by sex, and the results are still fairly preliminary, but we do think there's management occurring at Tepe Abdul Hussein as well. This is despite the kind of morphological similarities that they have with wild goat. So just an overview of how much material we had here. So roughly we had 45 specimens across the two sites, and maybe 70% of them produced enough DNA for species identification, and maybe 1/3 gave enough DNA for kind of genome-wide nuclear genome analysis. We found that a dilute bleach wash before genome, before DNA extraction does, in this case, helped increase their endogenous DNA content to roughly an average of 27% for these genome sequence samples. And then we were able to determine molecular sex across all of these samples. At Ganj, we actually see a similar molecular sex ratio as the metric data would suggest, a bias towards females. At Tepe Abdul Hussein, it's kind of the opposite. There's actually bias towards males, but this is off much fewer samples. So the genomes themselves, so we generated 40 new genome sequences and placed them in a kind of principal component analysis of ancient and modern, domestic and wild goat. And kind of the left and right sides roughly represent kind of West Eurasian and East Eurasian genetic affinity, and then the top and bottom reflects domestic and wild affinity. And what we see is that across the two sites, there's two clear clusters of ancestry, a kind of a larger, more domestic-like group, which we call the Zagros main group, and then a smaller outlier group, which appears to have greater affinity with wild genomes. And this outlier group is composed of a genome from each of Tepe Abdul Hussein and Ganj. So this is kind of across the two sites. And we can do kind of statistical analysis to directly test whether these two genomes, these outliers, do have more wild ancestry. So when we pair up the genomes across the two sites, we see that consistently the outlier genomes have more affinity with a kind of a clearly pre-domestic wild genome from Armenia. And this doesn't appear to be a diachronic signal, which was what I first thought anyway. Radiocarbon dates put the entire kind of population roughly, roughly within the sites in habitation of roughly 8,200 to 7,600 cal BC. So this doesn't appear to be a diachronic effect. They seem to be contemporaneous. And then putting their genomes kind of in a phylogenetic tree-like context, what we see is that the two groups are kind of basal to all ancient and modern domestic goat variation. With the main group, the larger group, being more similar to kind of all later ancient and modern domestics, whereas the wild-like group kind of are a bit more basal. They're getting closer to the wild Bezoar ibex. So this kind of fits with a very simple single kind of domestication branch model, though it is a bit more complicated than that. When you kind of allow for admixture between different parts of the domestic goat family tree, what we see is that, yes, the kind of Zagros goat are kind of basal to domestic ancestry, but there is kind of a mosaic of ancestry of contributions. So European goat, even as far as kind of the Neolithic 8000 BP, they have ancestry that's specific to Anatolian wild Bezoar. So their ancestry is a mosaic of both of this kind of Zagros ancestry, then also this Anatolian wild ancestry. And so we wanted to ask then if we do see, we think we have these two clusters of kind of domestic-like and wild-like goat. And if we have metric evidence of management at the site, might we have genomic signals of management, even though they're morphologically wild-like? So what we attempted to do was look for signals of inbreeding. So this is looking for what's called runs of homozygosity. They're chunks of the genome that show no genetic diversity between the two chromosomal copies. They usually represent kin breeding. So particularly long chunks represent close kin breeding. And when we did this for our Ganj rat genomes, and here's 2 samples and 3 chromosomes of these 2 samples, what we can see is clear regions where there's no genetic diversity for one of the particular genomes. So that would be inherited from a recent common ancestor. And looking at the bottom part of this plot, when we do that for all of the ancient and modern genomes, what we see is that 2 of the 4 genomes from kind of Neolithic Zagros, and that we could do this for, they show quite a bit of a proportion falling in this long runs of homozygosity. And that's relative to pre-domestic wild genomes from Turkey. And also it's kind of an interesting contrast to just the general genetic diversity that we find in these goat genomes. So this is looking at heterozygosity, and the Ganj goat in this case do show quite high genetic diversity in comparison to ancient domestic goat from Neolithic East Iran and Serbia, pre-pottery. So it appears that goat remain genetically diverse at this point at 8,000 KBC prior to the removal from their kind of native range. And then when they're brought to the further extremes of the Neolithic, you start to see a decrease of genetic diversity. Just looking at the kind of mitochondrial and Y chromosomes, where that could be affected by management practices as well. So the top plot is mitochondria, colored by different lineages. And what we see at the 2 sites is we see a full range of the mitochondria haplotypes that are observed in domestic goat. And in comparison, there's only 1 lineage of Y chromosomes that we see at the sites, which does suggest that the different the sex-specific survivorship patterns is affecting male and female specific genetic diversity at this stage. And so this is kind of interesting when we look at the broader Neolithic picture, where kind of eastern and western edges of the Neolithic, you see a segregation of the mitochondrial haplotypes, whereas in the Zagros of this period, we see the kind of full complement, though we don't know how hunting might be affecting this. In comparison, in the post-Neolithic periods, you see this kind of rise of haplogroup A, which now dominates modern goat. And what's interesting is that this in domestic goat, the rise of this haplogroup is associated with 2 selected genes, STIM1 and MUX6. And while when we investigated for selective signals in our Zagros goat, we didn't necessarily find strong evidence of selection. We could investigate these 2 genes. And what we find is for MUX6, we don't find evidence for the variant that is later selected, but STIM1, we do see the variant is present. And that's associated with neurological or behavioral effects, possibly related to timidity. And that suggests that this kind of variation that's later selected in domestic goat is already present in the Zagros goat. And I thought I'd just take this opportunity to kind of do a quick run through of what we know about ancient kind of Iranian goat genetics now. So I've just gone back to the PCA and just highlighted some kind of some sites that we've been talking about. So at Sangi Shamak, at the west and east mound, we do see domestic goat already kind of at that at the late 8th millennium BC. And at Manjukli Tepe as well, in the late Neolithic period, we do see they show affinity with Eastman Sangye Chekmak goat. These are some more lower coverage sample, low confidence. We do see haplogroup A starts to appear. This is Ramatabad, Dari Balegi, and some other sites, but they're unfortunately the genomes are kind of low coverage at this point. At Manjukli Tepe, Mianrud, and Tila Bulak in Uzbekistan, you start to see greater A frequency and a kind of shift towards Western affinities to a greater extent than kind of in Sohachai Tepe, Tepe Hasanu, Shizar, and then medieval Dara-e Balegi, more Western affinity, and then kind of culminating in, Iranian Azerbaijan, Tepe Hasanlu, and then Georgia as well, high haplogroup A frequency, and then just general genome-wide affinity to modern Iran Iranian goats. How does this compare to what we know about ancient Iranian humans? Well, as of 2019, we really didn't know that much. We know about the ancient farmers from the Zagros at Tepe Abdolazin and Ganj Dara. There is, I believe, one genome from the Chalcolithic Zagros at Sekabi, which is a mixture of Iranian and Anatolian ancestries, but there's still a lot we don't know about Iranian human ancient genetics. What about sheep? The metric analysis don't show the same kind of drop off in survivorship in sheep when you compare to goats. We do have a single sheep genome from Ganj Dara. It shows clear affinity to wild sheep. So it does appear that in this regard, the genetics and archaeological results line up as well. And I just thought as well, I'd mention the kind of recent Obishir results, which reported domestic sheep at Obishir, roughly at the top end of the 6 million KBC. Just kind of review what we know about goat and sheep now. So domestic light goats in the Zagros, 8,200 to 7,600 KBC. Sangye Chekmak in the West and East Mend, we see domestic goat. There's probably domestic sheep as well at Sangye Chekmak, and there's definitely domestic goat at Manjuli Tepe in the Neolithic period. And so that we can kind of begin to trace out this kind of spread of managed populations in the kind of Eastern wing. So I wanted to end with a general, this is kind of beating our own chest. This is a nice example of how archaeozoology and genomics inform each other, that we have this evidence of management and linking it to the genomic genomic indications of management as well, with inbreeding and the Y and mitochondrial results. But I actually wanted to just take a minute to say that I've also learned from this a fair bit from this conference, and it's given me things to talk about. So to think about. So the title of our paper was herded and hunted goat genomes. And really from the conversations from the kind of first day, it really got me thinking about how limited the term is when we think of it as from our modern perspective and what it might be in the past, and how important this the paper might be for creating testable questions that can be assessed with different kind of data type. So if these really are herded or hunted or some version of that, how can we test this a bit further? So genomes from Epiopaleolithic or earlier Neolithic sites that don't show metric evidence for management, what are their genomes like? Are these less frequently present? Are they being butchered elsewhere? Could you have isotopic evidence of dietary differences between the two groups? Maybe if you had genetic data, could there be oral microbiome differences? Maybe ritual placement of animals might change through time. Maybe there's evidence of work lithics or butchery. If we have genetic evidence of kind of herding effects, husbandry effects, is there evidence of pathologies to go with it? Is there archaeological indications of inbreeding or higher population densities? How might the spread of Western affinity, how might that be detected otherwise? Obsidian indicating interactions between Eastern Anatolia and Iraq, sulfur isotopes. and what kind of role do the western and lowland parts of the hilly flanks of kind of the Zagros, kind of how does that fit with goat genomics and goat management as well in general. So I'll end the talk, but just thanks everyone for their attention and collaboration.
Thank you very much, Kevin, for the talk. Really some interesting discussion points and ideas there at the end that we can hopefully pick up later today or tomorrow. But running a little bit behind schedule now, so we're gonna take a break for lunch now, or breakfast if you're, or dinner, depending on where you are. Since we're sort of a little bit late, I guess we're going to start maybe at 1:10 Copenhagen time. So just a little bit, 10 minutes behind schedule on the other end. So we have about 50 minutes for lunch now. Thank you very much, and see you in a little while.
چی من نیسته؟ لانچ. او خب خیلی خوبه. لانچ که بازو یک ساعت دیگه
ساعت لانچ بازو من کارا رو
مامان نکن. برو اول دستتو بشور میارم برات. من الان میارم برات مامان. شما برو دستتو بشور. بیا من میارم. آره دستتو بشور. من میام با سلام خوبی؟ سر کن. من میتونم از این کی نهارشون تموم میشه؟ من از اینجا میتونم. نه چرا این کار رو انجام میدی؟ بذار سرا. همینجا هیچ کاری نکن. الان مامان چرا این دفعه فیل کردی؟ این دفعه فیل کردی من که نمیتونم.
I don't know.
When the dust cleared, the back half of the building, or back 2/3 of the building was gone. The moment of the collapse. Capturing this time lapse from the nearby St. Regis Hotel. Basically, the fire department knocked on the door and said we need to evacuate. So we just got the stuff together. Certified accessible homes a lot of older residents and older buildings, just like this one. I spoke to the man, like works inside. She's a nurse. She cares for the older residents here. She called him Frank. The 3 units next to her were gone. They came crashing down. After about 3 hours, she was finally rescued. Thankfully,
You're going on your thing. I forgot.
Anyway, listen to this one.
Hello, everyone. Welcome back. Hope you had some time for lunch or coffee or breakfast or dinner, whichever your time zone demands. So yeah, welcome back to the afternoon session, where we will continue talking about animals and fauna. And the first talk will be by Pernille Bangsgaard and Lisa Yeomans, both from the University of Copenhagen, of course, talking about wild fauna at the Neolithic sites of Asyap and Gamshtare.
Thank you, Tobias. Let me just share my screen. I hope that's visible to everybody. Yes. Good. Okay. So hello, everybody. I should just start out, as Tobias also mentioned, that this is a collective work by my colleague Lisa Yeomans and myself. And also, of course, that it's based on the work of the entire tech team. So can I shift? Interesting. That doesn't seem to be working. There we go. Okay, so as both Asyap and Gantidari have already been mentioned quite a few times in the last few days, I won't spend time sort of presenting the site itself in any details or sort of the general results, but just simply mention that, of course, the things that I will present today is from the new excavations, from the recent tech excavations, and but of course also I will compare these new results to the results from the early analysis from the old excavations. So unlike most of the other results from the excavations, the early excavations at Asyap and Gantidari, the faunal remains was in fact originally published in its entirety and has also since, of course, been published in multiple publications, notably, of course, the articles by Melinda Seder on the domestication of goats, and also that has been a general focus on the faunal collections, where Asyap, you might say, represents the wild goat or the bezoar immediately before the process of genetic isolation begins, and Gantidari, of course, representing the immediate after. So, but this is not what I'm going to talk about today. Instead, I want to focus on all the other bones. In fact, or more specifically, I will concentrate on the wild fauna, with the exception, of course, of the microfauna, which Paul Clarkson will be speaking about, I think, in 2 lectures' time. So I will start briefly by just going over the general results, pinpointing a couple of results, and then I want to focus on a specific aspect of these finds, namely the occurrence of these intentionally placed deposits of faunal remains that we have identified at both sites. So, so first we begin here with the full list of the new faunal evidence from Asyap. This includes remains from 4 separate phases. All of these are found in Area 3. I should say Area 3 is also the location of this semi-subterranean building. That's the primary building at Asyap, the one we found. The results of interest here is the phases 3 and 4, which represents the in situ early Neolithic remains. So phase 4 is the construction and immediate use of the building, and phase 3 is sort of the initial infill, which is also from that period. So we'll sort of concentrate on that. In total, though, the entire collection includes nearly 7,800 fragments, but excluding both the later remains, all the unidentified fragments, as well as the microfauna, which was in the initial count, we are left with just over 1,600 bones. As such, it's not a super large collection, but it does represent a substantial sort of addition to the previous study, which I believe is of a similar amount of bones. So what we see here is a comparison of the results from our new analysis of phases 3 and 4 exclusively, but not with the pit included, I'll get back to that in a while, but in order not to skew the results massively, because it's a very special context, it's not included here. If we look at this, and of course the study carried out by Buchenau from the original, that is the one seen by in a dark gray, you might say, and the new results are the black. Overall, I mean, there is some variation occurs, for example, in the number of tortoise remains, as you see on your right, I think. Overall, there is also clearly some similarities in the distribution of species. The caprines, again, clearly dominates. These are supplemented by the trapping of or capture of various hunting of various animals, hares, foxes, other small carnivores, and also some birds and fish. The fish is freshwater and are likely from a nearby river, very close to the site. I don't have a final species list due to a lack of a full comparative collection, but definitely freshwater. So the caprine remains are mainly goat, as you see here, with some sheep. The distribution is about 2 goats to 1 sheep, you might say, and also a few gazelles. The goats, as well as the sheep, clearly represent wild animals. There's no documented change in the general size and horn core morphology. Fits well with the earlier results. Due to the limited amount of remains, an actual mortality profile is a bit difficult, but as you can see here at the bottom, we have the fusion data, and this also suggests that it was probable hunting of prime age adults, as you have very little unfused remains. Another point is we have some bird remains. It is very limited. Again, it's a small collection, but as you see here, it was possible to identify some of them. And here, Anatidae are the most common group or family, but it also includes a few Phasanidae bones. Based on the size and morphology of this first group, so the Anatidae, this represents medium to small size ducks. And the Phasanidae, again, it was too fragmented to put a species on, but based on the size and morphology, the likely identification is the chukar, but there are some other species of a similar size, so we don't want to say that definitely. But another interesting fact is that if you look at the distribution of the bones, we've taken out a sort of representative bones from the body, from the upper and lower wing and leg. And this very limited evidence, and it is very limited, I have to say, does suggest that there is a focus or a slight over-representation of bones from the wing. But due to the sample size, this could also be a byproduct simply of that. So if we move on to Gantidare, here again, this is the full list of identified species at the site from the new excavation. And this list is substantially shorter than the one compared to the Smith collection, so the old excavations. But it's also a much smaller collection of bones. The Smith excavation, as far as I remember, is around 60 or close to 60,000. This new collection, we have a total number of bones around 12,000, but that is including everything. And again, bringing it down to identifiable fragments, non-microfauna, etc., we come to 2,500. So overall, the collection is very similar, or distribution is very similar to the results by Hess, who identified and analyzed the original collection. It is represented here according to phase. So what you're seeing for each of the species is first Hess's result from the level E, then the results from the new excavation from the same level, and then Hess level D findings, and then our comparable results, and so on. Clearly, again, the caprines dominate the collection, and much more so than we've seen at ASIAP. If we take a closer look at those, clearly the goats, which we now know are genetically separated and managed, are overwhelming the large group of these finds, but we also find the odd mouflon and also a few gazelles. In the figure below, you'll see a real spike in the presence of mouflon at A9, which is part of the old level D, I should say. And we will just get back to that in a minute. So if we turn to the birds or the avifauna, a few more species are represented here compared to Asyap. There's still a couple of ducks, but again, the overwhelming majority of the bones come from the Phasanidae and more specifically the chukar. The second line is what is presumably chukar. This is Phasanidae bones, but they were too fragmented or did not have the diagnostic traits that we could identify securely to chukar. But based on no other Phasanidae of a similar size or species have been identified, in all likelihood, these remains are also from chukar. And if we look at the representation, or the representation of, again, the same bones, representing sternum, the body, of course, and then the upper and lower part of the wing, upper and lower part of the leg, it is very clear here, and also with a substantial larger amount of bones, that we have an overrepresentation of particularly the lower wing, seen here by this carpometacarpus bone. So if we just return to Asyap and this large semi-subterranean building, which was re-excavated in 2016 and then extended with a further trench, located inside what was actually the old trench and circled here in red and again pointed out with a red arrow. A pit was discovered of around a meter and I think half a meter deep, and located quite centrally in the structure. Inside the pit was a massive bone, and the content had to be taken up in a block, particularly because the preservation was not the best. When it was excavated, the content primarily consisted of very fragmented skulls and mandibles of wild boar. Based on the zoning, registration of zoning we did, there were a total of 19 wild boars in there. At the very bottom of the pit, and centrally located, there were a single brown bear skull, large male, and also fragments of red deer antlers, which was found in the fill of the pit, along with some postcranial bones from pig. The results of this analysis have already been published, you see below, so I won't go into all the details of that find, but just mention that the remains fall clearly within the range of wild boar, which we can see here based on the measurements of the molars. Here you see them from the third and the second molar, where it's compared to measurements from a series of other sites, and with known wild and domesticated specimens. So this is clearly indicative of the Asyap wild pig, or pig being wild boar, and they don't appear to have undergone any kind of size change relating to domestication. This is also sort of fits well with the kill-off profile, which is based on tooth eruption. Asyap is here seen in black, and again compared to a few other sites where it falls similarly to what we've seen from sites with wild boars, whereas the probable domesticated pigs from Helanchemi, that is the light gray, is clearly with a slightly different profile. So, but the wild boar pit was not the only intentional deposits of fauna that we find inside the semi-subterranean building. One of the most notable of these other ones is that this wild goat horncore that you see on your, I think it's on your right, in the right hand corner at the bottom. It was placed on the floor, surface on top of the floor, in what appears to be a sort of a slight depression. And clearly, as you can see here, it's surrounded by ochre. Other similar finds include large sections of red deer antler, and also both more wild goat and wild sheep horncores. These were found both on the floor, on top of this plinth or bench, and also inside both the structure of the bench and the walls. So if we move to Gantidari, a further, a number of or several deposits were found also during the new excavation, and I'll just mention some of them here, a few of them. But I also just want to mention a particular find from the Smith excavation, namely these mouflon skulls of Bucania that were found attached to the plastered interior of a small niche. Unfortunately, we rarely had the same stunning preservation of the faunal remains. But in level D, there were examples of deposits found on the floor. Here you see a cluster of red deer antler. In total, there could have been as many as 3, and clearly it had been burnt. They had been burnt along with everything else from this level, making them very fragile. I should also say there's no indication of them being thrown, so they are likely the results of hunting and not just collection or collecting. Another example, also from level D, is this deposit that we found inside the southern bin. Again, everything has been severely burnt, and from the location and intentional placement, or the location of the bone internally, we believe that they dropped down into the bin, probably during the fire and the collapse of the building. You could speculate, based on the proximity and the orientation, or the same orientation of the skulls, that they had in fact originally been placed either on a wall similar to the Smith find, or perhaps on a bench or something similarly above. This deposit included the Bucania, or the skulls of 12 wild sheep, all with very substantial horn cores, along with the remains, suggesting the presence of 9 chukar wings, along with a single duck wing. And then we had some bones from hare, which could suggest the feet of the hare, from up to 2 individuals, or minimal 2 individuals. But the later did also include a couple of other fragments. So that's a little bit more, or it's a bit less clear, you could say. So we also did find examples of these deposits from other levels. Here is from what is comparable to the level A to C, where on a floor we found 3 skulls, again large wild sheep or mouflon, were found in a group together, facing the same direction. Underneath these 3, there were actually a much smaller skull from a goat, and also in among them were the bones from a single Phasanidae wing. They were not complete enough to be identified, but the size is not consistent with a chukar again, but we can't say that definitely. So, and also from this same area, but in this case under the floor, the remains of a nearly complete fetal caprine, likely sheep goat, could be gazelle, or actually it's sheep or goat, we don't know which, was also found. The head is missing, but otherwise it's complete. So we do seem to have a pattern of faunal deposits at both sites. And I should say that by deposits, I mean an intentional placement of fauna or an ensemble of faunal remains that appear orchestrated, that appear to be, clearly stand out from the background of the general scatter of faunal remains. The question is, of course, whether these are very particular or very special in the fact that that we find them. The question is, of course, how much other of this kind of thing there are, which end up in slightly different context where we don't identify them. But that's a whole other discussion. These deposits on both sides include a selection of wild mammals, in some cases combined. We both had the caprines, the wild sheep and goat, the cervets, mainly the red deer, and also wild boar. In some cases, these are combined with bird wings, and in a couple of instances, we do find what is the likely domesticated goat here at Gantidari. which is also present, but in both those two cases, because these are the only two cases so far, they appear to be not very visible. The goat skull was found underneath the others and were not immediately visible. And the other remains, of course, if that was a goat, namely the fetal remains, it was simply buried under the floor. Oops, sorry, that was too soon. And that brings me to the second point, namely that we seem to have a variability in visibility. Most common are the deposits on display, whether on floors, on walls, or on benches, or anything in between. The bones included in this, I would suggest to be best described as signature bones. So, and by that I mean bones or body parts that are visually very representative of a species, or perhaps of that species is thought to represent, or similar along that line. So we have the large antlers of male red deer, the skull with very large horncores of, again, probable male mouflon, and then we have the wings of the bird, which again is a very visible sign of what birds are able to do, namely fly. Then we have the non-visible deposits that are buried inside structures, and these appear to include a more diverse set of bones. So there's still example of what I would refer to maybe as signature bones, but also of near complete bodies, remains that appear to represent either food or feasting activities, as we see at Asyap, or the fetal remains, complete body underneath the floor. So in other words, I think that a focus on and more work on this kind of deposits, and also attention to actually trying to identify them. What is it that sets them apart? So that we might be able to clearly see whether this is something that only found in these very special sort of context, separated context, closed off context in some cases, or whether it's a more widespread phenomenon that we might need to be aware of, could be placed elsewhere. But such a focus might provide some new insight into the beliefs and the mindsets of these communities. And with that, I think I'll stop my presentation and stop sharing.
Thank you very much, Pernille. Okay, we're exactly on time now for your paper. There are two questions in the chat. And Melinda has a hand up. Melinda, maybe you can make a very quick question or comments.
Mostly a comment. It's interesting to note that the species that are displayed at Ganjare, the sheep, and then in these kind of deposits, and in a much earlier site at Zawi Kemi, it's a pit with big goat skulls. But in each case, the animal that's displayed is the less well-occupied animal in the overall assemblage. So it's showing the difference between sort of the symbolic importance put on certain species and the dietary importance on species, and they don't necessarily match. As a matter of fact, they're sort of opposite.
Thank you. Yeah, interesting.
Yeah, exactly. That is super interesting.
Pernille or Lisa, yeah, maybe Pernille, you can respond to the questions in the chat by Kevin and Roger. Okay, thank you very much. And then we move on to the next speaker, which is Lisa Yeomans and Pernille. So not Pernille and Lisa, but Lisa and Pernille. And the topic of this talk is perinatal remains of livestock at Neolithic sites, Ganjare and the development of ovicaprine herding in Southwest Asia.
Okay, can you see okay?
Yeah, we're fine.
Okay, so just continuing on from the work that Pernille has already presented, I just wanted to talk a little bit about one aspect of the faunal assemblage that we found particularly interesting at the site of Ganjare, and that was the presence of perinatal remains of livestock at the site. So as has been mentioned many times so far in this conference, there are problems with identifying the early stages of domestication. The morphology of bones, as discussed by Melinda, is not doesn't change so rapidly. Perhaps there are new methods coming online with geometric morphometrics, but there are going to be problems with having enough data and the same person always taking the photographs or creating the 3D models. And then mortality profiles, whilst they're really, really useful, they do require quite a large sample size to be able to create the mortality profiles. And what I was kind of interested in is what other evidence we have for the presence of livestock at the site itself, whether the animals were actually brought into the settlement, so they were actually living around the humans. So Golnaz has already mentioned this yesterday. We have evidence for the presence of animal dung, and based on the other evidence that I'll go on to in a minute, this probably suggests that the domesticated goats were living at least some of the time within the settlement. And so you've seen this image before as well, which is the hoof prints that were left impressed in a mud brick as it was drying before it had probably been put into a wall. A similar one was published by Cram in 1984, so that they were found during the original excavations as well. So there is some other evidence for the presence of the domesticated goats within the settlement as well. We have a couple of cases where there's a shed deciduous tooth. So here you can see upper deciduous premolars, and you can see they're very heavily worn, with the enamel infundibular in the center of the tooth more or less gone in one of them and completely gone in the other one. And you can see the roots have been resorbed, so this would have allowed the tooth to then fall out of the jaw. So it's basically the milk tooth of the animal. And whilst it could have been an animal that was just about to lose its deciduous tooth, it's probably from actually probably fell from an animal's mouth as it was living on the settlement. And then we also have quite a high frequency of bones of perinatal livestock on the site as well. So Pernille's already showed this, but I was just going to say that I'm only going to focus on the presence of neonatal and perinatal bones, because that was one aspect that particularly interested me. And I really enjoyed the talk by Robin earlier. And so some of the points that he brought up and the comments that Linda made about that was what I'm going to try and cover a bit in this paper. So there's been a couple of methodological improvements on the identification of fetal remains to different ages. I used the methodology of Martin quite a lot in the work. And when me and Pernille were looking at the material, we compared it to known goats of known age in the reference collection. Just after I finished the work and submitted the paper, there's a paper was published by Nadia Polath looking at aging the fetal and neonatal sheep from a Shuklavik. But unfortunately, maybe I might have to revisit my work now. This paper's just come out. So this is just a table showing all of the perinatal livestock that were identified from the new excavations. And just in our attempts to try and age them more specifically, I'll just go through the methodology that Martin applied and explain a bit about how we try to identify them. So the average gestation period for goats is around 150 days or about 5 months, but primary ossification doesn't occur until into the 3rd month of life. So we're not going to get any remains of fetuses that died very young during the gestation. She assigned 3 ages to the fetuses. Those that are towards the end of the 3rd or in the start of the 4th gestational month. Those that are in the latter part of the 4th gestational month, and those that are in the 5th gestational month. And so I used her methodology, and we tried to age as best we could the perinatal remains. So this is just a few examples. These are three right metatarsals from the new excavations at Ganjdari, increasing in age from left to right. We suggested an age of fetal age one or two with the first one, probably 2 for the second one, and the fused metatarsals, the two bones the metatarsal 3 and 4 that are fused around the time of birth. So this suggests that the third one is probably from a neonate. And just a few more examples. And this is mainly based on the morphology of the bones and how formed the different articulations are. But it looks like from left to right, there's a stage 3 fetal calcaneus, a calcaneus probably of a neonatal, and then the one on the right, we just left it as a fetal calcaneus. We didn't try and age it any further, we weren't sure. So we did try and only stick to the more broad age categories if we weren't sure of the age. So looking at the distribution of the ages, perinatal just refers to neonatal or fetal, and we were unsure. But there is quite a high proportion of the remains died as fetuses as well, which is quite interesting, especially after listening to Robin's paper earlier. So there's quite a lot of data on the cause of death in modern pastoral communities. So for example, in Aldemy, a study of just over 8,000 female goats in Jordan, he found that 3.3% of the females aborted and 1.2% had stillbirths. And the majority of the abortions that occurred in the last month of gestation was usually as a result of infectious diseases. There were other causes as well, such as stress, possibly if the mother had been attacked by a wild animal, and the ingestion of toxic plants. But for a large part, a lot of the aborted fetuses was a result of various forms of infectious diseases. Other studies looking at the death rates in the neonatal age, just after the birth. There's a whole bunch of papers producing different figures, but there's one example. About 5.1% in India showed death in the first couple of weeks of life. And things like the birth weight, poor weather, and the maternal instinct of the mother were all contributing factors to death just after birth. So there's various reasons why humans might want to keep the livestock around the settlement. They'll be protecting them from wild predators, they provide more control over their breeding, and there'll be, here you can see the animals, often the newborn and sick, are often kept close to the human settlements as well. So I got quite interested in trying to look at the evidence across the region of Southwest Asia, where there was evidence for the penning of animals on site, and then the possible evidence for the penning of animals through the dung, although as Goran has mentioned, some of this might have been dung from wild animals that was collected, and then the presence of perinatal caprine bones and shed deciduous teeth. And so I'll try and go through this quite quickly, but there was some of the really good evidence was from a Shuklavuyuk. Initially, Boyden House in 1998 looked at the original material from the excavations and identified 749 fetal bones. From his descriptions, it might be that some of these were also neonatal, but he just wrote them down as fetal. And this forms 4.5% of the assemblage. Mary Steiner in 2014 looked at more material from the site and found both fetal and neonatal caprines, forming about 3.7% of the caprine assemblage at that site. Evidence for penning at the site was published in 2019. A paper by Abel et al. Looked at the evidence for increasing urine salts through the sequence and suggested that this increase was greater than would be expected just by the human population density increase at the site. And then, as I mentioned before, there's been new work done on the aging of the fetal sheep remains, just published by Naja Polath, And she suggested that that late gestational, perinatal, and the first week of life was the most lethal time for the managed sheep at the site. And then at Çatalhöyük, work by Nerissa Russell and Louise Martin, they identified 257 perinatal caprine bones, and these formed 1.6% of the identified caprine assemblages and included 36 fetal bones. And then they also identified the presence of shed deciduous teeth, and animal pens at the site were identified through the presence of hearths and middens that included spiracules, and that was work done by Wendy Matthews. At Inabasha, there was evidence in the late Neolithic of fetal caprines, and also evidence for burnt reeds and the phytoliths, and they're suggesting that the animal dung was probably burnt to reduce the spread of infectious diseases. At China, again, the presence of animal dung suggested that there were animals penned at or close to the site. Which we'll probably go through these a bit quicker. Again, secondary evidence of animal dung at other sites in the region. And at Tel Halula, in the middle PPMB, there was some fetal and neonatal caprines, but the exact number was not published. Tel Sabiabiad, again, there was no exact number, but it did mention, the report did mention a high frequency of neonates in level A2, and 2 fetal sheep bones were identified in the pre-pottery or Neolithic layers here. So then moving on to the Eastern Fertile Crescent, the evidence I've already mentioned from Ganj Dareh, and then evidence for penning has been identified at Sheikiabad, at Chokabonut. Reading in 2003 published a report that said there was a small number of neonates present. At Haji Farouz, the report by Meadow in 1983 described 7.1% of the caprine bones were neonatal. And then at Jani, Matthews et al. Published evidence of burnt ruminant dung as well. On Cyprus, the only evidence seems to be, that I can find, was evidence of large circular structures interpreted as enclosures for herds of animals. And then moving to the southern Levant, there's the Locus 20 at the middle PPMB site of Ain Nabu Nakela. There was evidence for spiracules here, but again, these might not necessarily indicate the presence of penned animals. These could have been collected dung. The work by Pinella, she identified 8 fetal and 41 neonatal bones. And then the work done by Louise Martin on late Neolithic sites in eastern Jordan also identified the presence of neonatal caprines as well. But what I thought was quite interesting was the lack of evidence for either penning or published evidence for the presence of neonates or perinates from the many middle PPMB and later Neolithic sites in the southern Levant. So I wondered whether this was partly a result of preservation biases, because we do know that the region is the collagen doesn't preserve so well in this region, so that might have affected preservation. I also wondered if it was something to do with the presence of the building material used in the construction of the architecture. Within Anatolia and the Eastern Fertile Crescent, there's more use of mud brick as opposed to stone architecture, and if this had some influence, or if there was some different method of herding practices where the animals weren't brought into the settlements in the same way that they were in other regions of Southwest Asia. So, looking through the published data, you can see there's a few sites that actually have the details published about the number of animals that they died in the various phases of life, either as fetuses or as neonates. And so this is one of the aspects that I wanted to bring up in this paper, was to try and encourage people to publish this data. I spent a lot of time looking through evidence from site reports in the southern Levant, and this data is not published. And I don't know if it's because it's just it's not considered as important or it's not present. So I just think it should make a point. We should try and publish this evidence and make a point of when there is no evidence for perinatal remains at livestock. It would be good for us to know. So overall, I'd like to try and address this question more, but about whether there are different practices in terms of the herding and pastoral economies of the region, where there's a different practice of bringing the caprides into the settlements. But the probability of answering this question is not possible at the minute because of geographical differences. And I don't know if this is preservational differences or also methodological differences. A lot of the work that's been done on identifying the presence of dung has also been concentrated in Anatolia and in the Eastern Fertile Crescent, whereas opposed to very limited evidence in the Southern Levant. So that was another point. So I would quite like to see the expansion of the techniques developed by Wendy Matthews and others to other Neolithic sites in the Southern Levant as well. And me and Peter have been discussing with Kevin the idea of looking at the DNA from the perinatal remains that we have from Ganj Dareh to see if there's any evidence of transmissible diseases that we picked up in the DNA. So, yeah, that's everything. Thank you.
Thank you, Lisa and Pernilla. Fascinating stuff. Maybe we have time for one comment or question. Yes, Melinda.
Sorry to be so chatty, but I'm awake now, so you'll have to deal with it. Just another example of perinatal remains is, but in a different kind of cast. We have a huge number of remains from pigs at Halanchemi. In the final levels of the site, they are selected limb bones that preserve their 50% of the overall limb bones, of a very high percentage of Sus in general. In this case, however, they are very restricted in size, and the best I can figure is that they are newborns. And so it's within a couple weeks of birth. So I think in this case, what they're doing is actually going out and harvesting newborn litters, which in pigs is something that can actually spur the females to come back into estrus. We call it sort of a pig pump hypothesis. And these may be wild harvesting, but the perinatal remains, I think, are fascinating about all sorts of different practices and need more attention. I also think actually on the pigs, the Bonchukwu material also shows a huge amount of very young animals. I don't know if it's as restricted in age, but let's hear it for the babies.
Thank you, Melinda. Okay, great. Then I think we're going to move on to our next speaker, which is Paul Clarkson. Paul wants to turn on his camera. There you are. Okay, I can see you now. Great. Welcome, and thank you very much. Paul will be talking about Jute, Mouse, Vole, and Shrew, the tale of an early Neolithic settlement.
Yeah, I'm just trying to get the slideshow to run.
Yeah, sure.
Not quite sure why I'm not being able to do that. Oh, that's better.
Yep.
Okay. Okay, thank you. Good afternoon, everyone, and good morning to Melinda. I just wanted to very quickly run through the microfauna from Ganj Dareh, which was kindly sent to me for analysis for my PhD. I entitled this Jerd, Vole, Mouse and Shrew, but we've got here the Jerd and the Vole, but actually it's really a tale of two taxa, which is the mouse and the shrew. And as you'll see when we go through this, that's quite significant. I'm sure by now, are all familiar with Ganj Dareh and the area, but I just wanted to, in case someone wasn't, explain that this is already been excavated, and a report on the microfauna, quite a famous one from microfauna specialists, was done by Hess in '79. Hess calculated a ratio of mus musculus remains to ovis capra, and he then came up with these figures from earliest to latest levels, and this indicated to him that there was a jump from level E, which he believed to be pre-sedentary, to level D, which he thought indicated the beginnings of sedentary occupation, due as well to the fact that it was accompanied by archaeological evidence for building. So he suggested that a rise in the proportion of commensal signaled the beginning of year-round sedentary occupation. Just to compare what we found with what Hess found, this Hess identified in his article 874 specimens of rodent, of which the majority, all but 16%, were mus musculus, and the others were identified as the mole, vole, and the Jerd. He doesn't make any mention of other microfauna. Our analysis comes up with a wider interpretation, in fact, a different interpretation, in fact, a different identification method. And this is because the method has changed, and we took a more conservative view of identifying the microfauna. We include all microphones, so there are some snake, some frog, well, anura, should we say, but you'll notice that we also have rodent and micromammal in here, and this is because our identification focused on different diagnostic values for different elements. So for micromammal, where you have available teeth, then you can assess to a much lower level, or higher level, I should say, really, of identification. So you can identify to family, to genus, and possibly to species if you use GMM. Amphibian, the majority would be identified by ilia, but that's a little more difficult, particularly without GMM. Now, I wanted to include this because it actually goes to explain why so many more specimens were identified by Hess to particular species and genus than we have. However, what you will see as you come on to the next slide is that we have to make assumptions about what this actually means. So this is our analysis and recording of the microfauna taxa, and what I've got down the side is, of course, the taxonomic classes. So for mus, that's primarily mandibles and maxilla, and postcranial bones are identified as rodent, simply because of the difficulty of trying to differentiate these from other rodents, small rodents of the same size. And vertebrae were largely classified as micromammal. Again, the problem of differentiating vertebra between rodent and insectivore. However, this table shows the taxa by phase, and I just wanted to put the whole lot in here. So you've got trench A, from A11 to A1 and AR, which I think means recent. B, which we only had one phase, which was at all productive, and D, again, D7, oldest, to D1, most recent. I wanted first of all to look at the figures I've outlined in yellow, which are those that are generally recognized as non-synanthropic or non-commensal species. And there is no apparent pattern, apart from the fact that there aren't many of them, actually. There's no apparent pattern of change over phases. However, I'd like to point out that if you look at A11, there is something of a pattern that seems to be emerging, where you have a rise both in mus and in rodent and micromammal bones from the oldest up to a sort of peak here. And there might even be the same here in trench D. So what I did was I looked at that and I just graphed it to see if we could find something from that. And this is trench A. It has by far the greatest number of specimens from this trench. And you can see quite clearly that there is I mean, this is an exaggerated scale, but you can see quite clearly that there is a change from the very earliest phase, A11, and that change may be related, and I'm suggesting it may be related to increasing density of building up to point A9 or phase A9, where we know there was an earthquake and fire, which remains of which, or evidence of which, is evident between A9 and A7. There then seems to be some sort of recovery. Now, these are only those taxa which we could regard as commensal or synanthropic. But you can see, interestingly, that the recovery, perhaps in line with rebuilding, and therefore an increasing density of structures, actually peaks before abandonment at A1. So there is a gradual decline at that point. What I wanted to find out was whether, in fact, because this is just raw NISP totals, whether the volume of the environmental samples had an effect. So I then plotted the same phases against NISP per litre. Now, obviously, the two are, one is dependent on the other, but needless to say, you do have roughly the same pattern evolving here. A3 in this case is higher, but the actual pattern remains the same. I then looked at D, which I never expected to find anything like that in, because it has so few specimens were recovered from it. But I still found this double maximum. And again, you've got NISP per litre approximately following the same pattern. I became interested in that, and I thought, well, one of the things that we should do is check that against things that could be a problem. And there are some problems with this interpretation. So first of all, I looked at burnt specimens, and you've got the number of burnt specimens here on the graphs on the left. You'll see that in trench A, it's maximized very dramatically at A9. And in trench D, it's a bit more even, but D6 is again the maximum. So it's worth just quickly going back and seeing that there's archaeological evidence that in D6 and A9, you have fire. And there's plenty of specimens in the assemblage which show some pretty intense temperature change. So I kind of thought, well, this might be interesting to see if we can put together some ideas on this. We now think that Smith's level E was not pre-sedentary, as he assumed it to be, but an external workspace. And that would still fit with the fact that there was a low number of commensals there. But his idea of the proportion of commensals against the proportion of non-commensals didn't quite fit, because the commensals were really the only show in town. There was a gradual rise in the commensal population before the earthquake. Was this because building density and population rose? It wasn't a rapid change, as you could see from Smith's level ED border. The earthquake fire was very clearly had an effect, and the effects of that damage are shown in archaeological site reports as well as on the remains that I found. Then there was a slowish recovery, where you've got to consider in this that mice are mature from 2 to 6 months, so they tend to rapidly evolve. And the question is why that was relatively slow, that increase, why there wasn't a step-up pattern. I suspect that we need to carefully consider whether in fact mice were slower to actually get back into those structures, but that's something that I've been considering. Okay, so the gradual decline occurred well before abandonment. It's worth remembering that phasing itself is not chronological. Well, it's chronological, but it isn't, you know, each phase is not equivalent in time to each other phase. They are structural changes rather than measuring a particular passage of time. But there was a gradual decline. Perhaps that links to increasing external open space as structures fall out of use, for example. I also thought, following Bellmaker and Brand, that I would examine the sampling strategy, and the table on the left is just a summary of the productive contexts, not all of them, but most of them, and the Nispalita, the richest ones are the horn core and external pit fills. But the most productive contexts of all were actually floor deposits or on-floor deposits, and partly because they had quite a good Nispalita, but there were a substantial number of them. And that's shown on the right-hand side by looking at the most productive contexts. You see floors occur quite a lot there. But I would like to point out that walls here were also quite productive in wall contexts. However, just going back to the table on the right, the MNIs are quite small, even with the most productive contexts. They're all under 10, and that indicates that these animals are dying in small numbers or even on their own, which leads me to mortality. A second criticism that could be leveled at that, apart from the sampling one, were there enough samples and were they representative enough? The second criticism is that it could be that there is potentially a large predator accumulation which is influencing the distribution of these through the phases. And so I looked at digestion. These are digested bones and teeth. For trench A, they tend to follow pretty well the same pattern that you saw mirrored in the distribution of Nisp and Nispalita. It's relatively small, but it's still worth remembering that that could mean that this could of course be a single phase when a number of predators were taking small animals and then leaving their remains, but it could also equally be a visiting predator which came all the way through the phases. One of the problems with this was that when you look at molar teeth, digestion is not always easy to spot. So you have light digestion here and abrasion here, easy to mix those two up. So there may be identification problems. And the other problem was then that burnt specimens would be very likely to have their digestion covered, destroyed by the burning. However, the small numbers of individuals in each context, their isolated distribution, the fact that most of the mice seem to be older than 2 months, only one was a young mouse of those that I could age, indicates maybe an occasional visiting predator rather than a predator accumulation. Organic effects also had created some problems for identification. So just briefly, from the work of a number of people, including Darvish and Cookie, this seems to be the general outline of the development of the mouse species, beginning in India and Afghanistan and then diversifying. Now, Cookie, in his article in 2020, indicates that Mus musculus domesticus synanthropized in human settlements in the Levant and Cyprus, but then between 10 and 8,000 years ago, they were diffused into Anatolia, the Taurus and the Zagros, which includes Ganj Dareh. He GMM'd some specimens from the old Ganj Dareh excavations and found that they were in fact domesticus. So the question is, are we seeing here in this distribution in the phases a period when domesticus is actually becoming domesticated? Is this plotting what Cookie actually identified using GMM and aDNA? Just quickly, as in summary, so a rise in the proportion of commensals didn't signal the start of year-round occupation, as Hess believed. They were dominant throughout the phases, assuming that E equates to A, 10, and 11. A reduction in taxonomic richness didn't indicate the start of sedentarism, but it's very clear that low taxonomic diversity shows that it existed. We haven't mentioned Crocodura, but Crocodura were found throughout. Was Crocodura also commensal? There's some papers from modern research which indicates that they are commensal with Mus domesticus. And not quite finally, commensals did track the archaeology of the site. They increased as the settlement grew, collapsed during the earthquake fire, and then grew again. But the gradual decline before site abandonment was an interesting one. Was the key factor density of buildings or population? And at what point in that could we say that Mus became synanthropic as opposed to being a species which is open to commensalism? Is the interpretation limited by sampling and recovery? Yes, I'm afraid so. 857 isn't enough to say with any certainty my suggestions would be correct. And more evidence is needed. We're asking for GMM to be done, and we hope to have that done in the next couple of months. And finally, is the interpretation biased by predator accumulation? Well, I don't think so, not from the evidence that we've seen there of where these animals died. They seem to die alone or in small groups rather than large predator assemblage. And thank you very much indeed for listening.
Okay, thank you very much, Paul. Super fascinating. And just two quick comments. It's interesting that your data seems to track quite interestingly with what Julian presented about the chipped stone analysis from Ganj Dareh, where he had this signal for potentially higher mobility indicated in the level E, which seems to be similar to what you have with a low number of commensals. And then also quite interesting that you may have this a signal for this catastrophic event that we seem to be seeing with the earthquake, that seems to be somehow possibly confirmed by your data. So that's definitely something we should talk about, I guess. But Frank has a comment or a question.
Yes, I think it's a very interesting and intriguing set of analyses. I am, however, somewhat skeptical of the idea that you can place these micro animals in their good context, because as anyone knows who excavates in the Middle East, you have rodent burrows throughout the site. And even at Ali Kosh, we found mice that were active. That is, they were actually bringing things up and down through the 7-meter profile that we had on the side of the site. So they move through the ground rather rapidly, and in some sites they hollow out the profiles of sites very much like a Swiss cheese. So while I think it was a very interesting analysis, I think one shouldn't place too much confidence in the actual context in which the rodent remains were found.
Yeah, I agree with that. And I did find that both the mole vole and the dejurd are burrowing animals. One was found at a very low phase, but the other one was higher up, and certainly they will have had an influence. So sampling and recovery, I'm aware that there are limitations to this suggestion.
Okay. Thank you very much. So we want to keep to the schedule as much as we can. Therefore, we're going to move on now to the next talk. Thank you very much again, Paul. And this will be Michael Gregg, Hassan Fazeli, and Judith Tomalski, the persistence of hunting and gathering and the adoption of Neolithic small blade technologies in the southern Caspian Basin and northern flanks of the Alborz Mountains. And I think there's a recorded talk, but they're, of course, here to answer questions later.
Well, good morning. As you can see, today I'm going to be talking about the persistence of hunting and gathering and the emergence of a Neolithic small blade flint technology at the intersection of the southern coastal plain of the Caspian Sea and the foothills of the Alborz Mountains in northern Iran. This work is done in collaboration with Hassan Fazeli from the University of Tehran and Judith Tomalski from the German Archaeological Institute in Tehran. Now, I'll also be presenting findings from our 2017 excavations at Kalmashana Tepe in northern Iran in context of the Mesolithic and Neolithic occupations of Belt, Hotu, Hilly Tepe, and Kalmashan caves, as well as changes in Caspian sea levels during the terminal Pleistocene and early Holocene. Now, the two caves that you may be most familiar with are Belt and Hotu caves, which were hurriedly excavated by physical anthropologists Carlton Kuhn in 1949 and 1951. The haphazard collection and recording of finds from these sites currently clouds our analysis of prehistoric human behavior during this time period. Kuhn excavated 30 10 to 20 centimeter spits at Belt Cave in a 10-day period in 1949, identifying both Mesolithic and Neolithic horizons, but not distinguishing between aceramic and pottery Neolithic contexts. Kuhn recovered groundstone mortars and pestles from both Mesolithic and Neolithic contexts, as well as Caspian softwares and Jatun and Cheshmiali pottery fragments in Neolithic spits 1 through 7. He also opened up a second trench on the last day of excavation, which yielded a Neolithic single platform core and the saddle cairn that you saw on the previous slide. However, small flint blades were recovered from both Mesolithic and Neolithic contexts throughout the Trench A excavation. In 1951, Kuhn returned to Iran and excavated Hotu Cave to a depth of 12 meters over a 5-week period, uncovering Neolithic and Mesolithic occupations, as well as human remains from the basal levels of the cave at a depth of about 11.5 meters. Kuhn first thought the remains that he found were 75,000 years old, but subsequent radiocarbon dates placed the earliest occupation at the site in the terminal Pleistocene. Genetic analysis of crania from the Mesolithic occupations at Hotu Cave shows that there are affinities to both Paleolithic hunters and gatherers from the Caucasus, as well as Neolithic farmers and herders from the site of Ganj Dareh. But there's no evidence for the admixture with Epipaleolithic or Neolithic groups from the Levant or Anatolia. Charles McBurney's 1964 excavations at Ali Tepe revealed 3 meters of Mesolithic occupations overlain by Iron Age deposits. But unlike Belt and Hoto Cave, there were no aceramic or pottery Neolithic levels found at the site. It was much more carefully excavated and analyzed, but there was no systematic collection of plant remains at any of these cave sites. However, McBurney did compare the frequencies of faunal remains from Belt, Hotu, and Tale Tepe caves, and hypothesized that changes in human predation were driven by the proximity of the Caspian Sea as it approached or receded. Animal bones from these caves suggest that when the coastal plain was narrow, the inhabitants relied on seal, deer, and waterfowl, but as it widened, they consumed auroch, gazelle, sheep, and goat. Now, more recent excavations by Hamid Vahdati Nasab and colleagues at Kalmashan Cave in 2009 revealed looted horizons overlying a highly disturbed aceramic Neolithic context and an in situ Mesolithic context dating between 12,100 to 10,700 calibrated BC. Stefan Kozlowski had previously noted that the Epipaleolithic flint tools of the Caspian caves appeared to be a geographical variant of the Trialetian industry of the Caucasus. However, Mozgan Yayez and Hamid Vahdati Nasab have argued that this industry should be known as the Caspian Mesolithic, based on the absence of obsidian, the absence of tanged narrowheads, and differences in predation apparent between the faunal assemblages of the Caspian caves and the sites from the Caucasus. Now, we had planned to survey the uplands and plains near Kalmashan Cave. However, when road builders exposed a multi-component archaeological site within 150 meters of the cave mouth in 2017, we excavated 3 small trenches on the talus slope north of the cave, which is bisected by the main highway linking the modern cities of Nika and Bashara. Our purpose in excavating was to establish the chronological sequence of occupation of the talus slope, collect botanical and faunal remains, as well as obtain bone and charcoal samples for radiocarbon analysis. Our excavation of Trench 1 revealed a Bronze Age burial and Chalcolithic levels and a colluvial deposit overlying in situ aceramic Neolithic and Mesolithic horizons. Our excavations of an expanded Trench 2 yielded the earliest radiocarbon date for a Mesolithic horizon, which is about 9250 calibrated BC, whereas the latest aceramic horizon in Trench 1 is circa 8250 calibrated BC. Our excavation of Trench 4 north of the highway also revealed a colluvial deposit overlying in situ aceramic and Neolithic and aceramic Neolithic and Mesolithic horizons, and yielded the earliest date for an aceramic Neolithic context, which is circa 8600 calibrated BC. We also excavated a small trench in the nearby uplands, which yielded dense concentrations of flakes, cores, and a limestone current within an alluvial deposit. This stone vessel on the left is from a disturbed context in Trench 1, whereas the pestle on the right is from an in situ Mesolithic context in Trench 2. These groundstone tools were found in an in situ Neolithic context in Trench 4, whereas the bone needle is from a in situ Mesolithic context from Trench 2. We also found an in situ clay basin and a clay wall in an aceramic Neolithic context in Trench 1. The Mesolithic lithic assemblages from Kamashana Tepe are broadly similar to the Caspian Mesolithic industry described by Jayez and Vadati Nasab. Judith Tomalski has recently examined both the Mesolithic and aceramic Neolithic assemblages in Tehran, and I'll be speaking about those in just a minute. But first I'll be talking about our contribution from Kamashama Tepe to a multidisciplinary study which was led by paleontologist Suzanne Leroy, examining the human responses to environmental change on the coastal plain of the Caspian Sea during the Mesolithic and Neolithic periods in northern Iran. This environmental reconstruction was based on analysis of microscopic organisms in two sedimentary cores recovered from the Caspian Sea lagoon near these cave sites. Pollen and charcoal evidence recovered from these cores provided evidence of information on vegetation changes through time, as well as aquatic organisms which attested to the presence or absence of water in these cores, and parasite and fungi which attest to the presence of herbivore dung, which could not have come from a level with water. Analysis of these cores, our analysis of these cores confirmed Charles McBurney's hypothesis that when Caspian sea levels were high, Mesolithic hunters were relying on seal, deer, and waterfowl, but as water levels receded and an extended coastal plain emerged, hunters consumed a different range of herbivorous mammalian species. Our 10 radiocarbon assays from Mesolithic and Neolithic occupations at Kamashana Tepe correspond with lower Caspian sea levels during the early Holocene. The coastal plain adjacent to Kamashana Tepe may have extended hundreds of kilometers northward into the Caspian Sea during what's known as the Mangashilak low stand, which is the area in yellow where our radiocarbon dates in a fall. Whereas the earlier and later deposits from Belt, Hotu, and Ali Tepe caves have evidence for the predation of human predation on seals and radiocarbon ages that correspond to higher Caspian sea levels, which are the areas in blue. Now, the pollen evidence from these cores indicates that there was a relatively benign impact of the younger Dryas in this region. There's a diverse deciduous species which suggest climatic conditions were favorable for human predation on a broad range of plant and animal resources in the neighboring ecological niches adjacent to these cave sites. The botanical and faunal evidence from Kamashana Tepe were examined by Alina Marinova and Robin Bendry, respectively, and these indicate that the process of neolization in the southern Caspian Basin was a gradual, low-cost adaptation with no immediate abandonment of hunting and gathering. Mesolithic groups were targeting sheep, goats, and waterfowl, collecting wild oats, wild barley, legumes, and using groundstone tools as early as 9200 calibrated BC. Whereas Neolithic groups continued to rely on the same suite of wild plant and animal resources for as long as 400 years following the emergence of small flint blades and single platform cores circa 8600 calibrated BC. There's no significant changes in the proportions of plant species associated with the small flint blades and single platform cores that were found in the aceramic Neolithic levels. However, there is a significant shift from a bipolar core reduction strategy, which dominates the Mesolithic horizons at Kamashana Tepe, to a unipolar technique characteristic of Neolithic industries. The proportion of irregular or multi-platform cores is much greater in the Epipaleolithic horizons, but decreases throughout the sequence until being completely replaced by single platform blade cores in the aceramic Neolithic occupations of the site, as can be seen in these two plates by Judith Tomalski from our forthcoming paper. Now, the archaeological, botanical, and faunal remains all suggest that the Mesolithic and Neolithic occupations of the talus slope at Kamashana Tepe straddle Robert Braidwood's eras of the terminal aspect of food collecting and incipient cultivation. However, compelling evidence for the era of primary village farming communities in the southern Caspian Basin has yet to be discovered. But the colluvial deposits uncovered by our excavations at Kamashana Tepe may provide clues for why evidence of fully fledged farming villages have not been found as of yet. Stone tools and architectural elements mixed with colluvial gravels supports the hypothesis that surface runoff or sheet erosion dislodged at least a portion of the slope from its original location, and we suspect that this disruption was caused by a rapid climatic change event that could have halted the process of the neolithization that was already underway in this region. However, large-scale horizontal exposure of the talus slope will be required to test this hypothesis and to support this interpretation. Thank you for your attention, and we welcome your questions and comments and suggestions.
Thank you very much. We have one raised hand here by Sam Walsh. Go ahead.
Hi, I just had a quick question about the human remains from Hotu cave that you mentioned. Because I'm going to be looking at the newly discovered ones, I wondered if the ones that were previously discovered still exist or if they've been lost.
Michael, I think your mic is turned off, your microphone.
Sorry.
That's okay.
I'm very sorry. The human remains are at the University of Pennsylvania Museum in Philadelphia, and we sampled them and we contributed them to the Lazaridis et al. Study as Ganj samples were also studied by the same group. Now. There are additional as far as I'm aware, there are only two skulls or two crania available for genetic analysis at the University of Pennsylvania.
That's great. Thank you.
Okay.
Okay, thank you very much. It's 2:30 now, so we're going to take a slightly shorter break now until 10 to 3 Copenhagen time. So that's about 17 minutes. So just enough time to make some coffee or have a quick sandwich or a snack before we carry on.
We're taking a quick break. They're taking a break.
with the next talk on lithic artifacts, and this is by Mariam Shakoui, Omran Rarazian, and Benjamin Moutin. Lithic industries from the southern Lut Desert, southeastern Iran during the Neolithic period. And it's a recorded talk, just so you know.
Hello everybody, it's my pleasure to be able to present my study on lithic assemblage from a surface survey of Darestan area in the southern Lut Desert. The geographical location of the Dagestan area in southeastern Iran and east of Mam city in southern Lut are permanently affected by the desert landscape. This unusual landscape for the Neolithic settlement, in contrast to Zagros Mountains, almost looked more like hell for archaeologists until recent years. The landscape of prehistoric sites affected by wind erosion is obvious in these pictures. Small mounds that are not recognizable from a distance are well visible in these slides. And also a dried basin of rivers which cover all the plain. A surface survey was carried on through 2016, and as you can see, sites from aceramic to chalcolithic were found. In total, 64 sites were discovered. This chart shows the percent of sites in each period. First of all, the density of chipstone assemblage in each site were mapped. Because of the topography of sites and the desert weather, the strategy of surface survey was not systematic. In the north, center, and southern part of the plain, we have sites with high density besides very low density. For example, less than 5 in number. The separation of sites is based on pottery, as it is a more reliable material in the southeastern part of Iran in comparison to chipstone. Through the 3 periods, there is little difference in technological organization. For example, in the aceramic period, there is a more formal tool and less debitage and core in comparison to pottery, Neolithic, and chalcolithic. In this slide, the density of debitage was shown on the map. Like previous, we have a high and low number of debitage in the north, center, and southern part of Darestan. The number of unused flakes in aceramic in comparison to the other periods is meaningfully higher. I will come back to this point later. Most of the formal tools are in the central and southern part. In aceramic, most formal tools was made on flakes. This situation changed through the Neolithic and completely transformed through chalcolithic. In this chart, the formal tools in the aceramic period are shown. It contains notched and denticulated, urine, scraper, bagged, naturally bagged, and microlig, trapezoid microlig. In pottery Neolithic, we can see an increase in the number of formal tools types. In aceramic, we have 6 types of formal tools, and in pottery Neolithic, we have an increase to 8 types. We have border and crescent type, which we don't have in aceramic. And through the chalcolithic period, we can see a decline to 4 categories of formal tools. Unlike the debitage and formal tool category, we can see a meaningful dispersal of core through the plain. It seems through pottery Neolithic in the northern part of the plain, there is a concentrated and specialized production of bullet cores. They are all exhausted and very small in size. If we added the information of the core tablet to the map of core dispersal, we can see more activity of core rejuvenation in central part where there is a low number of a core. We should keep in mind that maybe all of these analyses might be affected by a surface survey. It should be checked in the future by excavation of these sites. In this chart, it is obvious that in the aceramic period, there is a more flake core and a limited number of blade or bladelet core, especially bullet core. This situation was confirmed already at Tall Atashi, where there is just one bullet core at top layer of Atashi. As we know, Tall Atashi is an aceramic mound. If we accept that in the Neolithic, most characteristic of chipped stone assemblage is the production of bullet core, we can see this pattern in Dagestan. It started at the end of aceramic sites and fully flourished in pottery Neolithic through the plain. As you can see in Atashi, we have all sign of using pressure technique like pre-course, crested blade, and plunged blade. The important point about Atashi is that from excavation, we have just one bullet core at the most top layer, but from the systematic survey around Atashi, we can see more specialized bullet cores, just like what we can see in pottery Neolithic sites in Dagestan area. Keeping in mind the inconsistency of the surface survey, we can propose that after the abandonment of Atashi, the site is still used for the production of chipped stone. This needs more data to be confirmed. Here we can see the chipped stone from the pottery Neolithic of the Dagestan area. We can see blade or bladelet, which produced from the pressure technique, backed pieces, borer, and microlith. And again, a sign of using pressure technique like crescent blade and core tablet, bullet cores in pottery Neolithic sites of Dagestan. Thank you all for your time. At the end, I should emphasize chipped stone study in this area is in its first step. We need more time for comparative analysis with adjacent area. I present here some parts of my PhD thesis, and so thankful to Dr. Omran Garajian and Dr. Mouton and my advisor in University of Mazandaran, Dr. Abbas Nejad. Some part of this presentation is the result of the postdoc thesis of Dr. Jayez. I also thank her so much.
Thank you very much for this presentation. I think the main speaker is here, so if there are any quick comments or questions, we can deal with them now. Okay, I don't see anybody raising their hand.
Just may I ask something? If
yeah, sure, if you want.
Okay. Okay. Okay, thank you very much. I hope you hear me, Dr. Shakwi. Hello? She's not available, I think.
No. So.
Okay, let's move on to the next.
Excuse me, do you have my voice?
Okay.
I have some problem in connection.
Okay, thank you very much for the presentation. I was wondering about the term that you have used in your analysis. Ceramic, as I saw, and Neolithic. So they are a little bit confusing for me. Do you have a specific meaning by using this term? So ceramic is a just earlier part of Neolithic generally.
If I understand your question, you asked me about ceramic typology, yes?
No. The term that you have used is ceramic and Neolithic for your analysis.
Okay, ceramic and pottery Neolithic.
Oh,
yes?
okay. It was Neolithic, not pottery, in the chart that you have shown. Okay, thank you.
Yes, okay. You're welcome.
Okay, thank you very much. Then we move on now to the next speaker, Professor Yoshihiro Nishiaki, tracing the development of the Neolithic lithic industries in the West Zagros. Thank you very much for being with us.
Excuse me.
Yeah. Great.
Good evening. I'm very pleased to have a presentation at this important meeting. In my paper, I'd like to show you what I have learned about Tape Abdul Hussein. I'm sorry. With Iran. This site has been well known over the decades, and in recent years, human bones from this site were subjected to an ancient genetic analysis to investigate population history of the early Neolithic communities. And its faunal remains have also been studied in recent years. Then the site of Tepe Abdul Hussein has again come under the spotlight of research. Nevertheless, in my opinion, the stratigraphy and cultural assemblages of this site have remained unclear. It is not even clear how old this site is. It's a pity because this site is one of the few extensively excavated Neolithic sites in the western part of the Cyprus. I had an opportunity to study the lithic materials of this site several years ago at the National Museum of Iran in Tehran, but have not published the results. So in this presentation, I'd like to take this opportunity to present my preliminary evaluation of this site, mainly from chronological and lithic perspectives. Okay. The site of Abdul Hussein is located in West Iran, which has been a major field for Neolithic investigation. And many of these sites listed in this map have been already mentioned in this course, including Ganjikari and others. In my presentation, I will mention the site of East Chiasabus as well as Abdul Hussein, because I had an opportunity to study the lithics of East Chiasabus, and I think it well, a good opportunity to make comparison of the lithic from East Chiasabus and Abdul Hussein. Okay, first of all, how old is this site? This chronological table was taken from one of the old papers by Hojat Tarafi. I'm sure Hojat has updated this chronological table, but I show it how the site of Tepe Abdul Hussein was interpreted when I started studying the lithic material. So I have no intention to be going to criticize Hojat. Then in this chronological table, Tepe Abdul Hussein has been dated from a period between about 7,500 and 6,000 BC. The site of Abdul Hussein is a small mound with a diameter of about 80 meters, 10 meters high, and Judith Fuller opened several pits of 10 meters side across the mound in 1978. The target of my analysis is the squares on the southern slope indicated by red rectangle. Therefore, I do not consider any Neolithic occupations from other squares in this presentation. The stratigraphic sequence of Tepe Abdul Hussein has not been defined very well. Fuller left very detailed stratigraphic descriptions, but did not provide an integrated cultural sequence for the squares that she excavated. But the stratigraphic descriptions themselves are very detailed and sufficient enough to define periodization for this sequence. So based on the descriptions of Pooler, I have defined 6 architectural levels for these squares, like this. Actually, the stratigraphic division followed her idea. Simply, she did not give a serial number for groups of stratigraphic units. Then Judith Pooler published 6 radiocarbon dates for this site. I examined the context of her samples and discovered that all of them came from the lowest level, level 6, my level 6. The dates, as shown here, the dates range from about 8,500 to 6,000 BC. Obviously too diverse for one level of Neolithic occupations. And we should also mention the dates from human bones for genetic analysis recently published. In my chronology, the samples came from level 5, from the lower part of the site, showing about 8,000 BC. This date seems reliable, but still requires testing with further dates. Therefore, we sampled animal bones from each of our new levels for AMS dating. These are the results. The date from level 2 is an obvious outlier. But besides that one, we can define 2 phases of occupations. The older ones is dated to a period around 8,000 BC, and the upper phase is dated to about 7,500 BC. So the new date placed the occupations of the south trenches of Abdul Hussein in this way. So there should be, can be 2 different phases, and there may be a gap of about 500 years between them. So this is one thing for the first part of my talk. And the second subject of this talk is lithic assemblages from this site. So before we look at the lithic assemblages of Abdul Hussein, let me make an overview of the lithic sequence of East Chiasavus, which is the longest one, overlapping or encompassing the Abdul Hussein phases. Then the data from East Chiasavus is one of the best available for me to study this period. When we studied the material of this site with Hojat Darabi, we noted the period around 8,000 BC was a period of significant changes in lithic industries. There were 3 main changes. One is a rapid increase of pressure debitage. Pressure debitage was already used in the middle of the 9th century, 9th millennium BC, but it was never popular. But it became rapidly popular through time. And the second is a change in the shape of the pressure debitage cores. I'll show in the, I can't point. Anyway, there is a clear trend that cores with bladelet removers on the entire circumference of the core increase through time. Therefore, the diameter of the core are reduced. So-called bullet cores became popular only in the later levels. The third change is concerned with typology. Backed bladelets shown in red bars, quickly decreased in the upper levels, and end scrapers shown in blue bars increased in the later levels. So these changes occurred in a period of transitional to the preparatory Neolithic in the terminology of Mojav's Arabic. So we will see if comparable changes are seen at Abd Hussein. This is a general inventory of the lithic assemblages from southern fringes. About 5,700 specimens were available for study. They include plenty of pressure cores, both partial and circumferential types, including bullet cores. Typical tools of this site include backed plates, lets, secret elements, and end scrapers. I don't see hardly any differences in the tool typology between Abd Hussein and East Chiasados. But what about the temporal changes? In core types, so this is a comparison between these two sites. In core types, we see almost the same pattern at Abd Hussein and East Chiasados. Bullet cores rapidly increased over this period, and the pattern at Abd Hussein is comparable to the upper part of East Chiasados. Actually, bullet cores were present from the oldest level of Abd Hussein already, but they were not present in the oldest level at East Chiasados. And core diameter. The size of the core diameters also show the same pattern, reflecting the increase of bullet cores through time. The Abd Hussein cores do not include big ones like those of the older levels of East Chiasados. The pattern at Abd Hussein again matches that of the upper levels of East Chiasados. And then we see the same for the tool-type comparison. At both sides, backed bladelets sharply decreased and end scrapers increased. So the lithic assemblages from Abd Hussein are best comparable to the upper part of East Chiasados. The results fit with our new radiocarbon dates for this site. It also supports what we discovered at East Chiasados, that is, this is a period of changes in lithic industry, and more or less comparable changes were taking place at different sites in West Iran, around 8000 BC. While the lithic industries of the Zagros region have been collectively termed Mlefatian, thanks to the great work by Stefan Kozlowski, Mlefatian was obviously not monolithic, but it can be divided to several stages of development. Probably what we found at East Chiasados and now at Abd Hussein as well is the formative period of this distinct industry. In our previous study, we called the lowest phase of East Chiasados as Mlefatian because it lacked typical bullet core technology that is diagnostic of the later Mlefatian. Then the question is why lithic industries made changes in this way in this period. it will be important to understand them in the context of general cultural changes occurring in this period, like the more intensive farming and more intensive settlement occupations, which have actually allowed it to define, as shown in this chronological table, transitional and post-Neolithic phases in this period. Actually, I'm not ready to go further, but I'd like to state that the data from Abdul Hussein is an important addition to our knowledge to demonstrate that lithic industries were also changing in this important period of Neolithization. And this additional data encourages further discussion of the background for these changes. Thank you very much for your attention. And I'd like to thank these people and granting aid for supporting my study.
Thank you very much, Yoshi. That's wonderful. Really, really interesting analysis. I think Hassan has his hand up and has a question.
Yeah, and thank you so much for such a new work and the new chronology. Just my question is that when you will publish your result of new dating, because it's changed everything. So it's good for me to know more about your dating and when you will publish.
I will try to publish it as soon as possible. Actually, I have written much of the manuscript for this paper already. But you know, I'm quite lazy. But the analysis has been already done, both lithics and dating.
Hodja just wanted to say something.
Frank.
Oh, okay. Frank first, please.
Did you say me?
Yes.
This is extremely interesting, Yoshi. I think the comparison between the two sites is wonderful. And it raises an interesting point that I think bears in, compares with what I said on the first day, namely having to do with mobile people and traditions of manufacturing and the conservative aspects of making the stone tools. The site of Abdul Hussein and the site of East Chia Sabs are sort of well on the line of a migratory route, at least the highlands to the lowlands. But I think the comparison between the lithics makes clear that these people, in some sense or other, were in contact, if not actually physically, at least the customs and the habits of chipping flints and the changes through time parallel one another so closely that one has to think in terms of interaction between these two areas.
Mm-hmm.
Thank you, Frank.
Thank you. Well,
okay, Hodja wanted to say something.
Maybe you would like to reply. Okay. You have something to say, or I wanted to say that first of all, I should be very thankful.
Yeah, please go on.
You hear me? Okay, just
Yes.
to adding new chronological dates and making the chronological table of the Central Zagros more accurate. That's great. So, as you might know, concerning East Chia Sabs, we don't have any absolute date, any radiocarbonate from the uppermost 2 meters of the deposit. But based on the other materials, specifically obsidian pieces and object of marble, I think that the site should have occupation at the site, at least in that upper level, should have continued and the second half of the 8th millennium BC. So that would be a little bit younger than what you presented here at the end of occupation or the latest phase of occupation at the site.
If I remember correctly, you dated the top layer of East Geosubs 7000 BC.
Yeah.
Yeah.
Yeah, that is the
estimate from the thickness of the deposits.
Yeah, exactly.
Yeah.
Around 7,000.
Mm-hmm. Yeah, but according to my study of the lithics, those from the top layer do not differ greatly from just the underlying layers dated to 7,600 BC or like that. I don't think the top layer of East Geosubs is dated to such a late period as you suggested.
But we regionally, when we look at the whole region, based on the presence of obsidian pieces and marble specifically, we know that they appeared in the region mostly in the second half, from the middle of the 8th millennium onward. If we look at the other sites, surrounding sites, so this can be more probable to about 2 meters of undated deposits. So that would be, not so unusual actually if we place this within the second half of the 8th millennium BC.
Okay, so that period can be a period of, you see, continuity.
Yes, of course. But in terms of lithic technology, it should have not necessarily, we see a kind of, solid change through the layers, at least in the entire 8th millennium BC. So, yeah, thank you.
Okay. Yoshi, there's a question from Bogdana Milic in the chat. Maybe you want to reply to her there. Do you know? Can you see the chat function? Or unless maybe Bogdana, do you want to ask your question directly? We have a bit of time.
Yes. Well, I will answer to this question through chat.
Okay, as you like. Her internet's bad. Okay, so maybe you can answer it in the chat. Okay, great. Yeah, I was gonna also write a comment, but it's just a thought occurred to me, and I some of the colleagues working on sort of naviform technology in the PPNB of the Levant have suggested that maybe elements of it might be related to specialization, and I was wondering whether we could at some point think about or discuss this also for the Millefathian. I mean, these very regular pressure flakes, pressure flake cores. You know, is there evidence for specialists, so specialization here as well? What are there any thoughts on that from your end or anybody else's, maybe from the lithics side?
Well, so you mean which period? So I talked about technology of the very early Neolithic period.
Yeah.
And they made only, small bladelets, even through pressure technique.
Yeah.
Yeah. So if
the kind of when the bullet cores become
small ones
common. Yeah.
So in the later period, much bigger cores for pressure debitage appeared, and that is the period I think to think about the presence of specialization, which should have differed from the specialization in the early Neolithic.
Yeah, Doug Baird has his hand up.
Hi there. Sorry, I've got two screens. I'm just going to put you right in front of me so I can actually look at you. Yeah, I think it's a really good question. I mean, obviously, particularly more sophisticated modes of pressure production seem extremely likely to be specialized anyway because of the amount of skill, and learning and the efficiency of the production. So it's very interesting to ask about the early stuff. I mean, I sort of touched on this a little bit when I talked about Karam Shahir. the other day, and it's really interesting to me that at Karam Shahir, in the excavated stuff that we had, actually, you know, the evidence for pressure is quite restricted in terms of proportions of cores and pressure bladelets, you know, in what seem to be the early phases there. Most of it is percussion bladelets, although the bladelets and the tools are, you know, very similar in the end. So I do wonder if, you know, a few people at Karam Shahir are the ones that are adopting the pressure techniques, even if they're not the most sophisticated pressure techniques. I suggested, you know, limited stabilization and handheld pressure according to the criteria. So, you know, maybe when it's starting, a few people are adopting it as a mark of artisanship, even if it's not quite the high skill levels of the slightly later pressure. Anyway, that's my response to your question, Tobias, and I think it's well worth looking at a bit more in terms of why pressure's appearing in the first place.
It's similar to the Naviform technology in the Levant, right? I mean, where we have the idea that it may have spread from north to south into the southern Levant as part of kind of, well, some have suggested itinerant craftsmen sort of traveling, so taking account of how it spreads as well.
Yeah, I mean, this, you know, I did some work on the Naviform stuff a while ago, and one of the things that I think that is very interesting there is, again, how variable it can be. You know, so if you look at the Naviform, you know, technology as practiced at somewhere like the Obsidian workshops in, you know, in the central Anatolian sources, I mean, that's amazing levels of skill and precision in production. If you look at it, you know, out in the Eastern Desert, where there are thousands of Naviform cores and it's much less standardized, it sort of looks like every napper is banging off much less precise and shorter Naviform products. So you probably have to look at the context and the, you know, in some measure of quality or skill levels in this, I think, to really disentangle it. And contextually, you know, where's the debris on the site, and how frequent is the different characteristics of the debris. So
yeah. Frank, you're still muted, Frank, sorry.
The technology seems very widespread. The pressure flaking, the gradual changes of the cores to the bullet variety ultimately, but it is so widespread that I'm wondering whether or not we even should think about specialization. It may not be much different from making baskets or making pottery or sewing boots or anything else that people learn to do at home, and some people become quite skilled at it and others don't. But it's not something that is necessarily a sign of advanced art. It's something people learn to do at an early age, and it's very widespread. So I think it's a natural kind of evolution, if we will, but not necessarily one that we need to pin to specialists.
Yeah, I guess there's also discussion to be had of what do we really mean by specialization, whether it's people that are skilled at a certain task and spend more time on doing that versus detached sort of specialized craftsmen, I suppose, which is a different story. Okay, thank you very much again for this really interesting talk. We now move on to the next speaker, which will be Dr. Mohsen Jayes, the epipaleolithic Neolithic component chipped stone assemblage from the Izeh caves and rock shelters in the Khuzestan, Iran. And I think we're doing this one live. Yes, great.
Hello, is my voice and the desktop the more important? Can you see my desktop?
Yes. Yes. Yeah.
Yes. Okay. Going to start in a few seconds. Just a moment. Okay. So hello again, everyone. In the next few moments, I will be talking to you about the caves and rock shelters in the Ize plain of southwestern Iran and their chipped stone assemblages. But before that, I would like to say thanks to the conference organizers from the University of Copenhagen, the Razi University of Kermanshah, and also the Iranian Center for Archaeological Research. I think in the last 3 days and also today, there has been a lot of discussions and interpretations and introductions of sites and characteristics of the Zarzian Epipaleolithic in the Zagros region. So happily, I can skip my introduction and go directly to the Ize region. I just wanted to say that when it comes to the caves and rock shelters, most of the people think that that's Paleolithic. I don't know why is that, because we already have so many transitions from Epipaleolithic to Neolithic in cave sites like in Tangier Bolaghi, in southern Zagros, or even in the caves in southeastern Caspian Sea, which have been discussed these days as well. I just want to say that this speech is about the caves and rock shelters, and it's about Epipaleolithic, but also about the shift to Neolithic in the Ize plain, based on the chipped stone assemblers from caves and rock shelters. Ize plain, as you can see in this map, is located in this southwestern Iran. And look closer, geologically, Ize plain is like a bowl. We call it karstic polye. It means that it is internally drained. The water from the rain and the snow does not go outside the plain. It rather gathers in the central part of the plain in a seasonal lake called Miangaron. Actually, there are two seasonal lakes. One is the Miangaron, and the other one in the southeastern part is Bondun. You can see that it provides a very interesting combination of the mountains around the plain and then the alluvial plain, which has a very productive soil and is used as agricultural lands by local people. And then in the center, there are seasonal lakes, which this combination provides a very extended various resources for people who live here. And the archaeological investigations of the Ize plain starts with Henry Wright in 1970s. Henry Wright visited during a very short period of time Ize plain, and the red lines in this map are those parts visited by Henry Wright. As a result, some caves and rock shelters were introduced. Some of them were Upper Paleolithic, but mostly Epipaleolithic. In his report, Wright does not mention any pre-pottery Neolithic or early Neolithic settlement, and actually he was not looking for them in the caves and rock shelters in the plain. So this is a map with many colors, which I am going to decode for you. It shows recent surveys in the Ize plain. The yellow parts are those parts which have not been resurveyed intensively yet. So here I am presenting to you the results of fieldwork which is not finished yet and needs to be completed. But the other colors, the green part, shows the part of the mountains which have been surveyed in 2008, and the result of which has already been published in 2019 in the Journal of Quaternary International. So I'm not going to speak about this region today, but the red parts and the blue parts are the parts which have been surveyed in 2018 and 2019, and I'm going to speak about the results here in this speech. In this slide and the next ones, I am going to show you some views of the Ize plain, because it's important to see how the alluvial plain intersects and joins the mountainous parts. There is always a very clear line between the mountains and the alluvial land. And this line is the path that we followed during our survey. These are the agricultural lands, and you can see the Bondun seasonal lake in the background. This is Miangaron Lake in winter, and you can see the agricultural lands and the rural settlements, and the picture is taken up from the mountains. You can see the agricultural lands are extended to the last point near the mountains. That's why conducting surveys in the alluvial plain is a little bit difficult, because it has been eroded in many ways. When starting our survey, which has been conducted on foot, and the aim was to record the all-range caves and rock shelters. As you know, in surveying and finding, recording caves and rock shelters, we are mostly faced with chipped stone scatters on their outer slopes. It was important for me to that the chipped stones that we gather from the outer slopes of these caves and rock shelters be reliable statistically. So I adopted a sampling strategy, which I call the controlled way of sampling. This is a strategy based on the density of chipped stones on the outer surface of the caves and rock shelters. And when we were faced with caves and rock shelters which showed density of chipped stones more than 1 per square meters, all the chipped stones observable on the outer slopes were collected by my team. But when we were faced with caves and rock shelters which showed the density more than 1 cultural material per square meter on their outer slopes, if a grid was figured out, and all the chipped stones inside the grid were carefully gathered. Every single cave and rock shelter has been recorded regarding its characteristics, and you can see my team. The plans and the sections have been made from them. This is the survey path of 2018 in the Bondun Lake Basin. 50 kilometers has been surveyed on foot, as a result of which 69 caves and rock shelters have been recorded as archaeological sites. This is the past survey of 2019. Another 50 kilometers has been surveyed on foot in northern and eastern parts of the Ize Plain, as a result of which 59 archaeological sites as caves and rock shelters has been recorded. There has been more than these numbers of caves and rock shelters, but these are the numbers which show those caves and rock shelters with cultural material which could be attributed to prehistoric times. These red circles and their size here indicate the quantity of chipped stones gathered from these sites. So the bigger the circle, it means that the site shows more cultural material. Obviously, I do not have enough here to show you all these caves and rock shelters, so I'm just showing some of them which were more important in my opinion. You can see many of these caves and rock shelters are in the form of clusters of combination of caves and rock shelters, and they show cultural material on their shared outer slopes. In many of these caves and rock shelters, unfortunately, the illegal dig has been made and the cultural layers could be detected in the section of these illegal digs. Many of these caves and rock shelters are still today used as livestock barns or even as residential spaces by local people of the region. So I'm going to go through these pictures quickly, because I want to get to this slide, which shows some statistics and boring numbers. Totally 128 chipped stone assemblages have been collected from these caves and rock shelters. As you can see in this table, 12 of them come from the sites with high density cultural material. And the rest are those with low density cultural material. Totally more than 19,000 chipped stones have been gathered and studied during 2018 and 2019 survey. But the important information is in the lower table. As you can see, almost all these caves and rock shelters, based on the chipped stone material, showed a chronology that comparatively could be attributed to Upper Paleolithic and Epipaleolithic, and I'm going to discuss about the chipped stones in the next slides. But when it comes to the Neolithic, the number drops dramatically. Only 9 caves and rock shelters, actually 8 rock shelters and only 1 cave shows lithic industry which could be attributed to the Neolithic. In this slide and the next one, you can compare the distribution of these Neolithic sites. In the left, you can see the full range sites in 2018 in Bondun Lake Basin. In the right, you can see only 3 of these caves and rock shelters show Neolithic elements in their chipped stones, and you can see their pictures in the upper part. This is from 2019, and in the left, you can see the full range caves and rock shelters, and in the right, you can see only 4 of them, which are not among the major sites with high quantity of chipped stones, show Neolithic elements. In this diagram, I wanted to know if there is any pattern in the elevation of those caves and rock shelters which show Neolithic component. But as you can see, the range of their elevation is not much different from those caves and rock shelters with Upper Paleolithic and Epipaleolithic chipped stone industries. And here are the chipped stones. I have divided the typical chipped stones from ISE assemblages into 4 main categories. The first category are the shared elements. And by shared elements, I mean those typical chipped stones which could not be attributed to either Upper Paleolithic or Epipaleolithic or early Neolithic. And these mainly are conical bladelet cores, as you can see, which are microlithic in dimensions, and they have not been reduced by pressure technique. And also their products, the bladelets from these cores, either retouched or non-retouched, they could not also be attributed to any of these periods with certainty. There are also some tools which are included in shared element. These are notched denticulated flakes and blades, and some tools like borers or very few side scrapers. The second category is the Upper Paleolithic elements based on the well-known assemblages of Baradustian in the Zagros Mountains, or any other name which is known, because these days there are other names as well which are attributed to the Upper Paleolithic of the Zagros. But in all of them, we have carinated elements, carinated scrapers, and as well as carinated burins. And these are from the chipped stone assemblage from ISE plain. And also these tiny, finely retouched bladelets that we call lamel Dufour, and they are also characteristic of the Upper Paleolithic of the Zagros region. And we also have these end scrapers on blades. Although these end scrapers on blades are not exclusive to Upper Paleolithic, but they are mostly reported from Upper Paleolithic types of the region. The third category is the Epipaleolithic elements, which have been discussed in these days in many of the speeches. They include mostly backed bladelets, and we have also the geometrics, but the geometrics in chipped stone assemblages of ISE are few in number and they are not very typical. And actually, ISE assemblage lacks the very typical types like the scaling triangles or what we call the backed and truncated bladelets, which are well known from the Zarzian sites from mostly northern and central part of the Zagros, but in ISE we do not have them. What we do have in the Epipaleolithic of ISE plain, in my opinion, are the thumbnail scrapers. Thumbnail scrapers are the most numerous tool types in ISE-lithic assemblage. And finally, the fourth and the final category are Neolithic elements. These pressure removed cores, or sometimes we call them bullet cores when they are more regular. They have been found from some caves and rock shelters from ISE, which I have already discussed and introduced them in the previous slides. We also have some sickle blades on blade segments, as you can see, but they could be attributed to Neolithic or later periods also. I would like to add one final site to this picture. This is site number 17, and it has been recorded in a sporadic survey conducted in 2007, and it is located in the western part of the plain. This site is exceptional because this is the only single period scatter of chipped stones gathered in ISE plain. It's a rocky mound which lacks cultural layers. As you can see in the vicinity, it's the local cemetery of the Bakhtiari, the local Bakhtiaris of the region. And there's a scatter of chipped stones which are totally attributable to the Neolithic because of the presence of these pressure-removed bladelet cores and bullet cores and their products. The point is that this assemblage shows the utilization of a totally different raw material from those earlier assemblages. And I have already introduced the site and published it in an article in the Journal of Lithic Technology in 2015. And I just wanted to use it here to help me in the conclusion. As I told you, the survey is not finished yet in the ISE plain. So here I'm not going to discuss very big explanation or synthesis. I'm going to talk small and simple. I just want to share some simple pattern that I have observed from Epipaleolithic to Neolithic in the caves and rock shelters of the ISE plain with you. Maybe with your help, your comments and your questions, the picture becomes more clear. What I see is that there are two major changes from Epipaleolithic to Neolithic in ISE plain based on chipped stone industry. The first one shows a shift in occupational pattern. We can see that the number of caves and rock shelters visited or containing Neolithic material drops dramatically, which is not surprising. The second change is in the technological aspects of the chipped stones. Not only the introduction of the pressure-removed bladelets and their products starts from the early Neolithic in the region, but also what is important is that there is a major change also in raw material procurement observed, especially in site number 17, which I showed you in the previous slide. So whether these changes show a local transition, whether it shows that the Neolithic comes from outside the plain, these are the questions that I'm not willing to discuss now or answer them because, as you said, we need the survey to be complete and, of course, the excavations need to be conducted to be able to speak a little bit more clear. And finally, there are a lot of people that I would like to thank, but there's not enough time. So I just say the special thanks goes to the survey crew member of 2018 and 2019. And thank again to the conference organizers. And thank you for listening.
Thank you so much, Dr. Jayas. Really, really interesting material. I think, Frank, you raised your hand there.
Yes, I excuse me. I have to applaud your efforts in doing this survey. It's a wonderful job.
Thank you.
And I think you have an extraordinarily interesting sequence in development there. The ISE plain is clearly a sedimentary basin, as we can see by the presence of the seasonal lakes, but that implies then that you have a lot of colluvium on the valley floor. And it's most likely that Neolithic sites are going to be out on that valley floor, which of course means that they're essentially buried unless you figure out a way to look underground. But one thing that would be very interesting is to have coring done in these sedimentary lakes, these seasonal lakes, and determine something about the colluviation, the burial of sites, and certainly aspects of climate change.
Actually, in 2019, we extracted some sediments from the lakes. But still, we are waiting for the dating to be done, because we need first to know if the dating is the same as the Paleolithic and late Paleolithic occupations. But the extracting of the cores has already been done, and I hope that it continues in the next seasons as well.
Thank you.
Thank you.
Yes, Judith.
Hello, Mosgan. Great to have you here with us, and thank you very much for your wonderful talk. I have just two small questions. The first is, did I understood right that the number of Neolithic artifacts decreased in comparison to the earlier periods? And if so, if this maybe is a shift in the consumption of the artifacts, for example, so that they are not bringing all the artifacts and raw materials and shipping things into the caves, but had their major activity areas somewhere else, not in the cave actually. And the second question is, for your so-called thumbnail scrapers, they seem to me as core tablets more. So are you sure about that they are veritable tools? Thank you.
Regarding the first question, the number of caves and rock shelters that show Neolithic elements drops. I don't know how at the moment, because I said the survey is not complete, and as is needed to look also for the Neolithic sites in the alluvial plain somehow. I just can say that the number drops, and maybe this is a shift in the settlement pattern during the early Neolithic. And regarding the second, I'm sure that they are thumbnail scrapers, because they clearly have been retouched after the detachment of the flake. Because in core tablets, we know that the detachment of those tiny flakes around is actually the removal of the bladelets prior to the removal of the flake of the core tablet. But in thumbnail scrapers, we know that the flake has been removed, and then it has been retouched into a thumbnail scraper. So yes, there are real thumbnail scrapers. I hope there is an opportunity if in the future we meet after the in the post-corona period, I can show them to you in person.
Thank you. I'm coming as soon as possible.
Great, thank you very much. Now we have a slight change in the program. Professor Kozlowski is not able to be with us today because he's apparently prevented, and his talk's recorded. So because we have a cancellation tomorrow, we think we're gonna slot it in tomorrow, so that we can finish a little bit earlier today. So the next talk will therefore be by Saman Haidari Guran and Elham Razidian, Epipaleolithic of the Kermanshah region, Bawa Jawan rock shelter. So I'll pass the word to you.
So, hi everybody. I don't know, my picture and screen is available for you, or my sound also?
We can hear you, and we can just see you, but not your screen at the moment.
Yeah, so I'm going to, okay. So, what about now? Is it fine?
I think it's coming. Yes, we can see the PowerPoint. Yes, perfect. Yeah, great.
Yeah. So thank you very much, Tobias and Hojat, for organizing this conference. It's really great to be among the professional archaeologists. So I'm Saman Haidari Guran. I am employed by Neanderthal Museum in Germany at about 2 years, and I am planning to give the talk about the Epipaleolithic in Baoyawan Rock Shelter in Kermanshah. And this is the first time I talk about the epipaleolithic. Previously, this site has been introduced to the people, to the archaeologists, especially the middle and upper Paleolithic layer. First of all, I would love to thank many people, especially the excavation team, which are in the middle of this screen, and also a couple of other scientists that which are cooperating with this project. Professor Rob Foley and Martha Lark from Cambridge University, and also Stefano Benazzi from Bologna, Tom Hyam and Katarina Duca, and also Sarah Talamo, which are doing the dating for us. So the first picture would be the topic I'm talking about. First of all, I would love to little bit talk about the project of human evolution in the Zagros Mountains. HESM is called actually. And then I will show some pictures of the archaeological surveys, which we have started since 2009. And then selected sites for excavation. Actually, there is two sites have been excavated since 2015. Glemgush Cave is the first one, and the second one is Baoyawan Rock Shelter, which I talk mainly about it, and I talk about coronal stratigraphy of the Baoyawan Rock Shelter, and then epipaleolithic remains in this site, and also the future plan we have. So the aim of this HESM project is, first of all, we would love to know about the earliest occupations, hominin occupations in this region, in central Zagros Mountain, especially in Kermanshah Intermountain Plain. And then, of course, settlement systems and dynamics, transitional events between and biocultural changes, exchanges between middle and upper Paleolithic, and also we are focusing on upper Paleolithic to epipaleolithic transition. Of course, raw material sources studies is part of our project, paleoenvironmental and site protections activities. So since 2009, as I said, we have started for an extensive archaeological survey in Kermanshah region. Kermanshah is more or less in central of West Central Zagros Mountains somehow. And I would love to say this region, the intermountain plain of Kermanshah with almost 5,000 square kilometers is actually the largest intermountain plain of whole Zagros Mountain, from southern, let's say, Turkey, northern Iraqi Kurdistan until Persian Gulf. So this intermountain is really big one. And secondly, as other part of the Zagros Mountains, this region is consisting of different elevations from something like 300 meters above sea level in foothills of Western foothills until the peaks, which are more than 3,300 meters above sea level, which makes this region as a very geo-ecological diverse. During this survey, intensive survey, we have tried to revisit and visit the older discovered sites, including the what does it call, the Kale Davut, which is really great. Frank Cole is here. We have visited that site also, which Frank Cole for the first time found it and made a test trench in this site, and also the other sites like Varvasi, like Kobe Cave, and these sites which already have been known. So during our survey, we could manage to find more than 265 caves and rock shelter. The contract that we had with the Iranian Cultural Heritage and Organization was based on the caves and rock shelter. So we basically focused on this type of sites. And the result of that, as you see down here, has been published in two different journals during last years. So we try to focus on some areas which would help us more about the human occupations, early human occupation during the Pleistocene. So we have used technical geographical and GIS methods. So first of all, we try to make a density analysis, and as you see up there, we have in the red areas, we have quite a lot of sites with more lithic artifacts we have found. So these artifacts are coming from the surface collections. And then later we try to somehow make a spatial distributions of the middle and upper and probably later period. And as you see in the lower, let's say in the D picture, these different colors shows the density of the area, which we do have middle, upper Paleolithic, and sometimes in a very few cases epipaleolithic period. So because of that, we try to came to this valley is called now Darwan Valley. It's around 20 kilometers in the northwest of Kermanshah city, and now Darwan is in Kurdish language means area in a valley surrounded by high mountains, and the river of Razawar actually is running in the middle of this valley. It is a permanent river. So in 2015 we have found one of those sites we started a test trench in it. The site is called Galem Gush Cave. This site with more than 600 square meters is the largest occupational, let's say, cave in whole, maybe Kermanshah province. So far as I know, this is the entrance of that. As you see, it's a very huge site. And unfortunately, some looters, they have dug they made some holes in this area. And then we tried to, first of all, make a stratigraphy and also make a test trench in this area. So all together 4 square meters we have opened. We went down 2 meters and we found 4 geological horizon from 1 to 4, as you see in the section in the left. And the result of this paper, also this work published actually just 2 weeks ago in Journal of Archaeological Science report. If people want to know about the result of that, they can easily go there. So the interesting things about this find is we were able to, first of all, the oldest material came out technotypologically were Upper Paleolithic. So we were able to date this layer, the beneath of that, but still 28 centimeters of the sediments, occupation sediments is below that. So the sample for dating came not exactly on the beneath of the occupation. So the date is 41 and something like 41, close to 42,000 years ago. The dates have been made or carried out in Oxford University by Tom Hyam and Katarina Dukov. And the lithics also are typical Upper Paleolithic lithic. And this is another sample of the lithic artifact. So I am not going to talk about the lithic. And just I would love to say in this side, we have kind of 3 main occupational layer. The first one at the beginning of it is not that much dense, but in the middle of that, something like 36,000 years ago. So we see more population or using of the site has been much more than previously, and then later became less and less. At the end, we have occupation probably, let's say, early Bronze Age, something like that, 5,700 years ago. So even earlier than that. And then on the top of that, so there is no any more occupation in that area. So unfortunately, between Upper Paleolithic and Bronze Age or Middle Holocene Age, we do not have any occupation like Epipaleolithic or something else. So that was Galemgud. And the second site, which is called Bawa Yawan rock shelter, it is right here. In Kurdish language, Bawa means actually is very equivalent to the term of sand. So Bawa Yawan means sand Yawan, I mean in a European or Christian term. So this is a Bawa Yawan rock shelter here, right here in the middle of the valley. So that's a rock. It's not actually a cave or even classic rock shelter. It's a wall of stone, more than 50 meters high. Just in the beneath of that, we have a little bit of cavity, maybe 1 meter or something like that. The wall goes back, and this is the area we have found from the surface. From the survey, we found artifact, so we decided to work here. In the just 50 meters, 70 meters far from the wall, there is a pond, very small lake here. At the moment, a lot of freshwater turtles and also fishes are living here. So people sometimes they come for hunting fishes. And so that's a permanent water very close to the rock shelter. There is a road between Kermanshah and Kamyaran or Sanandaj, goes right close to the side. And during last years, unfortunately, this road has been extended, became Autobahn actually, and a lot of slope sediments, unfortunately, gone by this activity. So that's a map of the site. We see we have, this is the operation area we have conducted in 2016. We started to excavate actually a very small part in this rock shelter, and then 2017 and 2018, we extended our excavation squares like that you see. So we do have two parts. It's called Eastern Trench and Western Trench. Western Trench is much, much bigger, and Eastern Trench is smaller. It's something like 6 square meters, but it's not completely. One of them is under this stone, so it's like 5.5. And this is a three-dimensional model of this rock shelter. You see how far we went down. In the western part, we went in at least in this square, which is called I-32. We went down more than 4 meters. And in the eastern part, we didn't go that much. It's like a 1.5 meter. So this is the work of 3 seasons. But the first season, I have to say, it was very small, like 2 weeks. And then later in 2017 and 18, we worked more than that. So the datum point is 20 meters exactly on the top of one rock here. So this is the excavation. We have tried to screen and wash all the sediments came out of the excavation, and then basically we have catched, let's say, all the even very small finds. This is the stratigraphy of western part. We have 5 geological layers. You see it's here, and all together we were able to sample 13 charcoals for datings. I have to say we have also tried for the charcoals below in this part, in the lower part of geological 5, but unfortunately they were out of range. So I am not talking about that. I will talk about the range. It is under 40-something, 45,000 years old. So in the geological layer 5 and 4, we have found quite a lot of Middle Paleolithic artifacts. As you see, it's a classical Mousterian artifacts. And then later in geological 2, we have found 2 different type of artifacts, the Upper Paleolithic and then Middle Paleolithic. But in the beneath of the geological layer 2, we do still have Middle Paleolithic artifacts. This was the Western Trench, and the lower one is the Eastern Trench. So now, since I am talking about the Epipaleolithic in Eastern Trench, at pretty much top of the layer, we have found Epipaleolithic. So these blue artifacts are Epipaleolithic, but these blue are just the tools, because we were not sure about the cores, we were not sure about the flakes, and since the changes between sediments are pretty much gradual, you cannot actually distinguish between the epi and upper. So that's why we have decided at least try to go to the geometric artifacts and then see where they are, and then you can relate all the other chipped stones close to this, let's say, geometric artifact as Epipaleolithic period. So before I go speak about the epipaleolithic, I would love to share this fantastic find in quite above, pretty much surface of geological layer 5. We were able to find a tooth. Immediately, it was clear to us this is a human tooth. After few hours, I have shared the picture of these tools to my colleagues in Cambridge University, especially Martha Lahr, and she immediately said, this is a human, no doubt about that. And later a study showed this is a Neanderthal remain. So these tools belong to the young Neanderthal. It's a deciduous tooth, so it's a milky tooth, and something like 6 to 9 years old. And so that was a very exciting find in this site. And later I will talk about the date of this site and how old it is. So this is the location of the Baoyawan tooth. It's here. And this is the area from the Bayesian model. It looks like Baoyawan is a very, very young Neanderthal. I mean, compared to the other Neanderthal remain around the world, it's between 41 to 43,000 years old. And then we have a very beautiful sequence of occupation in these sites. We see it after the tooth. We do have, let's take this picture away. Okay, we do have 40,000 and around the middle of layer 2, we do have almost 35,000 years ago. So in Western Trench, which we couldn't find epipaleolithic, we found just the middle paleolithic and upper paleolithic. This is the sequence of chronostratigraphical sequence actually we do have here. And but we fortunately we could find also one charcoal close to the epipaleolithic layer. The blue star is a location of this charcoal we have found, and this area is Eastern Trench. The blue are the geometric artifacts. We could, well, the dates are 13,470, let's say, 13,470. This is a geological horizon in Eastern Trench. We do have geological horizon 3, which we have found one middle paleolithic artifact here. And then we have a bunch of upper paleolithic in this area. And then in between 20 to 47 centimeters, so here, this green line, up there, we do have epipaleolithic layer. But as I said, there is no any changes in sediments. And then just because of the location of the geometric, we are guessing probably this line is the beginning of epipaleolithic. So this is some selection of the epipaleolithic artifacts. These two cores, as you see very clearly, can relate to epipaleolithic, are from the area which we have found geometric artifacts. So I want to show you some statistical number about what we have here. So altogether 6,123 lithic artifacts we found from the all layers, from the lithic artifact from the old period, from middle paleolithic, upper paleolithic, and epipaleolithic. And you see just 224 lithics belong to epipaleolithic period. And then from these 224, 2 pieces are core, 33 tools, and the rest are here. This is the graphs. And from the tools, among these 33, we have 4 owl and also 9 geometric microlith. Actually is the highest number, these tools, which is very interesting. But maybe more interestingly is the number of tools, let's say the percent of tools among these 224, which is very different from the other period, from the middle paleolithic and upper paleolithic. The percent of tools among the upper paleolithic is really high. I mean, I compare it to the different sites. 14% of the old artifacts tools are pretty much high. I don't know why, but we have to look at it and why it's happening like that. So very close to this epipaleolithic layer, this is the Eastern Trench, we do have one bedrock mortar. This is a very simple sketch map of this bedrock mortar. This is something like 1 meter and 80 centimeters higher than the trench. On the wall, you see this guy is there, and it's 5 centimeters deep and around 8 centimeters wide. But the whole area, this area is completely polished. I am not saying this bedrock mortar 100% related to the epipaleolithic, but it might be. If it is, we have to find out somehow, but it's very interesting. If we find some elements which has been applied in this bedrock mortar, if we find it somewhere here, it would be really interesting find. So I would love to a little bit talk about the raw material. Based on this survey we have done in Kermanshah, we could find at least 4 types of very large, let's say large scale raw material sources. One of them, big one, is called reddish fractured chert in mountain area, and the Gakie is very famous one actually in the middle of the valley. Gakie is famous because of the hand axe, has been taught actually by Frank Hall. And then we have a couple of other type of raw materials in this region. So here, based on the survey, based on the excavation we had in these pictures, actually belong to the different period. Just as an example, I brought it here. But this is the type of the raw material we have. But in epipaleolithic layer, in Eastern Trench, in this amount of artifact we have, 37 of the artifacts coming from this area is called Gakies, more than 35 kilometers far from the site. And 12% coming from the Mayvala region, this reddish one, as I said, this type. And also another type is called Galali, which is a typical radiolarite source. Is here just 6% of that coming from that. And then 45% we don't know. It might be from here, but they are not clear from where. But as far we could understood, this is the frequency of the raw material and, let's say, people movement around the landscape. I would love to little bit talk about the animal remain, fauna remain. There is not much different from the lower parts and epipaleolithic period. But very interesting things is we do have large mammals, equida and bovida in lower part, and also we have also same more or less. But the biggest difference, let's say from the middle paleolithic, upper paleolithic, and layer 2, still is not distinguished from upper and epi, but somehow it gives you some information. At least actually in this pretty much top, we do have hare, we do have partridge, and also sheep, goat. But the main things we can be more or less sure about that, the freshwater turtle is quite a lot of them in lower part. But during the upper paleolithic and epipaleolithic is completely absent. So people, they didn't like to eat turtle anymore for some reason. But instead of turtle, they used shells, especially during upper paleolithic. But also in epipaleolithic is absent. So this is at least 2 area we are sure about that. We couldn't find any this type of animals or fauna in upper part, but we see somehow people, they had more interested in a smaller animal in epipaleolithic period. So this is a better picture of the at least geological layer 2. That's a pattern of probably half of them belong to epipaleolithic and half belong to the lower part, which would be upper paleolithic. Unfortunately, as I said, distinguishing between upper and epi in this geological layer is very difficult, but hopefully in the future we can somehow find out about that. Yeah. So I will, as a not last picture, but this is pretty much the last one. Our future work would be next season. We are planning to excavate in this area. This area, as you see, is a little bit higher than the other part. We assume probably we do have epipaleolithic period in this area. So the reason for that would be collecting more samples for dating and also finding out some relationship between this epipaleolithic period and also the bedrock muhtar over there. Also, you see few pieces we do have in Western Trench as well. So it shows a pattern of occupation very close to the wall. So as a conclusion, the first thing would be this extensive surveys in Kermanshah Intermountain area, mostly shelter sites, of course, has produced very little finds from epipaleolithic period. So that would be one issue which we have to think about that, but I believe because most of the epipaleolithic artifacts are much, much smaller and they being eroded or washed away or something happened to them. And then in Baoyawan rock shelter, we do have a very long sequence of occupation from middle Paleolithic to epipaleolithic, which it's very interesting. That shows kind of similar pattern what we do have in Varvasi rock shelter. Actually, the location of the site is very strategic. So apparently people, they have used this site and also Varvasi in the same, let's say, because of same strategy they had. So that's another issue I can talk about it. I mean, from Neanderthal to modern human. So people always say they use the same place as a kill site or as a settlement site. And then another issue would be due to the small number of epipaleolithic tools from Baoyawan, it still is too soon for regional comparison. But so far, the number of geometric tools consistent with a little bit consistent, not 100%, but it's morely close to the upper layer of epipaleolithic in Varvasi rock. So that's our first, let's say, conclusion about the cultural material. And then another thing, this 13,470 years Cal BP for the upper part of, let's say, uppermost part of epipaleolithic of Baoyawan could somehow show the final phase of epipaleolithic in the area. But that's I put 2 question marks there because I am not sure about that. We have to think about it, but maybe one of the very much, let's say, late epipaleolithic in this area. We need to make more samples for dating to see what is going on there. So at the end, I would love to briefly say something about what I think about this late epipaleolithic and early Neolithic transition. Maybe this is a very naive idea. I don't know if it's too much naive. Please correct me, the expertise about Neolithic period. But I have somehow think about we have a problem of, let's call it uppermost, lowermost gap. So if you look at it, here we have 13,000 old epipaleolithic. And then let's say in this tell site, we have, as far as I know, the Chogolan in Zagros Mountain was the oldest. I'm not sure, but please correct me if I'm wrong. It was 11,700. So we do have kind of 1,000, 2,000 year gap in between tell sites and shelter sites. So the question is, why? Where can we find epipaleolithic? Is it a problem of site formation or is a site location problem? What we have to do? Thank you very much for your attention.
Thank you very much, Salman, for your fascinating presentation. So I see that you already open up a very challenging question, actually, for the final discussion, as we have some lithic, epipaleolithic guys who raised their hands out. So let's start from the older generation, Franco, and then to the youngest.
Age before beauty, I guess. I'm interested to see the comparisons in a way between Ize survey and yours, how the sites are occurring along the fringes of the valley. And it raises the same question here. The Kermanshah Valley is, of course, also a sedimentary basin in a way, and it's likely that many of the sites are buried, so that finding the sites, Braidwood used to think that the big change was when people began to move from caves into the outside. And in fact, you may be right. He may be right about that. That the sites that define the earliest the PPNA, the transitional sites, may in fact be out on the plains rather than on the caves and rock shelters. I'm also interested that in the fauna, apparently this sites are not showing onager or red deer, and these were also prevalent in the other earlier sites that have been excavated, both in Kermanshah and in the Khurramabad region. And then finally, the question of water. And I see there are turtles in the lower part and clams in the upper. The clams suggest that there's a fairly decent body of permanent water, and I don't see it in the plain today. Can you explain where they may have been, why they may have been camping in this location, and was water one of the defining factors?
Well, yeah, thank you very much, Frank, for your comments and your questions. If you ask you mean the water was the main reason people they choose this area, I agree. For the first question you had, actually we do have red deer. We do have very few in the lower part. We had in the upper Paleolithic also we had very few. Maybe we had two in the lower part and one in the middle part. So red deer we do have, as we have in other sites like Varvasi in Khurramabad Valley. And yeah, so yeah, I think the choosing of by the way, Varvasi is not close to any permanent water. It is more, as you said, actually, it is more a strategic location. So people, they had control on animals. I think in case of Baba Yewa and Rock Shelter, we do have both. It's a strategic location and also close to the water. I hope I answered you. I don't know. So, Hojat?
You also said that you had equids as well, right?
I had what?
Equids, onager.
Yes.
Okay.
Yeah, in lower part, just one actually. Pretty much lower part, yeah. That was your question?
No, it's just Frank, I think, felt that you didn't say equids, and I was just saying I thought you said you had.
Oh, yeah,
So,
we had one.
Okay, sorry. If Eleni, if you hear me, please ask your question. Sorry, it was a technical issue here.
For a moment, I thought that you would mistake me for the youngest, Hojat, but I'm glad to see you haven't. Your last closing comment, Saman. First of all, I would like to thank you for this very, very comprehensive presentation. Okay, covering a huge time span. You guys have done amazing work. You mentioned the gap or the apparent gap between the beginning of sites like Tsoga Golan and the dates you get from, if I am not wrong, what you call the uppermost Epipaleolithic.
Yeah, I made it up this morning. Actually, I called it uppermost, lowermost gap. Let's say, because this is a pretty much uppermost because of
Okay.
So,
So I mean, this time span actually corresponds almost completely with just before the end of the late glacial climatic warming, okay, and the beginning of what we call the Younger Dryas, the last glacial sort of peak. And Tsoga Golan starts right at the beginning of the Holocene. So what you may have there is something that has to do with the harshness of climate in this part of the central Zagros. I mean, it is not unknown of in central Anatolia and in the central Anatolian plateau, there is similarly a dearth of archaeological evidence relating to this particular period. So this may be the combined effect of more mobile, less archaeologically visible habitation, as well as erosion by deflation of sites and materials. It is a possibility. I just wanted to raise that in case it may answer a bit of,
thank you very much. Also, thanks a lot for saying those words for my work. It is not just me. Many people are involved with this project. But the things is, you're right. I mean, Chogagulan is, as far as I know, it was, I don't remember, 500, 700 meters above sea level. But this side is 1,300 meters above sea level. This is a big change. But, as probably all of us knows, the late glacial maximum between 28,000, 30,000 till 20,000, the Zagros much was colder than younger Dryas, as far as I know. So people still manage somehow to live there. And why they have to leave the area during the short cold period of younger Dryas? So I believe there are somewhere, but I think maybe site formation process, that's my idea. Site formation problem is much more effective, let's say, elements on this issue. But that's really an interesting question. I don't know how can we find this problem, but I hope we find more younger. Hopefully, if we find some more younger dates,
yes, you need to excavate more Paleolithic sites and get many more dates. Maybe
exactly. That's the plan.
Sites.
Yeah, thanks to DIFG, actually now I have money enough to make much more.
Okay, thank you. Just I wanted to make a comment, but first ask Dr. Jayas to go through any comment question.
Okay, thank you, Dr. Darby, and hello. It's nice to see you here. I was hopeful that I could see Elham as well here. This is a comment on the bedrock mortar you showed. I just wanted to say that based on the location that you show, we should be aware that these type of mortars could be totally natural. Robert Bednarik was the expert which in 2008 actually mentioned it, that many of these bedrock mortars, as regular as they seem, when they are located in karstic formations and they are in a location in which there is a probability that the water drops could be coming down during the time, they can be shaped and they could be easily misrecognized with bedrock mortars. I'm not saying that the bedrock mortar you showed is the case, but I just wanted to say this, that there is a probability and also their dating is really challenging, as you know. Just that, I just wanted to say that, and congratulations on the great job.
Thank you very much. I am completely aware of this natural phenomena, these dropping stones in karstic area. You are completely right. We can easily distinguish between them. These are sometimes actually they are pretty much look like bedrock mortar. Yeah, you're right. But since this bedrock mortar location, first of all, as I said, around it, something like 50 centimeters around is completely polished, very clearly polished. It's a human use polish. It's not animal use polish. Yeah. So that's the first thing. And secondly, the roof on the top of this bedrock mortar is so short, it cannot drop off the water, make such a hole in the stone. So that's the thing. So I'm more or less sure about that, but I'm not sure about how old this bedrock mortar would be. I mean, that's the case. But if somehow it's related to the Epipaleolithic or any other period, that would be really good. But thank you very much for your comment.
Thank you for your answer.
Thank you, Roger. If you, okay, here we are.
Thank you, Hojat. Thank you so much, Saman. Really wonderful presentations, and many congratulations on your Neanderthal tooth. You know, it's so rare to have a human or hominin physical remains from Iran or indeed across the Middle East. That's fantastic find. Just back to this problem of the sort of missing connection. I like your uppermost, lowermost terminology. And of course, we can approach that from both directions. As Eleni says, you know, we can excavate more late epipaleolithic sites and hope that we can decrease the gap that way. But we can also excavate sites like Sheikhiyabad, which is really not that far from Bawa Yawan in Kermanshah province, where, you know, our radiocarbon dates go back, depending on how you model them, even into the very end of the Younger Dryas. So, you know, there clearly are people there, and more of these early PPN sites are being found in survey. They're not that easy to find, of course, and they're even more difficult to excavate. But that's the other angle we need to take, and hopefully we can get back to Sheikhiyabad and excavate these extremely early levels at the base of the mound. Thank you.
Yes, yeah. Thank you very much. Yeah, you're right. Yeah, I didn't mention Sheikhiyabad because of time limitation, but it's right behind of the mountains. Actually, I'm working. So I hope really by my heart you come back to the area and work again. We need you, Roger, definitely in Kermanshah. You're welcome.
Okay, just I wanted to say that concerning the Younger Dryas, as I mentioned earlier a few days ago, so we have only a single day, which coincided with this climatic event from Margol-Galan. So, and we're not sure, we're not certain that it was under, I mean, the cave was surely under occupation at that time. But at the same time, as mentioned and illustrated today by Eleni about Palagora, we have another climatic event, Heinrich event. So interestingly, we have a gap in our sequence at Margol-Galan, which is chronologically, looks to be the same time that they have at Palagora. So this is going to be another big question for the future investigation concerning, overlooked period of epipaleolithic, because those people who have been working on the Paleolithic, they just focus on the earlier period, and we have some other guys, they were just focused on the later. So mounded site like Sheikhiyabad and Ganjar, and also in this between, so this around 10,000 years, so now was overlooked up to now mostly. So from now on, we are looking forward eagerly to see further data from different sites, specifically including Zarzi, which is planned to be excavated by Roger, Wendy, and their colleagues in the future, and any other, your site as well, Bawi, Yawan, and other sites, hopefully to be excavated by Dr. Jais, Miza, and some others. Yeah. Okay. Thank you very much. If no more question, comments, so let me close up the today presentation. And so thank you very much again for being with us. So I hope you have a good time. So I hope you enjoyed this today's presentation. So and see you tomorrow at around 9:10 as scheduled. So with some new presentation in the last day, and then big final discussion at the end of the conference about different and various objects that we have been discussing over the last few days. Thank you very much. Bye.